Welcome to Blazor Pages for front-end development. Mastering Blazor is essential for building responsive, scalable web applications. You'll gain the skills to create efficient projects, enhance user experience, and streamline development with Microsoft Copilot. We will begin by introducing the foundational concepts of Blazor, guiding you through creating and configuring Blazor projects. You'll also explore how to run and debug your applications effectively, establishing a solid foundation for your development journey. Then, we'll analyze Blazor components, their lifecycle methods, and how they communicate. You'll identify techniques for creating reusable components and advanced approaches to building dynamic interfaces. Next, you'll examine data binding, event handling, and navigation techniques in Blazor, which are essential for developing interactive applications. You'll also explore state management and best practices for form handling and validation. We'll move on to server-side and client-side rendering, discussing their use cases in Blazor. We will explore hybrid rendering models and key performance considerations for optimizing applications. Finally, you'll use Microsoft Copilot to assist in developing Blazor projects. You'll apply Copilot to write, debug, and optimize Blazor code, culminating in a complete, efficient project. By the end of this course, you'll have the expertise to build responsive, scalable Blazor applications while streamlining your development process with Microsoft Copilot. Let's get started with Blazor Pages for front-end development. Hi, I'm Dr. Sharon Jumper, and I'm excited to be your instructor for this course. My journey into front-end development began when I was a teenager, experimenting with code for fun. I would write simple scripts on computers in big box stores that turned their displays into silly little interactive experiences. After high school, I spent 4 years in the U.S. Army as a signals intelligence analyst, where I deepened my understanding of how computers facilitate global communication. These early experiences shaped my career and fueled my passion for learning. As a lifelong learner, I've adapted my skills to the rapidly changing landscape of technology, applying front-end development principles in my roles as a lawyer, professor, enterprise learning architect, cybersecurity consultant, and entrepreneur. Whether building prototypes or launching full-fledged platforms, the ability to create dynamic, user-friendly interfaces is invaluable in today's digital-first economy. Today, we will explore the core aspects of front-end development, creating engaging, responsive, and accessible web pages that captivate and communicate effectively with users, as well as applications that make their lives and businesses more productive. From designing visually appealing layouts to adding interactivity, you'll gain the skills to craft modern web experiences. Whether you're planning to enhance a personal project, scale a business, or simply learn a new skill, front-end development opens a world of opportunities. And with technologies like Microsoft Copilot assisting you, you'll find the development process smoother and more intuitive. I'm excited to guide you through this journey of learning and discovery. Let's get started.
The learning experience in this course is designed to give you a comprehensive understanding of key concepts through various learning methods. You'll be guided through interactive, engaging materials that help you build practical and theoretical knowledge. Whether you're interested in front-end, back-end, or full-stack development, this program has the tools to support your growth every step of the way. Throughout the course, you'll be introduced to core concepts and key ideas in videos. These videos are designed to help you understand definitions, processes, and essential steps clearly and concisely. You'll get to absorb foundational knowledge, setting the stage for deeper exploration as you move forward. And when you need step-by-step guidance, screencasts will provide you with a detailed practical view. These screencasts will show you exactly what's on the screen and how to work through specific coding tasks. The course also includes readings that reinforce the key ideas presented in the videos. These readings are more than just supplementary material. They're job aids. You can print them out and use them as a reference while working on assignments or activities, helping to apply what you've learned in real-world situations more easily. Small activities are included to help you check your understanding of key ideas. These activities provide quick, interactive opportunities to practice what you've just learned. After completing each activity, you can compare your work with a fully explained example and answer key. This ensures that you always know if your answer is correct. Practical experience doing tasks you would in a job within this field is essential, and that's where guided labs come in. These labs take you through the implementation of different concepts step by step. As you work, you'll receive feedback and helpful hints, ensuring you can get the help you need when you need it. It's the perfect opportunity to practice in a controlled environment while learning by doing. After completing the guided labs, you'll move on to independent projects, or you try it. This is where you'll put your skills to the test, applying what you've learned in the labs. You'll work through real-world problems, cementing your understanding of the course material. The course will culminate in a practical project leveraging Microsoft Copilot that you can use as a portfolio artifact when you begin your job search in this field. As you progress through the program, the portfolio pieces will become stronger and better representations of the authentic experience you've gained. They'll showcase your understanding of code and the ability to implement different concepts from the developer program. This course guides you step by step from understanding concepts through videos and readings to apply them in activities, screencasts, and labs. Each part of the course builds on the last, helping you gain knowledge and authentic experience. By the end, you'll have completed real projects that not only showcase your skills, but can also be included in your portfolio as you start your career. Everything you do here will prepare you for success as a developer. Let's get started.
Throughout this course, you'll complete several guided labs. These labs are meant to give you an opportunity to practice your newly learned skills in an environment where you can get help and feedback as you complete coding challenges. This video will describe how to complete the guided labs in this course. We will explore a guided lab together so that you'll know what to expect when you come to one later in the course. First, let's check the content leading up to a guided lab. This structured content ensures that you have exactly the skills you need to complete the task. In this instance, there is a practical application video that describes in detail how this concept is used in real-world situations. Following this practical application video, you can review a reading that explains the concept in detail so you can go through this content at your own pace. Next, you'll find a video that works through the guided lab itself. This video won't give you all the answers to the guided lab, but it will provide an overview of the upcoming questions and challenges. Lastly, we come to the guided lab itself. The guided lab is a simulated code environment where you can experiment with code and receive hints and feedback in a realistic coding situation. To start, I'll click Start. In this lab, step 1 is an introduction to if-else statements, so I'll click Begin. Below the simulated code environment, I can find the specific instructions for this lab. Declare the variable age as type int. Place your cursor into line 2, type your answer, and select Enter to check your work. Alright, I think I know this one. I'm going to type in INT and hit Enter. Great, I got that correct, and I got a bit of feedback about my correct answer. To move on, I click Continue. And these instructions say, prompt the user to enter their age, place your cursor into line 4, type your answer, and select Enter to check your work. This one is a little trickier. Let me try type your age. Got it. This feedback for my wrong answer points me in the right direction. Let's try that again. I'm going to erase what I had here and then enter your age. Perfect. I'll click Continue. Let's try one more. Convert the input to an integer using int.parse and store it in the age variable. Place your cursor into line 6, type your answer, and select Enter to check your work. I'm not totally sure here, so I'm going to click on Hint and get some help. And the hint says use console.readline, and then an open and close parentheses, display a message asking their user for their age. Great, that helps. I'm going to click Continue and type in console.readline. And I've got it. That's how you work through a guided lab. Some questions will require more complex code to complete, so make sure you're using the hint function when you need it and reviewing the feedback provided for your right and wrong answers. Have fun completing these coding challenges that put your new skills to work.
In today's rapidly evolving tech landscape, artificial intelligence plays a key role in making development more efficient and intelligent. That's where Microsoft Copilot comes in. Microsoft Copilot is a powerful AI-driven tool that can assist developers in writing, optimizing, and debugging code. In this course, you'll leverage Copilot as a thought partner and a code-generating assistant, helping you solve problems, generate code snippets, and enhance your projects. The goal is to provide you with hands-on experience using a tool that real-world developers use to improve their workflow. In the last module of this course, you'll engage in videos, screencasts, guided labs, and independent projects that integrate Copilot. These labs will take you through how to use specific prompts to generate code, optimize solutions, and solve problems. You'll be shown step-by-step how to leverage Copilot's capabilities to strategically approach the final project. During the guided labs, you'll get hands-on experience working with Copilot. These labs are structured to show you how to craft effective prompts and work with Copilot's code generation features. You'll use it to assist in writing code, refining your solutions, and debugging. This practice will prepare you for the independent work you'll do in the final project. After the videos, screencasts, or guided labs, you'll move on to independent activities where you'll take control. Here you'll use Copilot to assist with various aspects of the project. You'll be making strategic decisions, but Copilot will support you by generating code, suggesting optimizations, and helping you troubleshoot. This prepares you to work more independently while still having the power of AI to assist. The final project will combine everything you've learned in the course, and you'll have Copilot as a key tool in your development toolkit. You'll use Copilot to help you generate and refine code as you combine the concepts from earlier lessons. The project is a portfolio-ready artifact showcasing your coding skills and your ability to leverage AI in modern development workflows. To succeed in the final module, actively engage with the guided labs and practice using Microsoft Copilot effectively. The videos and prompts will take you through Copilot and equip you to apply it strategically and independently. By the end of the course, you'll be fully prepared to complete the final project and demonstrate your skills using traditional coding and AI-assisted workflows. Welcome to the course. In this video, we will discuss how you can make the most of each part of the course to set yourself up for success. Whether you watch the videos, complete activities, or work through hands-on labs, each element has been designed to help you master the skills you need to become a confident and capable developer. The first step in every lesson is the videos. You'll be introduced to new concepts, definitions, and key ideas. Watch these carefully and take notes on the important points. The videos provide the foundational knowledge you'll need to build on, so don't skip them. They'll give you the context to understand everything that comes next. After each video, complete the readings. These readings reinforce the key ideas you've just learned and can serve as job aids. I recommend printing out the readings or saving them for quick reference. They'll be extremely helpful when completing activities, working on projects, or just needing a refresher. They're not just supplementary. They help you apply what you've learned to real-world tasks. Throughout the course, you'll find small but impactful activities. These quick exercises allow you to check your understanding of key ideas. Don't rush through them. Take the time to work through these activities thoughtfully. After each, compare answers with the answer key to check how well you understand the material. This is your chance to practice without pressure. At the end of each lesson, you'll encounter practice quizzes. These quizzes are a great way to ensure you fully grasp the concepts from the videos and the readings. Use these as a checkpoint to assess how well you retain the information. If you find yourself struggling, review the videos and readings again. The goal is to build confidence and solidify your understanding before moving forward. When you need to see the material in action, screencasts guide you. These videos show you exactly how to work through certain tasks step by step. If you ever feel stuck or unsure about applying a concept, watch the screencasts and follow along. This hands-on guidance is invaluable for understanding how the code works in real time and applying what you've learned. At the end of each module, there will be graded quizzes. These are an important part of your success as they allow you to demonstrate mastery of the material. These quizzes build on the practice quizzes, and they're a great way to ensure you're ready to move on to more advanced concepts. Treat these quizzes as milestones. Passing them means you're fully prepared for the next challenge. The guided labs are where you'll take the concepts from the lessons and apply them in a controlled, hands-on environment. These labs will take you step by step through tasks, including helpful feedback and hints. The more effort you put into the labs, the more you'll get out of them. It's all about learning by doing, so take your time and ensure you understand each step before moving on. After you've completed the guided labs, it's time to test your skills with independent projects or U-Try-Its. This is where you'll apply everything you've learned without step-by-step instructions. These projects are a great way to gauge how far you've come and to put your knowledge to the test. Don't worry if you feel challenged, that's part of the learning process. By completing these projects, you'll reinforce your skills and build confidence. Finally, at the end of the course, you'll complete a culminating hands-on project that you can use as a portfolio artifact. This project will showcase the skills you've gained throughout the course and give you something tangible to present to potential employers. As you progress through the program, these portfolio pieces will become stronger representations of your hands-on experience and understanding of key concepts. Success in this course comes down to using all the tools available. Watch the videos carefully, engage with the readings, complete the activities and quizzes thoughtfully, and take full advantage of the screencasts, labs, and projects. Each element of this course is designed to help you master the material step by step. By the end, you'll have a solid understanding of the concepts and real projects to prove your skills. Remember to persist, take your time, and you'll be ready for a successful career in development. To consolidate what you've learned in this course, you'll complete a project using Blazor and Microsoft Copilot. By the end of the project, you'll have developed a fully functional app called Eventease, a dynamic web application designed to streamline event management and showcase your front-end development skills. Whether you're building this app to impress potential employers, sharpen your technical expertise, or just creating something impactful, this project is your opportunity to shine. And don't worry, you won't be doing it alone. Microsoft Copilot will be your sidekick, helping you write, debug, and enhance your code every step of the way. In this video, we'll introduce the end of the course project. By the end of the project, you'll have developed a fully functional Blazor-based web app with features like event browsing, registration, and participation tracking. Using Blazor, you'll craft reusable components, enable efficient data binding, and implement state management. Microsoft Copilot will assist you throughout the process, making your workflow smoother and more efficient. Whether you're new to Blazor or have some experience, this project is designed to be approachable and help you build essential development skills. Let's review the details. The goal of the project is to create an app using Blazor for event planning, which will include the following components. You'll create an event card component, a dynamic display of event details like name, date, and location. Your app will have routing functionality to enable seamless navigation between event lists, details, and registration pages. Also, you'll build a registration form, a user-friendly form with validation for signing up for events. Your app will have an attendance tracker too. This will be a feature to monitor and manage event participation. Finally, your app will confirm state management, which is session tracking to ensure a smooth user experience. Throughout the project, you'll use Microsoft Copilot to assist with generating Blazor components and templates, debugging and optimizing code for performance and usability, and implementing advanced features like state management and validation. You'll progress through a series of structured activities, each aligned with lessons you've completed in this course. This project is broken into 3 activities. In Activity 1, you will use Copilot to generate foundational components, like the event card, with dynamic data binding and routing. Then in Activity 2, you'll debug and optimize the application's performance and reliability by resolving issues like input validation errors, routing bugs, and performance bottlenecks. Finally, in Activity 3, you'll expand your app by adding advanced features, including a registration form, state management for user sessions, and an attendance tracker. Each activity builds on the previous one to ensure a structured learning experience. And Copilot will be your guide at every stage, offering real-time suggestions and enhancements. You'll follow a detailed step-by-step instructions, and by the end of the project, you'll have a polished and deployable app that you can proudly showcase in your portfolio. Plus, this app demonstrates your proficiency in using Blazor and leveraging AI tools like Microsoft Copilot. This end-of-course project is your chance to bring your ideas to life and showcase your skills. It should be a challenging but satisfying experience.
Welcome to Setting Up Blazor Projects. This module introduces you to the foundational concepts of Blazor and its core components, guiding you through project setup and development. As you progress, you'll gain practical skills to build and manage dynamic Blazor applications confidently. We will begin by introducing Blazor and its core components, showing how they work together to create dynamic, responsive applications. Then, we will guide you through setting up the development environment, ensuring you're ready to start building Blazor projects efficiently. After that, you'll create your first Blazor project and gain valuable hands-on experience with the platform's key features. Finally, we will explore how to run and debug Blazor applications, helping you troubleshoot issues and ensure your projects run smoothly from start to finish. By the end of this module, you'll have the skills to set up, build, and debug Blazor projects with confidence, laying a strong foundation for creating dynamic web applications. Let's get started with setting up Blazor projects. Are you ready to bring your .NET skills to the web and create powerful, interactive applications without needing to integrate JavaScript? Meet Blazor, Microsoft's framework that lets you build rich, dynamic web apps using the language you may already be familiar with, C#. In this video, we will explain what Blazor is and its purpose in web development. Blazor is a framework that lets you build interactive web applications using C# and .NET. The purpose of Blazor is to help developers build interactive web applications using C# instead of JavaScript. With Blazor, developers can create both the parts of the app that users interact with and the parts that handle data and logic, all using C#. This makes development easier and more efficient because everything is done with the same language and tools. To understand how Blazor can run code in the browser without needing JavaScript, we need to learn about WebAssembly. WebAssembly is a web standard that allows you to run code written in different languages directly and quickly in the browser, like C# in this case. With Blazor, your .NET code is compiled into WebAssembly, allowing it to run in any modern web browser alongside your HTML and CSS. Blazor uses WebAssembly to run .NET code directly in the browser. This means you can use C# for client-side tasks which makes the development process faster and more consistent because you don't need JavaScript. WebAssembly makes your apps faster, more responsive, and more powerful. Now, let's review the two main benefits of using Blazor in web development. The first benefit is that Blazor lets you use C# for both client-side and server-side code, ensuring consistency and reducing development time. Another benefit is that Blazor apps run very quickly thanks to WebAssembly, giving users a smooth and responsive experience. To understand how these concepts work together, let's consider an example of how Blazor can be used in a real project. FitWave is an online platform that offers personalized workout plans, nutrition tracking, and real-time video coaching to its users. It wants to create a highly interactive web app that runs smoothly on both desktop and mobile browsers without requiring users to download a separate mobile app. FitWave decides to use Blazor WebAssembly to achieve this. FitWave needs a solution that combines high performance with the flexibility to work offline, as some users want to use the app while at the gym or outdoors, where internet connectivity might be limited. Additionally, they want to keep development centralized in their existing .NET ecosystem, avoiding the need to maintain a separate JavaScript-based front end. FitWave uses Blazor WebAssembly to create an interactive client-side web app that runs directly in the user's browser. Here's how they leverage it. First, through offline workout tracking, FitWave uses Blazor WebAssembly to enable offline capabilities for workout tracking. When a user logs their sets, reps, or exercises during a gym session, the data is stored locally in the browser using indexed DB. Once the user regains internet access, Blazor syncs the offline data with the server, ensuring that all progress is updated seamlessly in their account. Next, through an interactive dashboard for progress visualization. With Blazor WebAssembly, FitWave can offer users a dashboard with interactive charts and graphs, all rendered directly in the browser. Through dynamic and responsive components, users can visualize their workout history, follow changes in their strength metrics, and track daily nutrition intake. The client-side processing power of WebAssembly makes these interactive elements fast and smooth, providing a great user experience without relying on constant server requests. FitWave can also use Blazor WebAssembly for the application's real-time video coaching feature. FitWave can integrate WebRTC-based video streaming with their Blazor WebAssembly app, allowing users to join live coaching sessions directly through their web browser. The app can leverage .NET libraries to process data for personalized feedback during the session, while Blazor WebAssembly manages the client-side interface, making it easier for coaches to make adjustments during workouts. Blazor WebAssembly can also use shared code for server and client. FitWave's development team can share validation logic and data models between the server and the client. For example, validation rules for inputting weight or exercise details are defined once in C# and reused across the entire platform, reducing duplication and minimizing potential errors. This shared logic speeds up development time and ensures consistency in user input validation across different parts of the app. Finally, Blazor WebAssembly can create a single-page app experience. FitWave can use a Blazor WebAssembly to create a single-page application, or SPA, providing users with a fast and fluid navigation experience. When users move between sections like workout plans and nutrition tracker, Blazor updates the view without needing to refresh the entire page. This makes FitWave's web app feel just as responsive and engaging as a native mobile app, which is key for maintaining user engagement. Now that you have a basic understanding of Blazor, you're ready to start building your own interactive web applications using C# and .NET. Aspiring web developers, are you ready to take your .NET skills to the next level? In this video, we're exploring something that can transform the way you build web apps: Blazor's two powerful hosting models, Blazor Server and Blazor WebAssembly. Choosing the right model can mean the difference between a lightning-fast app and one that can run smoothly even when the internet is down. In this video, we'll differentiate between Blazor Server and Blazor WebAssembly. Blazor, as part of .NET, provides two main hosting models, Blazor Server and Blazor WebAssembly. Both enable you to build rich, interactive web applications using C# instead of JavaScript. But they differ significantly in how they operate, so let's break down each one. First, let's talk about Blazor Server. Blazor Server is a hosting model in which the application's logic and components run on a web server. Whenever a page changes, updates are sent to the client using a real-time connection via SignalR. The app's logic stays on the server while the user interacts with a lightweight version of the app in their browser. This means that the app can load quickly, but it needs constant connection to the server to keep working. This model is ideal for scenarios where a quick initial load is important, as the client doesn't need to download the entire app to start using it. Now that we've covered Blazor Server, let's shift our focus to Blazor WebAssembly, which operates in a completely different way. Unlike Blazor Server, Blazor WebAssembly runs the application directly in the user's browser using WebAssembly. It is a hosting model that downloads the app's code and runs it using a technology called WebAssembly, allowing the app to work even if the user's internet connection is slow or goes offline temporarily. This makes it great for apps that need to work without always being connected to the internet. Here are a few advantages of Blazor Server. Faster initial load. Because the app doesn't have to download everything to the client, it loads very quickly, even on slower connections. Centralized logic. Since the app logic stays on the server, it's easier to control and secure. Supports older browsers. Since the processing happens on the server, it can support older browsers that might struggle with more complex client-side apps. So when should you use Blazor Server? Blazor Server is ideal for applications where real-time updates are important, such as dashboards or collaborative tools. Here are a few advantages of Blazor WebAssembly. Offline capability. Since the app is downloaded to the client, it can run offline or with intermittent connectivity. Client-side performance. Once loaded, the app can provide a highly responsive experience because it runs directly in the browser. No server dependency. You can host the app as a static site on any web server or content delivery network, CDN, which can be simpler and cheaper to deploy. Blazor WebAssembly is great for apps that need to work offline or have lower latency after the initial load, like productivity tools or e-commerce sites. Now that you understand the benefits of each one, it's time to explore when Blazor Server or Blazor WebAssembly is the right choice for your project. We will start by examining some use cases for Blazor Server. Blazor Server is best for real-time applications that need quick updates, like systems where changes must happen immediately to function effectively. For example, in monitoring systems or collaborative platforms like project management dashboards or stock trading apps, users rely on the app to update instantly as new data comes in. Blazor Server ensures these updates happen in real time without requiring users to refresh their browsers. Another key benefit is that Blazor Server handles secure server-side data. Since all data processing occurs on the server, sensitive information such as financial or medical records stays protected. Blazor Server is the best choice for applications where security is a top priority, like healthcare systems or financial dashboards, because the data never resides on the user's device. It's securely processed and stored on the server. Lastly, Blazor Server is great for apps that need to minimize client-side memory usage. By shifting most of the processing to the server, Blazor Server reduces the demand on the user's device, making it a good choice for applications that need to perform well on lower-powered devices or in environments with limited system resources. For instance, a data analysis tool handling large data sets would benefit from Blazor Server, as the heavy processing is done on the server, reducing memory and processing load on the user's device. Now, let's examine some use cases where Blazor WebAssembly is the better option. Blazor WebAssembly is ideal for apps that need to work offline. For example, a task management app or fitness tracker can be used by users without a constant internet connection, and any updates can sync once the connection is restored. It's also a great choice for client-heavy apps requiring local data processing, such as image or file manipulation tools. These apps work faster when the processing is done on the user's device instead of sending data back and forth to the server. Lastly, Blazor WebAssembly can help reduce hosting costs because it doesn't rely on server-side infrastructure to handle most of the app's logic. This is particularly beneficial for large-scale consumer-facing apps where minimizing server usage can lead to significant cost savings. To summarize, Blazor Server runs your app on the server with minimal client-side processing, making it perfect for applications that need quick initial loading and server-side control. On the other hand, Blazor WebAssembly allows your app to run in the client's browser, offering offline capabilities and reduced server load after the app is downloaded. Choosing the right model depends on your app's needs. If real-time interactions and centralized data management are key, go with Blazor Server. But if you want a standalone, offline-capable app with a rich user experience, Blazor WebAssembly might be the better fit. Now that you know the difference between Blazor Server and Blazor WebAssembly, you're ready to make an informed decision for your next web project. Experiment with both models and decide which one suits your needs best. Have you ever wished building a web application could be simpler, faster, and more intuitive? Blazor may be the framework for your next development project. It lets you create dynamic web apps without switching back and forth between JavaScript and .NET. In this video, we'll identify the key features of Blazor. To understand how Blazor makes development simpler, let's begin by discussing component-based architecture. A user interface, or UI, is the set of visual elements, like buttons and icons, that enable interaction between the user and a digital device or product. Components are the building blocks of the user interface, and they are used to make complex applications easier to manage by breaking them into smaller parts. Each component can define its own properties, methods, and events, allowing for interactive and dynamic web pages. Components render their HTML based on the data they receive, and when that data changes, they automatically re-render, keeping their user interface, or UI, in sync with the application's state. Blazor is built using components, which are reusable building blocks that manage both the user interface and logic. The user interface is what the users interact with, while the logic is the code that controls it. Separating the user interface and logic makes it easier to update or reuse different parts of the app without affecting other sections. For example, in an online store called QuickMart, you can create a component for the shopping cart to handle adding and removing items. This shopping cart component can be reused throughout the site, like on the product page and checkout. Now that you understand how components make apps modular and reusable, let's move on to two-way data binding, which helps keep your user interface, UI, and data synchronized. With components defined, we need a way to keep the user data and the interface connected smoothly, which is where two-way data binding comes in. Data binding is a mechanism that synchronizes data between the user interface and the underlying application logic, so changes in one reflect in the other automatically. It allows developers to easily connect UI elements like text inputs to data models or variables in their C# code, ensuring that when the data changes, the UI updates automatically, and vice versa. Two-way data binding is a feature that synchronizes data between the user interface, UI, and the underlying data model in both directions. This means that changes made in the UI are automatically reflected in the data model, and changes in the data model are automatically reflected in the UI. This is especially useful in forms or interactive components where user input needs to be captured and processed in real time. Let's examine how data binding is used in Blazor. For instance, in QuickMart, when a user types their shipping address, the data model updates in real time, so it's ready for checkout without extra steps. With two-way data binding making user interactions simpler, Blazor integrates seamlessly with .NET libraries to further improve productivity. A library is a collection of ready-made code that helps developers avoid writing everything from scratch. Blazor integrates with .NET libraries, which are collections of pre-built code for common tasks, like accessing databases or managing authentication. This allows you to use existing solutions instead of creating everything yourself. For example, in QuickMart, you could use Entity Framework to manage product inventory and customer data efficiently without writing complex database code yourself. Now that we've covered these key features, let's examine how they all work together to streamline development. First, component-based architecture allows for the reuse of app parts, saving time and minimizing the chance of errors. Next, two-way data binding ensures that your user interface and data stay in sync automatically, eliminating the need for repetitive manual coding. Finally, integration with .NET libraries enables using existing tools such as authentication, simplifying tasks, and cutting down on development time and effort. Together, these features make Blazor efficient and productive. Blazor's key features, component-based architecture, two-way data binding, and .NET integration, streamline web development. These tools reduce complexity, helping you deliver great user experiences more efficiently. It can be a challenge to build interactive, modern web applications without using complex JavaScript frameworks. Blazor enables developers to create full-featured web apps using C# and .NET. This framework simplifies the development process and makes projects more efficient and maintainable. In this video, we'll describe the tools and software required to create a Blazor project. Let's begin by discussing the benefits and key features of Visual Studio Code and .NET SDK, the main tools that you need to get started with Blazor. Visual Studio Code is a popular free code editor developed by Microsoft, known for its flexibility and extensive features. It's designed to be lightweight, fast, and extendable. Whether you're working on web development, mobile apps, cloud applications, or any other coding projects, VS Code provides a rich set of tools to help you write, test, and debug your code. There are several reasons for using Visual Studio Code. With Visual Studio Code, you can write, debug, and manage your Blazor applications all within one editor. Since it does not have a built-in project management system like Visual Studio's solutions and workloads, you will manage your code as folders and use the terminal to create, build, and run applications. This setup gives you the flexibility to keep your environment lightweight and only install the features you need. Let's examine some of the key features of Visual Studio Code, or VS Code. VS Code has two tools that are tremendously helpful to developers when it comes to code writing and editing: IntelliSense and Copilot. IntelliSense in Visual Studio Code provides real-time code suggestions, auto-completion, and error checking based on the current language syntax. It helps streamline coding by offering method suggestions, parameter info, and quick fixes as you type. GitHub Copilot, on the other hand, is an AI-powered tool that generates entire code snippets, functions, and solutions based on plain language comments and context. It assists with writing and editing more complex code by learning from vast public code repositories to provide relevant suggestions for various coding tasks. Both tools enhance productivity by speeding up code writing and reducing errors. VS Code comes with built-in Git support, which means you can manage your version control directly from the editor without switching to the terminal or another Git client. You can stage changes, commit, push, and pull updates to and from your Git repository directly in the editor. Diff and merge tools permit you to view changes between file versions, compare branches, and resolve merge conflicts within the editor. One of the best features of VS Code is its extensibility. You can customize it to fit your development needs by installing extensions from the marketplace. Language extensions add support for programming languages like Python, Java, Go, and more. Framework extensions. Install these extensions for popular frameworks like React, Angular, Blazor, Django, and others. Tools and utilities integrate tools for testing, linting, debugging, and containerization, like Docker, directly into VS Code. There are thousands of extensions available, so you can tailor your development environment exactly how you want it. VS Code has a built-in terminal that allows you to execute commands directly within the editor. Whether you're running shell scripts, installing dependencies, or managing your project's build process, you can do it all without leaving the IDE. Multiple terminals. You can open multiple terminals and run different processes simultaneously. Shell options. The terminal supports Bash, PowerShell, and other shells depending on your operating system. VS Code has robust debugging tools built in, making it easy to troubleshoot and test your code. You can set breakpoints in your code, step through it line by line, and watch how variables change in real time. The debug console allows you to view output, errors, and logs, and interact with your application as it runs. VS Code supports debuggers for JavaScript, Python, C#, and many other languages via extensions. VS Code works on Windows, Mac OS, and Linux, providing a consistent experience no matter which platform you prefer. One of the standout features of VS Code is its Live Share extension. This allows you to collaborate with other developers in real time. You can share your workspace, files, and even debugging sessions with teammates, all without leaving your editor. Live Share makes it easy for you to code together, even when working remotely. You can share terminals and even allow collaborators to set breakpoints and debug your code with you. With VS Code, you can use predefined code snippets or create your own to speed up repetitive tasks. Snippets are shortcuts for commonly used code patterns, and you can trigger them using simple keywords. Built-in refactoring tools allow you to rename variables, extract methods, and automatically clean up your code. Now, let's review the .NET SDK, which is the next tool you will need to create a Blazor project. The .NET SDK, Software Development Kit, is a collection of tools, libraries, and resources that developers use to build, run, and manage applications using the .NET platform. It provides everything needed to create applications, including compilers, frameworks, runtime environments, and command line tools. There are many reasons why developers choose to use .NET SDK. First, the .NET SDK relies on Command Line Interface, CLI, for many tasks. It includes compilers for multiple programming languages such as C#, F#, and Visual Basic, allowing developers to write and compile code into executable applications. The SDK comes with the .NET runtime, which is responsible for executing the compiled application. It ensures that your .NET applications can run across various operating systems, such as Windows, Mac OS, and Linux. The SDK includes libraries and frameworks that provide pre-built functionality for common tasks, such as handling file I/O, network communication, security, and database access. These libraries form the .NET Standard or .NET Core-based libraries, which can be reused in multiple types of applications. The .NET CLI, Command Line Interface, is a powerful tool provided by the SDK that allows developers to perform various tasks such as creating new projects, running applications, building and packaging solutions, and managing dependencies entirely from the terminal in Visual Studio Code. The SDK comes with a set of command line templates for different types of projects, such as console apps, web applications, ASP.NET, mobile apps like Xamarin, and Blazor apps. These templates help developers quickly set up projects with all the necessary files and configurations. The SDK integrates with NuGet, a package manager for .NET. In Visual Studio Code, developers use the command line to manage dependencies. This allows them to easily download and integrate third-party libraries or tools into their project using CLI commands. With the .NET SDK and Visual Studio Code, you can develop applications that run on multiple platforms, including Windows, Mac OS, and Linux. This makes it versatile for developers who need cross-platform capabilities. The .NET SDK supports multiple frameworks for various types of development. ASP.NET Core for building web applications and APIs. Blazor for building interactive web apps using C#. Xamarin for creating mobile apps. Windows Forms and WPF for desktop applications on Windows. Let's examine some of the key features of .NET SDK. The SDK provides the tools to compile and build .NET applications through the terminal, creating executable programs that can be run on different platforms. The command line support for package management, NuGet, allows developers to efficiently manage libraries and frameworks used in their project directly from the integrated terminal in Visual Studio Code. With the SDK, developers can create applications that run on multiple operating systems, including Windows, Mac OS, and Linux, without needing platform-specific tools. The SDK relies on predefined templates accessed through the .NET CLI to help developers quickly set up projects, making the initial setup fast and efficient. Lastly, the SDK includes the .NET runtime, ensuring applications can run both locally and in production environments. Now that you know a bit about the tools we will be using, let's go through the process of installing them, beginning with Visual Studio Code. Start by heading to the Visual Studio Code website, https://code.visualstudio.com. Once there, download the appropriate version for your operating system. It's free and contains everything we need for Blazor development. Next, you'll need to install the .NET Software Development Kit, SDK, which allows you to develop applications using the .NET platform. Head over to the .NET website at .NET.Microsoft.com and download the latest stable version of the .NET SDK. After downloading, install the SDK by following the on-screen instructions. The .NET SDK will enable you to create and run Blazor applications and other .NET projects. To make sure you can create Blazor projects, next you'll need to install the Blazor templates. Blazor templates are pre-built project setups that give you a head start when creating web applications using Blazor, a framework for building interactive web apps with C# instead of JavaScript. These templates provide the basic structure of a Blazor application, whether it runs on the server, Blazor server, or in the browser using WebAssembly, Blazor WebAssembly. They come with all the necessary files and configurations, so you don't have to build everything from scratch. Blazor templates are pre-built structures that provide the basic code to help you start a new Blazor application quickly. Here's how to install Blazor templates. First, you must open a terminal or command prompt. To do this on Mac OS, you can open the terminal by pressing Command and spacebar and typing terminal. Or on Windows, search for command prompt in the Start menu. Next, in the terminal or command prompt, type this command and press Enter. This command installs both Blazor WebAssembly and Blazor Server templates, so you're ready to create any type of Blazor project you want. Once the installation is done, you can check if the templates are available by typing this command. This will display information about the Blazor WebAssembly template, confirming that it has been installed successfully. So, to get started with Blazor, your checklist has 3 items: Install Visual Studio Code for writing and debugging code. Install .NET SDK to provide all the tools and libraries for building Blazor projects. Ensure that Blazor templates are available and add extensions for development. In this lesson, we covered the essential prerequisites for creating a Blazor project. You learned about the tools and software needed, including Visual Studio Code and the .NET SDK, as well as how to install Blazor templates. With these foundational elements in place, you're now equipped to set up your development environment and start building powerful web applications with Blazor. Using Blazor, you can build powerful interactive apps without needing to switch between multiple technologies. Building a web app that works seamlessly on both the server and the client using just this one language can streamline the development process, reduce overhead, and create more cohesive and maintainable applications. In this video, we will demonstrate the step-by-step process to create a new Blazor project using Visual Studio Code. Let's start by setting up Visual Studio Code, the tool we use to build and run our Blazor project. First, open Visual Studio Code. In the Extensions panel, search for C# and install the C# Dev Kit extension. This will allow Visual Studio Code to understand and work with C# code, just like adding a plugin to ensure your code editor can process C#. Now that Visual Studio Code is ready, let's ensure that you have the .NET SDK installed, which Blazor needs to run. The terminal is a tool in Visual Studio Code that allows you to type commands directly into your system. To open it, in Visual Studio Code, click on Terminal at the top menu and select New Terminal. Type .NET -- version to check if the .NET SDK is installed. If it's not, download it from the .NET website at .NET.Microsoft.com/en/download/visual-studio-SDKs. The .NET SDK is like having the right tools in your toolbox. Without it, you wouldn't be able to build or run your project. With Visual Studio Code and the .NET SDK set up, you're ready to create a new Blazor project. Let's go through that process now. In the terminal, type .NET space new space Blazor server space -o space my Blazor app for Blazor server, or .NET space new space Blazor WASM space -o space my Blazor app for Blazor WebAssembly. If you're not sure which to choose, Blazor WebAssembly is a good starting point because it runs directly in the browser without constantly communicating with the server. Later on, for more advanced apps, like a live chat or a real-time dashboard, you might choose Blazor Server. It's like using an app that works offline versus one that always needs to be connected. Click Allow to create the new project. Next, in the terminal, type .NET space new -- list. Blazor Server runs your app on the server and sends updates to the client. It's great for apps that need real-time updates, such as a stock market app where prices change frequently. Blazor WebAssembly runs the app in the browser without needing a server for most tasks. You can select the template from the list here. For this example, let's choose the Blazor WebAssembly standalone app, Blazor WASM. After choosing a template, the next step is to name your project and get it set up. Let's name this example Groove Eco Blazor, so it's easy to find in your workspace. Naming your project is like labeling a folder. It helps keep everything organized. Type the command displayed into the terminal to set up and name your project. To verify that your project was created, go to the Welcome page on Visual Studio Code and click Open. Your projects folder should appear. Now that your project is created and named, let's run it and examine how it works in your browser. Navigate to your project folder by typing cd space my Blazor app in the terminal. Then type .NET space run to compile and launch the app. When you run this command, it builds your code and turns it into an app that can run on your machine. A URL like http:// localhost 5000 will appear. Localhost refers to your computer acting as a server while you're testing the app. Open this URL in your browser and you'll be able to interact with your Blazor app as if it were live online, but it's actually running on your computer. With just a few steps, you've created and run a functional Blazor app ready to build on. Imagine what you could create next: a portfolio project, a dynamic web app, or even the next big idea, all from this starting point. Developers often face the challenge of building highly interactive, robust web applications that can deliver a seamless experience across platforms. However, achieving this often requires managing multiple languages and frameworks, which can be complex and time-consuming. This is where Blazor comes in. By allowing developers to build web applications with C# and .NET, Blazor simplifies the development process, making projects more efficient and collaborative while reducing reliance on JavaScript. In this video, we will explain the initial setup required for a new Blazor project. Before we proceed with this setup, let's quickly cover Blazor. Blazor is a framework for building interactive web applications using C# and .NET. Blazor is a great choice if you want to create robust, full-featured web applications without writing JavaScript. Before we begin creating our Blazor project, we need to make sure our development environment is ready. You'll need Visual Studio Code and .NET SDK. Ensure that the latest version of each tool is downloaded and installed on your computer. With these tools ready, we're all set to begin. Next, let's create our Blazor project in Visual Studio Code. First, open Visual Studio Code. Once Visual Studio Code is open the integrated terminal by selecting Terminal, then New Terminal from the top menu. In the terminal, type the following command to create a new Blazor WebAssembly project: .NET space new space Blazor WASM space -o space my Blazor app. This command tells the .NET SDK to create a new Blazor WebAssembly project in a folder called My Blazor app. After the project is created, navigate to the folder where the project is located and double-click on it to open it in VS Code. Now that your project is open in Visual Studio Code, let's explore the solution structure. This is the basic layout of your Blazor project, and it's important to understand what each part does. Now, let's examine what's been created by viewing the Explorer window. From the top menu, select View, then Explorer. Click Open Folder in the left column to discover the solution structure. The solution structure is the basic layout of your Blazor project, and it's important to understand what each part does. First, find the Pages folder and click on it to expand its contents. This folder contains .razor files, which represent the main components of your Blazor app, like the home page or contact page. Next, click on the www.root folder. This is the public folder for static files like images, CSS, and JavaScript. Everything in this folder is accessible to users visiting your website. The program.cs file is the starting point for your Blazor app. It configures services and middleware and runs the application. Next, let's set up the development environment to ensure everything works smoothly. This includes installing the necessary .NET SDK and extensions to enable proper development with Blazor in the Visual Studio Code. In the Visual Studio toolbar, click on the Build menu and select Build Solution. To enable Blazor development in Visual Studio Code, you'll need the C# extension. Go to the Extensions tab on the left-hand side, search for C# and install the extension from Microsoft. In the integrated terminal, run the following command to restore any necessary dependencies: .NET space restore. To verify that the .NET SDK is properly installed, run the following command in your terminal: .NET space -- version. And there you have it. your first Blazor project is set up and ready to be fully built. Well done! You've completed the initial setup of your Blazor project, explored the solution structure, and run your first Blazor application. From here, you can start adding pages, components, and functionality to build a fully interactive web application. Keep exploring the Blazor framework and its capabilities. There's so much more you can create. Ever wondered what it takes to unlock the full potential of your Blazor project? It all starts with the project configuration file, the hidden powerhouse behind how your application performs, scales, and integrates. In this video, we will describe how to access and modify project settings in a Blazor project. Whether you're tuning performance, managing dependencies, or prepping for deployment, this video will give you the skills to build a Blazor application that stands out. The .csproj file, short for C# project file, contains important settings that define how your Blazor project is built and run. This file manages things like dependencies, build configurations, target frameworks, and more. Whenever you need to tweak certain project behaviors, you'll likely find the answer in this file. Let's locate this file first. In Visual Studio Code, open your Blazor project folder and search for the file with the .csproj extension in the project's root directory. Click on it to open the file. Once you open the .csproj file, you'll notice it's written in XML format. This may seem a little intimidating at first, but don't worry, we'll break it down. Let's start by examining a few key sections of the file. The project tag defines the root element. The property group tag contains build settings like the target framework. The item group tag defines package references and other dependencies. Now let's modify some default settings in the .csproj file. For example, you may want to change the target framework for your project. To do this, locate the target framework element inside the property group tag. Request that Copilot modify the line as needed. For this example, I am changing the target framework from Net 7.0 to Net 6.0. Click Accept once Copilot makes the edit, then click File from the top banner, and then click Save. Next, let's customize some additional project properties. For instance, we might want to change the output type or the root namespace for the project. To do this, ask Copilot to add the following lines inside the property group. Output type, exe, close output type. Root namespace, my Blazor app, close root namespace. This defines the type of project output with the default namespace for your Blazor project. Another important part of the csproj file is the item group tag, where you manage your project dependencies. For instance, if you want to add a new NuGet package to your Blazor project, you can do this by adding a package reference tag inside the item group section. Here's an example of adding the newtonsoft.json package. Item group, package reference include equal, open quote, newtonsoft.json, close quote, version equals, open quote, 13.0.1, close quote, backslash, tag item group. After you save the .csproj file, Visual Studio Code will download and include the specified package in your project. Great job! In this lesson, you've learned how to access and modify project settings in a Blazor project using the .csproj file. We covered adjusting the target framework, customizing application properties, and adding dependencies. These skills are essential for configuring your Blazor project exactly how you need it.
Managing dependencies effectively keeps your Blazor application secure and performing well. When you're writing a Blazor application, you can install a variety of libraries that can assist your development efforts. Microsoft has developed many libraries, and third parties have created many more. These libraries speed up development and use the shared knowledge of the Blazor development community. In this video, we'll demonstrate how to manage various types of dependencies in a Blazor project using VS Code. To begin, we have our Blazor application open. This is just a Blazor application we built off of the template. And to check the dependencies we currently have installed, we can click on the CS proj file, which is a project file for our application. And you'll notice there's a section called Item Group. Item Group contains all the package references that we have available for our project. You can see here we have 3. And the package reference tags not only indicate which packages are installed, but the specific version that we have installed for this project. Now we'll add a package to our project. I'm going to use the terminal. You can see I have a terminal window open here, and I'm going to use the terminal to install the package. You can also add a reference directly to the CS proj file, but we'll do that in a moment. I'm going to start by using the terminal since that's the more common way to install packages. I'm going to use the command .NET add package. And this command will actually go out to a catalog that Microsoft maintains, and we'll look for the package called newtonsoft.json. I'm also specifying a tag that indicates the version we want to install. I'm using this command, and it will install this package for us. It prevents us from having to go to the internet and look up the package on our own and install it manually. Run this command. You can see it's going out to the internet, and it pulls in the files that it needs and installs it for us. And you can also see in our CS proj file, we now have a reference to newtonsoft.json, and it's the specific version we asked the .NET command to install for us. We can also install the package or have a reference to the package in the CS proj file itself. So I can edit this file directly and install the package that way. You can see we get IntelliSense as I'm typing, so I can tab over and it will fill the items in for me. It will even give me some options on which packages to install if I wanted to. So using this approach, we can also install the package if we know the name and the version without having to use the terminal or NuGet. But NuGet and the terminal are the accepted and common ways to install packages, and it just makes it a lot easier instead of having to type everything in. Using the terminal, we can also list all the packages that we have installed. I'm going to clear the screen here so that it's a little easier to read. We can use the command .NET list package and tell the command to give us all the packages that are outdated. Now we only have 4 packages installed, but let's see what this command tells us about those packages. And it's telling us that every package we have has a newer version. And you can see the version we requested, what it resolved to, and then the latest version number that's available. So what this is doing is it's checking the version we currently have installed, and then it's going out to the catalog and attempting to figure out what is the latest version in the catalog, compares that with our version, and lets us know what the latest version is. If we wanted to install the latest version, we can use the .NET add package command again and just tell it to give us the latest version that's available. Sometimes we have to deal with package conflicts. A package conflict is where you have one package that is dependent on another package, and sometimes one package has to use a specific version of another package. And you can use the terminal and this package system to discover which packages are out of date. I'm going to install another JSON library. This is a system level JSON library that's a part of the .NET framework. And it's called system.text.json, and I'm going to install specifically version 6.0.0. So we'll install this package first. So we have that package installed now, and you can see a reference to it in our CS proj file, and we're ready to go with version 6. But now I realize that I need another package called SignalR protocol that uses SignalR to process JSON files. So I'm going to install that next, and I'm going to install version 7 of that package. So I'll run through the setup process for this one. Okay, we have our packages installed. We've got the system.text.json, version 6 of that, and we have the signalr.protocols.json package installed, version 7 of that. Now let's see what happens when we try to build this project. I know that there's going to be a conflict because the signal R package depends on a newer version of the text.json package. You can see that in this output that we have an error. For example, the middle error there, it says that Microsoft extension.configuration.json 8.0.0 is dependent on system.text.json that is greater than or equal to 8.0.0. We've installed system.text.json versus 6.0.0, so that dependency isn't met. We have a conflict and the project will not build. Now let's suppose we don't want to use signalr.protocols.json. So now we want to remove dependencies. Let's suppose we want to remove the system.text.json package because we already have, we're already using Newtonsoft. So I can use the .NET remove command to remove the package. So I'll say .NET remove package, and then I give it the name, system.text.json. And then it'll look for that package in our dependency list and remove it from the reference. And I can do that with any of the packages in our list. We can also restore packages to figure out like if there's something that we want to retain that the project needs. And that's just using the .NET restore command. And it will go through our project and make sure that all the dependencies are met. If there's any dependencies that the project needs, it will go out to the catalog, find those dependencies, and install them for us. So it tells us that we don't have any dependencies that we need to restore, so this project is good to go. Finally, we can use the package manager to determine if we have any packages that are vulnerable, that have any known security flaws. And we're going to use the .NET list package command to determine if there's anything we need to update. When we find a vulnerable package, obviously it's the best practice to update that package so that there's no security holes in our application. So I'm going to use the .NET list package and use the -- vulnerable flag to get a list of those projects. You'll notice that it returns system.text.regular expressions. Version 3 has a security flaw that needs to be resolved. You can look up the advisory here, and if you click on that link, it'll take you to what the problem is with that package. And then we can install the latest version of that package to hopefully resolve that dependency and make sure that we have the latest secure version of that package. In this screencast, we explored comprehensive dependency management in Blazor applications using VS Code. We covered adding and updating NuGet packages through the CLI, that's the terminal, and maintaining security through built-in tools. Remember that effective dependency management is key to maintaining a stable and secure application.
Managing different configurations for various environments like development, staging, and production is a critical task in modern applications. In this video, we'll explain how to use appsettings.json for configuration management. Let's start by learning what appsettings.json is and how it stores these settings. Appsettings.json is a file in .NET used to store configuration settings as key value pairs. A key value pair is a simple structure where the key, like logging, identifies the setting, and the value, like debug, defines the setting's behavior. This separation allows teams to tailor configurations for different environments, such as development or production, without touching the core code. At its core, appsettings.json serves as a central place for managing settings externally from the codebase, making it easier to update configurations without redeploying the application. In this example, the logging key contains nested configurations where the log level key specifies different logging levels. The key allowed host has a value of *, meaning it allows requests from any host. Now, let's explore how we can store and manage these settings in appsettings.json. Settings in appsettings.json are stored as key value pairs. Let's add a new configuration like an API URL for a delivery app. Type in the following: squiggly bracket, open quotation, API settings, close quotation, colon, open squiggly bracket, open quote, base URL, close quote, colon, open quote https://api.myapp.com, close quotation, close squiggly bracket, close squiggly bracket. In this example, we're specifying the base URL of our API, which the app will use to send delivery updates. This structure allows easy updates. If the API URL changes, you can simply modify this file without touching the code. Once you've stored the settings in appsettings.json, you can access them in your Blazor application using the iConfiguration interface. Let's examine how to retrieve the API URL in your code. To access the settings from this file in your Blazor app, we use something called iConfiguration. First, you'll need to create a service in your Blazor app that will retrieve the base URL from the configuration file. This service will read the configuration settings when your app is running. To do this, create a new folder called Services inside the project folder to store the service class. Name it API-services.cs. For this example, add code displayed to the API-services.cs file. In this example, the API service class is responsible for getting the base URL, the API address, from the settings stored in the configuration file. To do this, it uses dependency injection, which automatically gives the class access to the iConfiguration object. The iConfiguration object holds all the settings from both appsettings.json and appsettings.development.json, which means it knows all the important settings your app might need. The API service uses this information to find the base URL and use it wherever the app needs to connect to the API. In order to use the API service in your Blazor components, you need to register it as a service so it can be injected where needed. Here's how to register it. Open the program.cs file in the root of your project. Update the configure services method to add the API service to the service container. Find the section where services are added and add the line displayed. Let's explore a simple use case where you use the appsetting.json file in a Blazor or .NET application to store an API URL. The goal is to configure this setting in a centralized way and access it in the application without hard-coding the value into your code. Imagine you are building a Blazor application that needs to connect to an external service, such as a weather API. Instead of hard-coding the API URL in multiple parts of your code, you store it in an appsetting.json file. This allows you to easily update the URL in one place and keep your code clean and flexible. The appsettings.json file is a configuration file used to store application settings and configurations. It is located in the root folder of your .NET or Blazor project and stores settings as key value pairs in JSON format. There are several reasons that developers choose to use appsettings.json. It can be used to store important settings like API URLs, database connections, or feature flags in a single place. If the API URL changes, you can update it in one file instead of changing it throughout your code base. You can use different settings for development, staging, and production environments. Now, let's explore the steps to add an appsetting.json file in your project. If you already have one, you can add new settings. If not, create a new one. When your .NET or Blazor project runs, it automatically loads the appsettings.json file. However, you need to access the settings in your code. To create a service class, in the services folder of your projects, create a file called API-service.cs. You need to register your Blazor or .NET app in the program.cs file for your app to use the API service. Open program.cs and find where services are being registered. Add the service registration. And that's how you use appsettings.json to manage application settings in ASP.NET Core. You've learned how to store configuration data, access it in your code, and manage different settings for development and production environments. Now it's your turn to try it out in your projects. Building a web application is only the first step. Knowing how to efficiently run and test it can make all the difference in your development process. Understanding how to run a Blazor application in Visual Studio Code will set you up for success in both testing and deploying your app. In this video, we will explain the process of running a Blazor application in Visual Studio Code. Now, let's talk about Visual Studio Code, the tool you'll be using to run and manage your Blazor application. Visual Studio Code is a popular free code editor developed by Microsoft, known for its flexibility and extensive features. It provides tools for building, testing, and running applications. It includes debugging features and an integrated terminal for running your Blazor app. A Blazor project is a web development project that uses Blazor, a framework developed by Microsoft for building interactive web applications with C# and .NET. Blazor allows developers to create client-side web applications using C# instead of JavaScript, and it uses WebAssembly to run .NET code in the browser or operates on the server side. If you already have a Blazor project in Visual Studio Code, you will open it by selecting File, then Open Folder in Visual Studio Code. Alternatively, to create a new Blazor project that we want to name My Blazor App, open a terminal in Visual Studio Code, navigate to the directory where you want to create your new Blazor project, or create a new folder for your project and enter the code mkdir space My Blazor App space cd space My Blazor App. Now, enter a command in the terminal to create a new Blazor WebAssembly project, specifying the intended file name at the end. For instance, for creating a project named My Blazor App, type .NET space new space Blazor WASM space -o space My Blazor App. Now, let's discuss build configurations. Visual Studio Code offers two main configurations, debug and release. Debug is ideal for development as it includes debugging symbols and additional error messages. Release is optimized for production with a smaller file size and better performance, but fewer debugging details. For this example, we will be debugging. To choose a build configuration, click View, then Terminal. Enter the following command in the terminal box: .NET space watch space run space -- configuration space debug. Your Blazor project will open in a new window if all is functioning properly. If a new window doesn't automatically open for you, try Control and click on the link displayed in the terminal window, https://localhost 5001. You can click on items to test if they are working, as was done here. While testing your app, you may need to make small adjustments like tweaking user interface elements or fixing layout issues. Normally, you'd have to stop, rebuild, and restart the app each time you make a change, which can be time-consuming. This is where Hot Reload makes things easier. Hot Reload is a feature in Visual Studio Code that allows you to apply code changes to a running application instantly without restarting the app or server. To enable Hot Reload, you simply need to run your application with this .NET watch command in the terminal. .NET space watch space run. You can edit Razor components, CSS, or other code files within your project. Every time you save changes in these files, the server automatically rebuilds the project and updates the browser. The user interface will refresh with the new code applied almost instantly. Here, we've asked Copilot to generate code to make the title, or header, purple. With these steps, you're now ready to run a Blazor application in Visual Studio Code with confidence. This skill is essential for testing and deploying your projects effectively. Keep practicing, and soon this process will become second nature. Thank you for watching, and happy coding. Every developer faces bugs, but how quickly you solve them can make all the difference. What if you could determine exactly where your code is going wrong and fix issues before they become bigger problems? In this video, we will identify the tools and techniques for debugging Blazor applications. Now, let's start by understanding the most basic debugging tool in Visual Studio Code, breakpoints. Breakpoints are markers that pause the application at specific lines of code, letting us inspect what's happening at each stage. To set a breakpoint, navigate to the left side of the code line you want to inspect and click. A red dot will appear indicating a breakpoint. A breakpoint is used to debug in Visual Studio Code. It pauses the code at a specific line so you can inspect what's happening. For instance, if a for loop is supposed to run 5 times but isn't behaving correctly, you can set a breakpoint at the start of the loop. When the program pauses, you can inspect the value of the loop counter to help identify the issue. While the code is paused, you'll often want to track how variables change as the program runs. With breakpoints set, let's run the debugger. Go to the Run and Debug tab on the sidebar and click on Start Debugging. Visual Studio Code will build and launch your Blazor application in debug mode. Once the code reaches a breakpoint, the execution will pause, giving you a chance to examine the current state. The watch window is a powerful tool that lets you track specific variables or expressions while debugging. To add a variable to the watch window, simply right-click on it in your code and select Add to Watch. You may also ask Copilot to add a variable to the watch window. Now, in the watch panel, you can observe the variable's value at each breakpoint. Now, let's explore stepping through code. Visual Studio Code has several options here: step over, step into, and step out. Step over allows you to move to the next line in the current function. Step into goes deeper into functions, letting you inspect the inner workings of nested functions. And step out returns you to the previous function. Debugging is a crucial skill in Blazor development, and Visual Studio Code provides powerful tools to help you identify and fix issues. In this lesson, we explored how to set breakpoints, use the watch window, and step through code. Now you're ready to apply these techniques to troubleshoot and enhance your Blazor applications effectively. Debugging is more than fixing errors. It's about understanding how your code works. Mastering these debugging techniques will help you solve problems faster and write better Blazor applications. Debugging is a crucial skill in Blazor development. How you approach issues can make a big difference in your project's efficiency. Learning how to debug effectively will save you time and help you build more reliable applications. In this video, we will discuss common issues and how to debug them. Let's start by discussing one of the most common problems in Blazor development: null reference exceptions. A null reference exception happens when your code tries to access an uninitialized object. In programming terms, uninitialized means that no space in memory has been allocated for that object, so it can't be used. For this example, let's assume a Blazor project has a service class and a Blazor component. This example illustrates a common scenario where a variable is not initialized, leading to a null reference exception. In this example, we have a class, myService, with a method, getMessage, that returns a simple string. In the Blazor component, myComponent.Razor, we declare an instance of myService, but do not initialize it. When onInitialized tries to call myService.getMessage, it throws a null reference exception because myService is null. Let's continue on to another common problem. Data binding failures occur when data from your backend, like a server or database, isn't properly passed to the user interface, UI, which can result in the UI displaying incorrect information or not updating at all. In Blazor, data binding is what allows your UI elements, like lists, tables, or forms, to automatically display and update when data changes in the backend. To troubleshoot a data binding failure, start by checking if the backend is returning data properly. Use breakpoints in your code to pause execution and determine if the data retrieval function is working. If the data isn't being sent as expected, there may be an issue with the logic fetching the data. Next, confirm that the data structure matches what the UI expects. For example, if the UI is trying to display a list of products but the list appears empty, it could be because the backend didn't send the data in the correct format or the UI isn't bound properly to the data. This could happen for several reasons, such as the data didn't load properly from the server, there was a mismatch between the data structure expected by the UI and the data sent from the backend, or there was a logic error in the code responsible for retrieving and displaying the data. When this happens, the user interface can't properly display the data, which might cause empty lists, incorrect values, or no updates when the data changes. When the app encounters an error it can't handle, it throws an unhandled exception, often caused by logic mistakes or incorrect input. For example, if the app expects a number for a user's age, but the user types 20 instead of 20, the app won't know how to process it and may crash without explanation. In Visual Studio Code, you can catch errors using the debugging panel. Set breakpoints to pause the execution when exceptions occur. You can also use try-catch blocks in the code to handle exceptions gracefully. This pauses the app when an error occurs, letting you inspect the issue. You can also add if statements in the code to check for bad values. For example, you can check for null values so that you can handle null reference exceptions. Now that you know how to handle exceptions, let's explore tracing the flow of your application to debug more complex issues. Tracing flow means following the sequence of method calls and events to ensure everything runs in the right order. This is especially helpful for tracking user interactions or debugging event-driven logic. For example, if you set up a button to trigger an update but nothing happens when you click it, it likely means the event handler, the code responding to the click, didn't run properly. In VS Code, set a breakpoint by clicking in the gutter left margin next to the line number where you want the code to pause. To inspect variables, hover over the variable when the code is paused, or view the variable's value in the Variables section of the Debug panel. In VS Code, open the Debug panel to view the call stack, which displays the sequence of method calls that have led to the current breakpoint. This can help identify if any methods were skipped or executed out of order. Lastly, inspecting variables at runtime is essential for troubleshooting. It allows you to check the current values of elements in your application while it's running to identify issues like incorrect or missing data. For example, if a field is supposed to display the user's age but displays nothing or the wrong value, you can use breakpoint to pause the code and inspect the variable holding the age. This lets you confirm if the data is being passed correctly or if there's an issue in the code logic. In VS Code, set a breakpoint, and when the code pauses, hover over the variables in the editor to reveal their values or view them in the Debug panel under Variables for a detailed inspection. When the code pauses, you can inspect the variable's value to ensure it holds the expected data. If the value is incorrect or missing, trace backward through the code to determine where the data might have been lost or assigned incorrectly. In VS Code, the integrated terminal can be used for debugging output by adding console.writeLine statements in your code. This output will appear in the debug console, allowing you to trace application flow or inspect variable values without breakpoints. Mastering debugging techniques such as handling exceptions, inspecting variables, and tracing the flow of your application will make your Blazor projects more reliable and save you valuable time. The more you practice these skills, the easier it will be to solve problems and improve your code.
So in this lab, we're going to create a simple Blazor application using a template that's part of the .NET framework. And we'll use that template to create a simple application and then run it and do some debugging as well. So to get started, I'm going to check my .NET version just to make sure I have my environment set up correctly. So I'm going to use the .NET version command, and this should just give me the .NET version. I'm on version 8.0, which is great. The latest version as of this recording is 9.0, but 8.0 is going to work great for our purposes. So the first thing I'm going to do is create a folder called Weather App. I'm going to use the make-dir command and name my folder Weather App. Okay, so now I have my folder. It's under my development main folder. And now I'm going to change to that Weather App folder. So I've moved to the Weather App folder. Now I'm in that folder. I'm ready to create my app. So I'm going to use the .NET new command to create this application. I'll say .NET new. And then I'm going to use the Blazor WASM template. I'm going to use the -o parameter and then call my app Weather App. So it's created the application now under the Weather App folder. You'll notice that it created a new subfolder called Weather App. So a shortcut is just to get into the root folder that you want and use the .NET new command. So you don't have to use make-dir or cd. It will automatically create the Weather App subfolder for you. So I'm going to now change to that Weather App subfolder, and now I can open this up in another instance of Visual Studio Code. I'm going to do that so it's a little bit easier to work with and debug, so we don't have all the other folders in front of us. So now I'm in a new instance of Visual Studio Code, and I have the Weather App open. And now we can get into creating our application, running it and debugging it. So in step 3, we're going to modify the counter.razor. So if we go to our pages folder, part of the template is that it comes with 3 different pages already pre-built. We're going to go into counter.razor and modify the increment count method. This one comes with a method that just updates the number of the current count variable, which is an int. So using the ++ will increment that by 1 each time the method is called. We're going to use a for loop to modify this a little bit. So I'm going to delete this. We'll add it back in just a second, but we're going to put it inside of a for loop. So I'm going to set an int variable equal to 0. And then I'm going to say if I is less than. So when it's greater than 5 or greater, then it'll exit. And then I'm going to increment by 1. And then I'll use my open brace and close brace. And we're going to get some helpers there. And then I'm going to type in current count. You can see I'm getting some IntelliSense here. ++, so that's essentially what we had last time, but we'll add that back in. And now we have our method. It'll loop 5 times and then exit. Now the final thing we're going to do in this lab is create a main function and a nested function, and call the nested function from the main function. So I'm going to continue to modify my counter.razor, and I'm going to remove that and create a new function called main function. Create my braces, and then inside this I'm going to call nested function. It's turning red there because we don't have our nested function written yet, so we'll create that next here. And we'll use the IntelliSense, and then in here we'll update that counter like we had in our original code. We'll do current count ++. So now when we call our main function, the main function is going to call the nested function, and nested function will update the count, and we should be able to see that on our page. One thing we can do here is debug it by setting a breakpoint, and I'm going to go into our debugger and run this. I'm going to choose C# as the language, and then I'm just going to choose the default configuration of Weather App, and that just sets some properties for our debugger. Now notice this actually won't run. We'll get an error when it tries to build. So this is telling me that we had a build failure. Would you like to continue to run the last successful build? We don't want to do that. The issue is that I changed the method from increment count to main function, and I didn't update the onClick event. So it's essentially telling me there's no method to run when someone clicks the button here. So I'll just have to change this to main function. Since we already set those properties earlier, we don't need to set them again. But it's going to try to build the application. All right, so our application is running, which is great. It built and it's going to run. We're going to go to our counter page, which is the one that we modified. And now when we click this button, remember that the main function is going to be called. That's the onClick event here. It's going to call the nested function, and I set a breakpoint at this line. So we can see how we can actually debug this by clicking the button And then we'll go back to Visual Studio Code, and you'll notice that it stopped at that line because that's where I told it to stop. That's what the breakpoint does. And we can check the value of current count. So I'm going to hover over current count, and it should give me the value. If not, I can look in other places. There should be watch lists and other places that we can look at. So I'm going to hover over current count, and you can see the value is 0 because we haven't actually run this nested function even once yet. And we set the current count to 0 initially. So when we hover over it, we just get a 0 because it hasn't changed. Now I'm going to step into the code, which is going to increment that current count by 1. And now when I hover over it, you'll see that it's changed to 1. So I can watch this change as we work through the program. You'll also notice that some of these variables and values are showing up under our variables list, so I can watch that increment each time. So now I'm going to just continue to run the program. And when I click it again, it'll stop at that breakpoint. Current count is 1. And when I step into the application, it should increment to 2. And you can see it's changed there. Current count is 2 and current count is 2. So this just allows us to, in real time, see what's happening in the code and find bugs. So as bugs occur or as issues occur, we can use these breakpoints to stop at any point in our code and try to sort out what's going on.
Mastering Blazor's core components and setting up your development environment efficiently is essential for building dynamic web applications. Gaining hands-on experience with these tools, along with running and debugging your projects effectively, will ensure your applications run smoothly and perform at their best. We began with an overview of Blazor and its core components, highlighting how they interact to build responsive, dynamic web applications. Next, we guided you through setting up the development environment, making sure you were fully prepared to begin building Blazor projects efficiently. You then built your first Blazor project, which gave you practical experience with the platform's key functionalities. Lastly, you explored how to run and debug Blazor applications, helping you troubleshoot any issues and ensure your projects operate smoothly from beginning to end. As you have discovered, understanding Blazor's core components is crucial for building efficient, responsive applications. Proper setup ensures a smooth development process, while hands-on experience with key features prepares you to tackle real-world projects. Running and debugging effectively is vital for maintaining performance and confidently resolving issues. Welcome to Blazor Components and Lifecycle. Mastering Blazor's components is key to building efficient, scalable applications. This module will equip you with the skills to create modular, high-performing projects, setting a strong foundation for advanced development. We will begin by identifying the different types of Blazor components, laying the foundation for building dynamic and modular applications. Next, you will examine the life cycle of Blazor components, highlighting how each stage impacts performance and behavior in your projects. Then, you will focus on parent-child communication, identifying how components interact and exchange data effectively within Blazor applications. After that, we will explore techniques for building reusable components, which will help you streamline development and maintain cleaner code. Finally, you will enhance your Blazor components by applying advanced techniques to improve functionality and performance. Mastering Blazor's components is essential for creating modular, efficient applications. Understanding their lifecycle will help you optimize performance, while effective communication between components ensures seamless data flow. Building reusable components will streamline your development process, and advanced techniques will enhance functionality and scalability, empowering you to create robust, high-performing applications. Let's get started. Building web applications can be much more efficient when you can reuse and modify components with ease. Blazor components provide a powerful way to create flexible and interactive user interfaces transforming how developers build apps. In this video, we will describe what Blazor components are and explain their role in Blazor applications. First, let's define a few key terms related to Blazor components. A Blazor component is a core building block of any Blazor application. It is a reusable, self-contained piece of code that handles the user interface, or UI, logic, and state for specific parts of the app. Blazor components combine C#, HTML, and CSS with Blazor-specific directives to create responsive and interactive web elements. Blazor directives then link these parts, enabling smooth communication between the user interface and application logic within a single component. C# handles the logic and interactivity. HTML defines the structure, and CSS styles the appearance. By using these elements together, you can create reusable dynamic components using Blazor. Suppose we wanted to create a product card for a shopping application. A product card is a visual representation of a product typically used in e-commerce websites or apps. We can create a product card as a Blazor component. By using a component, we can display any product on a web page using this single block of code. Let's examine how a simple product card might be constructed as a Blazor component. We created a file in our application called productcard.razor containing all the components code. First, we add an @code directive that we'll use to add code holding our product information. Using this directive, we can add any C# code the application will need. Inside the code directive, we'll create 4 public parameters that will hold product information. First, we declare a string variable called image_URL to hold a URL to the product's image that we can display on our page. Next, we declare the product name and description parameters as string variables that give the user useful information about the product. Finally, we declare a decimal variable called price for the final piece of important product information, what it will cost the customer to purchase. Beneath the code directive, we'll add HTML and CSS elements to create the user interface elements. The HTML contains a wrapper div element for the entire product card. Inside that element is an image element that displays the product image, an H2 element for the product name, and a paragraph element for the description. Finally, we include another div element to display the product's price. Each of the elements we can style with common CSS styles or style sheets. Notice in this HTML, we can use Blazor directives. In the product name H2 element, we can reference the data in the C# parameter directly using the @productName directive between the H2 open and close tags. This makes components like product cards very useful because you can reuse them throughout the app without writing the same code repeatedly. For example, once you've created the product card component for one product, you can reuse it for every product in your store without needing to rewrite the code. This saves time and ensures consistency in how each product is displayed. Another strength of Blazor components is their modularity. Modularity means components can work independently or together to create more complex interfaces. In our app, the product card component can function independently, displaying a single product, or it can be combined with other components, like a product list, to display multiple products on the page. In addition, each Blazor component manages its user interface as a single logical unit. This means that the visual elements and the logic that controls user interactions are tightly integrated within the component. A product card component, for instance, not only displays the product's image, name, and price, but also manages actions like adding the product to a cart or displaying more details when hovered over. With both the layout and functionality contained in the same component, it's easier to maintain, reuse, and extend the code. Furthermore, Blazor components manage their own internal data, called state. The component state represents the current status or other data within the component. The product card can store whether an item has been added to the cart. When a customer clicks the Add to Cart button, the state changes to display that the item is in the cart. This state is isolated to the component, so changes won't affect other parts of the app unless the developer needs it to. Components often need to share data or interact with each other. This is where parent-child relationships come in. A parent-child relationship occurs when two components interact, with the parent controlling the data and the child displaying or handling the data. In our app, we could add a product list component and make that the parent. It could pass product data to the product card component, which is the child. The parent manages the data while the child displays details like the name, price, and image. This setup keeps the data flow organized, with the parent handling the data and the child focusing on presenting that data. Mastering Blazor components allows you to create dynamic, reusable parts of your app that make it more efficient and scalable. By understanding how Blazor components manage the UI, logic, and state, you'll be better equipped to build powerful web applications. Every web application is built using parts that work together to create a seamless experience. In Blazor, these parts are called components. But how do you choose the right ones to build your application efficiently? In this video, we will identify the different types of components available in Blazor. Components help organize your code, making it reusable and easier to maintain. Instead of repeating the same HTML in different places, you can create a component once and use it wherever needed. Let's start with the simplest type, standard components. Standard components in Blazor are built-in elements that make it easier to create user interfaces. These are ready-made parts like text input fields, buttons, and forms that you can use in your app without having to code them from scratch. They handle common tasks such as letting users type information or click a button and come with built-in functionality to save you time. Using standard components helps you develop your app faster and ensures everything works smoothly since they are optimized for Blazor. Common uses of standard components in Blazor include accepting user input text, displaying data, handling navigation, navlink, data binding, input text, form validation, edit form, and routing and navigation, navlink. Now that we understand standard components, let's examine Razor components, which offer more flexibility and customization. Unlike standard components, which are built-in and less flexible, Razor components allow you to fully customize how they appear and behave. Once created, you can reuse these custom components throughout your app, giving you more control over how your app functions and appears, while still benefiting from reusability, just like standard components. Razor components in Blazor allow developers to build unique UI elements that meet specific design requirements not covered by standard components, create reusable, self-contained components that manage their own state and logic, and enable code reusability across your Blazor app, making it easy to maintain consistent design and behavior. We've covered custom components. Let's now explore third-party components, which provide pre-built advanced features from external libraries. These components, like sortable tables or charts, offer more complex functionality without requiring you to build them yourself. Just like standard and custom components, third-party components are reusable, meaning you can easily integrate them into different parts of your app. Third-party components in Blazor allow developers to provide features that are not included in Blazor's standard component set, such as rich text editors, data grids, charts, and file uploaders. Third-party components often save development time by providing pre-built, customizable components with advanced functionality. Companies often rely on third-party components for building sophisticated UIs, such as dashboards, forms with extensive validation, and more. Each type of component serves a different purpose in your application. Standard components handle basic tasks, Razor components add flexibility, and third-party components save time by providing advanced features. Choosing the right components is key to building efficient, reusable, and scalable applications. By understanding these three types of Blazor components, you're now ready to start developing smarter solutions for any project. Imagine building a web application where each part of the interface is not only reusable, but also responsive to user actions and changes over time. This is the power of Blazor components. They're more than just blocks of code. They're dynamic, interactive building blocks that make your app not only functional, but truly engaging for users. In this video, we will explain the key features and capabilities of Blazor components. Blazor components are reusable UI elements written in C# and HTML that make web development more efficient and maintainable. Blazor components have three core capabilities that enable developers to build dynamic websites: parameter passing, event handling, and lifecycle methods. We'll explore each of these, but let's begin with an example that illustrates the basic component structure of Blazor. This simple example displays a header with a message and a button that updates the message when the user selects the button. This code block has two main sections. The first is a Blazor @code directive. Directives begin with the symbol and are special instructions for Blazor. This code directive contains C# code and can be used to store information or manage user interactions. The second section is HTML and CSS code. In this HTML, we can use Blazor directives as a part of the markup language. Blazor components tightly integrate with code to make updating data, responding to events, and updating the user interface more straightforward and easier to maintain over time. This is just one part of Blazor's power when building dynamic websites. Next, let's investigate the three core features that really make the framework powerful. We'll start with parameter passing. Blazor lets you pass data from a parent component to a child component using the parameter attribute. This is useful when you want to customize a child component based on the data or context its parent provides. In this example, we've defined a parameter called title. By adding the parameter attribute, we're telling Blazor that this value can be set externally by a parent component. We can reference the title parameter in our HTML by using the directive @title. To pass the title to the child, we create a reference to it in the parent and then set the variable title to whatever value we need. In this case, we're setting title to custom title from parent. Now, whenever this component is used, the parent can control the text displayed in the child component. This makes our components adaptable and encourages reuse. Now that we've covered how to pass parameters, let's explore how components respond to user actions through event handling. An event is any user interaction, like clicking a button or typing into a form. Event handling enables components to respond to these actions, making your app interactive. In this example, we define an event handler called change message in C# in the @code directive for our component. When a user selects a button, we set the value of the variable called message to button clicked. In the HTML section of our component, we create a button and use the Blazor @click directive to set the event to the C# handler change message. When the user selects the button, the Blazor directive will call the event handler from the @code portion of the component. Next, let's examine how Blazor components manage their behavior over time using lifecycle methods. Lifecycle methods let you control a component's behavior at different stages, when it's created, updated, or removed, so they perform efficiently and consistently. For example, a component can fetch data from a server as soon as it happens on the screen and clean up resources when it's no longer needed, keeping your app running smoothly. For example, in this @code directive, we use the onInitialize lifecycle method to set an initial alert to the user by setting the message variable to the value page loaded. This method runs when the component is first rendered, making it perfect for setting up default values or fetching data. Mastering features like parameter passing, event handling, and lifecycle methods allows you to unlock the full potential of Blazor components, enabling you to build web applications that are not only efficient, but truly interactive. Have you ever wondered how every button you click or form you fill out on an app works seamlessly? Behind the scenes, there's a process managing every step of that interaction, the component lifecycle, which ensures your app runs smoothly from start to finish. In this video, we will define what a component lifecycle is and why it's important. Understanding how a component behaves through its lifecycle helps with managing how an app works efficiently. The component lifecycle refers to the stages a user interface component goes through from its creation to its removal in an application. The component lifecycle provides hooks to manage resources, update the user interface efficiently, and handle cleanup processes, ensuring the app runs smoothly. The component lifecycle begins with initialization, where the component is set up and its starting values are defined. For example, a greeting component might be initialized with the default data, like a user's name, to display a welcome message. After initialization, the component is rendered on the screen, allowing the user to interact with it. After the welcome message, a greeting component is initialized with the user's name. It displays the message, "Welcome, John," on the page. When the user interacts with the app or when data changes, the component enters the update phase. During this phase, the component adjusts to reflect the new information. If the user changes their name from John to Jane, the greeting component updates to display "Welcome, Jane" instead. Finally, when the component is no longer needed, it should be removed to maintain app efficiency. When the user navigates away from the greeting page, the component is removed from memory to free up resources and prevent the app from slowing down. Mastering the component lifecycle isn't just about creating and removing elements. It's about ensuring your app is fast, responsive, and efficient, providing the best experience for users. Components are the heartbeat of every Blazor application, managing everything from initialization to cleanup with precision. Lifecycle methods give you the power to orchestrate how components respond, update, and conclude their journey in the app. In this lesson, you'll unlock the strategies for harnessing these methods to build responsive, efficient components that truly bring your app to life. In this video, we will describe the key lifecycle methods in Blazor components. To manage components effectively, Blazor provides special methods called lifecycle methods that control how components behave at different stages. Lifecycle methods are pre-built blocks of code in Blazor that control how components behave at different stages, such as initialization, rendering, updating, and cleanup. These methods, or blocks of code, allow you to execute specific tasks at each stage of a lifecycle to ensure the component functions correctly. First, let's start with onInitialized. This method is called once the component is initialized. Think of it as the place to set up any initial state or perform setup tasks. OnInitialized is ideal for initializing values or calling services, especially for data loading that you don't want to repeat. Here is a simple example. In Visual Studio Code, we define onInitialized in our component class. In this example, the code sets up a list when the component is first rendered. Now let's move to the next method, which is useful when working with parameters. OnParameterSet. This method is called whenever the component receives new parameters from its parent component, so it's helpful for reinitializing values or adjusting to new inputs. If you have a component receiving data dynamically, OnParameterSet is a great place to handle updates. Here's an example of using OnParameterSet. Notice how this method updates the display based on new parameters. In this case, every time the parameter value changes, onParameterSet processes it. Now, let's discuss another method that's important for rendering and UI updates. The onAfterRender method is called after the component has finished rendering. This method is often used for JavaScript interop or running code that needs the DOM to be fully loaded. One important note, onAfterRender can run multiple times, so be careful about placing resource-heavy logic here. Here's an example on how onAfterRender works in a Blazor component. By using the firstRender parameter, we limit the execution to the firstRender only. This is very useful for operations like logging or initializing JavaScript components. Next, we'll examine a cleanup method, dispose. This method is called when the component is no longer needed and is being removed from the UI. Dispose is your go-to for releasing unmanaged resources such as stopping timers or unsubscribing from events. Think of Dispose as a cleanup crew that helps keep your app efficient. In this example, we ensure that a timer object is disposed of when the component is removed, which helps free up memory and resources. Lifecycle methods ensure that components behave correctly as they are created, updated, and removed. By using these methods, you can build efficient and responsive components. To recap, we covered 4 essential lifecycle methods in Blazor components: onInitialized for initial setup, onParameterSet for handling parameter updates, onAfterRender for post-render logic, and dispose for cleanup. These methods help you manage data, UI, and resources efficiently. Now you have the foundation to work with lifecycle methods in your Blazor components. Happy coding! Developers want to build web applications that are not just functional, but also seamlessly responsive. An app that anticipates user interactions and handles them with precision. That's the magic of mastering lifestyle methods in Blazor. Lifestyle methods let you control your app's performance, manage its state, and make it adaptable in real time. Understanding how components manage their state and behavior is key to building efficient, dynamic applications. In this video, we will explain how to effectively use lifecycle methods to manage component state and behavior. Before we get started, let's define a few concepts used in Blazor projects. Components are the building blocks of a user interface such as Blazor. They are used to make complex applications easier to manage by breaking them into smaller parts. Components handle both the user interface and behavior behind the scenes, and lifecycle methods help control how a component works during its lifespan. These methods help you control your component's behavior, such as when to load data, update the display, or clean up resources when the component is no longer needed. Lifecycle methods are special Blazor methods that allow you to control a component's behavior at key moments, such as when it's initialized, updated, or removed from the user interface. In Blazor, components undergo a lifecycle, a series of stages from initialization to cleanup. Lifecycle methods allow us to execute custom logic at specific stages in the process. Understanding these methods helps in managing state, initializing data, and optimizing performance. First, let's start with onInitialized. This method is called once the component is initialized. Think of it as the place to set up any initial state or perform setup tasks. OnInitialized is ideal for initializing values or calling services, especially for data loading that you don't want to repeat. After initialization, the component often responds to changes in its data or inputs. This brings us to the next lifecycle stage, updating the component's state when the parameters change. In a product list, onInitialized async fetches data and displays the list once the data is received. Here's how it works. OnInitialized async runs and makes an API call to get product data. Once the data is received, the product list is displayed. Now that the component is initialized, let's explore how it handles parameter changes, such as when a user applies filters. Parameters are values passed to a component like filters for category or price, which affect how the product list is displayed. When parameters change, the onParameterSet method is triggered, allowing the component to respond. When a user selects a new filter, onParameterSet updates the product list to reflect the new criteria. After a component is updated or interacted with, it's important to clean up resources when no longer needed. In the final lifecycle stage, cleanup, you remove event listeners, functions that respond to actions like scrolling or clicking, to prevent any memory issues. The dispose method runs when the component is destroyed, cleaning up event listeners or other unnecessary resources. For example, if the product list has a scroll event listener, dispose removes it when the component is removed, preventing unnecessary memory usage. Now that we've covered all the key lifecycle stages, initialization, parameters, and cleanup, let's highlight some best practices to ensure you're using these methods efficiently. First, keep lifecycle methods simple. Breaking down complex tasks into smaller functions makes your code easier to manage and debug. Instead of handling everything in a single lifecycle method, split responsibilities across smaller functions that each perform a specific task. Simplified methods are easier to test, reuse, and update. For example, onInitialized async can call a separate function to fetch data from an API, keeping the method focused only on initialization logic. By default, Blazor re-renders components whenever the state changes. However, not every change requires a full re-render. The shouldRender method allows you to control whether a component should re-render based on specific conditions. Preventing unnecessary re-renders improves performance by reducing the workload on the user interface. For example, if a product list only needs to update when a filter is applied, shouldRender can prevent it from re-rendering on unrelated state changes. How your components handle data and behavior at each stage of their life can be the difference between a slow app and a responsive one. By mastering lifecycle methods, you can ensure your applications run efficiently and keep users satisfied. How do components in a web app stay independent while still sharing important data? In Blazor, parent-child communication is the key to balancing flexibility and control when building scalable applications. In this video, we will define parent-child component communication in Blazor. Let's start by defining parent-child communication. In Blazor, parent-child communication allows data or actions to be shared between components while keeping them independent, which is essential for building dynamic, responsive applications. This approach simplifies maintenance and enhances flexibility by avoiding code duplication and tight coupling. Now, let's discuss how a parent component sends data to a child. The parent can pass data using parameters. For instance, the parent can send a username to the child, which displays it independently. In the first step, the child component has a username parameter to accept data. Then, in the send step, the parent sends the username, like Alice, to the child, and the child displays, "Hello, Alice." Just as the parent sends data to the child, sometimes the child needs to send information back to the parent. This is done using event callbacks, which act like notifications. When something changes in the child component, it informs the parent so it can respond. For example, a child component with an update button can notify the parent when clicked, allowing the parent to process the update. First, we need to declare an event callback in the child component. This allows the parent to subscribe to an event. Next, we handle the event in the parent component. The parent receives the data, for example, Bob, and updates the list of usernames. Now that we've covered both parent-to-child and child-to-parent communication, we can explore the benefits of using this communication method. One benefit of parent-child communication is maintainability. By keeping components independent, you can change one component without breaking the others. For instance, if the way the child component handles data changes, the parent component remains unaffected and doesn't require modification. Another benefit is reusability. Independent components can be reused throughout the app. Similarly, the same child component can be reused in different parts of the app to handle data display. Now, let's apply these concepts to a real-world example, a simple user management app. We're going to explore how parent-child communication works in Blazor using a user management app. The parent component manages a list of users, while child components display individual user details and allow updates. This setup ensures that the components communicate seamlessly but remain independent, which is essential for flexibility and maintainability. In Blazor, parent components send data to child components using parameters. When the parent component adds a new task, it passes the task details, like task name, to the child via a parameter. For instance, if the parent adds a task named Finish Report, the child receives it and displays Task Finish Report. This keeps the child component focused on its role, displaying the task. If changes are needed in how the task is displayed, like bolding the name, the parent's logic remains unaffected, improving maintainability by keeping the display logic separate from the task management. When a user marks a task as completed, the child component sends the updated status back to the parent using event callbacks. For example, if Finish Report is completed, the child informs the parent, which then updates the task list. This two-way communication allows the parent to respond to changes without directly controlling the child's behavior, keeping the components loosely coupled. This makes the child component reusable across different parts of the app to manage or update other tasks. Using parent-to-child and child-to-parent communication keeps components flexible, maintainable, and reusable. The parent handles the overall task management while the child focuses only on displaying and updating specific task details. This separation ensures that changes in one component don't affect the other, making the app easier to maintain and enhancing reusability, as the same child component can be used to manage other task-related features. By skillfully deploying parent-child communication, you can keep your components independent yet flexible, ensuring data flows smoothly while maintaining clean, scalable code. Have you ever wondered how components in a web app stay independent yet still share important data? In Blazor, parent-to-child data sharing through parameters is key to creating flexible and dynamic applications. In this video, we will describe how parameters are passed from parent to child components. Data sharing between components is essential. Blazor enables this using the parameter attribute, which marks properties in a child component to receive data from the parent. An attribute in Blazor modifies the behavior of a component, and the parameter attribute specifically indicates that a property will accept data from the parent. Let's consider how this works with simple data, like a string. Suppose that a parent component needs to pass a username, like Alice, to a child component. The parent sends the username, and the child displays "Hello, Alice," using the value passed via the parameter attribute. In addition to passing text, you can also pass other data types, like numbers. Let's go over how that works. Suppose the parent needs to pass an age, such as 25, to the child component. The child then displays age, 25, showing how the parameter attribute can handle different types of data, not just text. Being able to pass different types of data, like text and numbers, allows parent components to send a wide range of information to child components. Now that we've discussed how the parameter attribute works, let's break down the steps involved in passing parameters from a parent to a child. First, we need to declare the parameter in the child component. The child component defines a property and marks it with the parameter attribute. Next, we pass the value in the parent component. The parent assigns the value to the child's parameter using HTML-like syntax. Parameters don't just pass data, they also make components more flexible and reusable. Let's explore some scenarios when it is appropriate to use. A button component can receive different labels like submit or cancel based on the value passed by the parent. This makes it reusable. Reusing components means you can write code once and use it in multiple places, saving time and reducing errors. Now that you understand how parameters work, let's explore the key benefits of passing parameters. The first benefit is reusable components. If you're developing a product card component, you can create a generic card that displays different products, but each card receives its own product information, name, price, etc., via parameters. The second benefit is parent-child communication. Let's consider a different scenario. A parent component could pass user information like appointment details to a child responsible for rendering the doctor's schedule in a telemedicine platform. The third benefit is dynamic user interfaces, like one for a fitness app. Parent components could pass different workout plans or diet information to various child components, allowing dynamic and personalized user experiences. Reusable components, parent-child communication, and dynamic user interfaces create modular, maintainable, and scalable applications. These principles streamline development, enhance collaboration, and deliver personalized user experiences across various platforms. Understanding how to pass data between components is fundamental to building dynamic applications. By mastering parameter passing, you can make your Blazor components more flexible, reusable, and easier to maintain. In web applications, seamless communication between components is crucial for building interactive and dynamic user experiences. In Blazor, child components often need to notify their parent components when something happens. This is where event callbacks become essential. In this video, we will explain how child components can communicate with parent components using event callbacks. Now, let's begin by understanding how event callback works for basic event communication. In Blazor, event callback is a mechanism for communication between child and parent components. It lets a child component send notifications to its parent when an event occurs, such as clicking a button. Essentially, it provides a way to handle events at the parent level, even though the event occurred inside a child component. Now that you understand what event callback does, let's explore how it works in practice by breaking down the code step by step. This opens the code block for the Blazor component. Everything between the brackets will define the code for this component. Parameter. This tells Blazor that this property can receive data or events from the parent component. Public event callback on button click, squiggly bracket, get semicolon, set semicolon, close squiggly bracket, colon. This creates a property called on button click of type event callback. It allows the child component to trigger an event that the parent will handle, like a button click. The get semicolon, set semicolon part allows the property to be accessed and modified by the parent component. This line declares a private method named handleClick. This method will be executed when the button is clicked. It is private, meaning it can only be used within this component. On button click. This refers to the event callback we defined earlier. It triggers the event for the parent component. Invoke async, open parents, close parents. This method triggers the event, notifying the parent that the button has been clicked. The async part means the action happens in the background, which can be useful when the action takes time. This Blazor child component includes a button click event that's designed to notify its parent component when the button is clicked. We start by defining a parameter called onButtonClick, which is set up as an event callback. This allows the parent component to provide a response whenever this event is triggered. The method handleClick handles the button click. When the button is clicked, it triggers the event and allows the parent component to take any necessary action. This approach is a common way in Blazor to enable child components to communicate actions back to their parents, creating interactive and dynamic web applications. This code sets up a button-click event in a Blazor child component. It includes a parameter called onButtonClick, which allows the parent component to respond to the button click. When the button is clicked, the handleClick method is triggered, which then calls the onButtonClick event. This way, the child component can notify the parent component of the click, allowing the parent to take action based on that event. Now that we've explained how to trigger a basic event, let's move on to a more complex example using event callback with a t-tag to pass data. Event callback t-tag is a version of event callback that allows the child component to send data, such as a selected item, back to the parent. The t-tag represents this type of data being passed, like a string or a number. When the child component triggers an event, it can pass a value like a string or number to the parent, which can then use this data. Let's discuss how event callback t-tag is used to pass data from a child to a parent. Add code opens the code block for this Blazor component, just like before. Parameter. Again, this allows the parent component to interact with this property. Public event callback, tag string, on item selected, open squiggly bracket, get, semicolon, set, semicolon, close squiggly bracket. This creates an event callback t-tag property where the t-tag is a string. It will send a string value like an item name from the child to the parent component. This declares a method called selectItem, which is used when the user selects an item. The method takes one argument, item, which is a string representing the item for the user selected. This bracket closes the selectItem method. This bracket closes the code block for this component. Now that we've walked through how to trigger events and pass data between components, let's take a moment to reflect on how these tools, event callback and event callback with a t-tag, are essential for enabling seamless communication in your Blazor applications. Enabling components to communicate efficiently is a crucial part of building interactive applications. By mastering event callback and event callback with a t-tag, you'll be able to create responsive applications where components can easily trigger actions and share data between parents and children.
In this lab, we're creating a simple task manager application, and we're going to show how we can use parent and child components and as well as event handling in Blazor, and we'll also illustrate lifecycle methods using this lab. So you'll be able to try all of these features in a Blazor app. In step one, we're simply setting up the development environment. We're going to create a new task manager app called Task Manager App, and it's going to be a Blazor WASM template that we're going to use to create that application. Now in step two, we're going to create parent and child components, and this is a really powerful feature of Blazor where we can embed a child component in a parent, and so we can interact with the child through the parent. So first task that we're going to do is create a child task display.razor file, and we're going to use the child and embed that into the parent. You'll notice that I have in the code directive here 2 parameters. So I'm setting the parameter attribute on these items. So we've got a task name, and then we have a method called onTaskCompleted, and that includes this mark as complete method as well, this child component. We're marking the first 2 as parameters so that we can interact with them from the parent. The next thing we're going to do is create that parent. We have a title here at the top, and then in the parent itself, we're going to create a reference to the child task display here. So we're going to use this construct to essentially pull in the child task display.razor code. And you can see there's an onTaskCompleted, which is handle task completed, and that is also in our child, the onTaskCompleted method. But what we're doing here is telling the application that when that is called, to use this method in our parent to handle that task. We have a new task list, which is just a list of strings, and we're just calling them task 1, task 2, and task 3 for now to illustrate how this works. In step 3, we're going to be using lifecycle methods, which allows Blazor to handle tasks in a very specific way. So to do that, I'm going to go back into my parent task manager.razor code, and I'm going to add another method called oninitialized in my code directive. Paste that in here. And this is the oninitialized, which is just going to write out to the console that the parent component was initialized to illustrate how that works. I'm also going to make a change in my child task display file. And I'm going to create a method called onParameterSet, which is going to fire every time one of the parameters has been modified or updated. So that onParameterSet is going to, again, just write to the console to illustrate the point. But when we add a task, for example, it will write the task name out to the console. I'm going to go ahead and run this application. And we can see how the lifecycle management works in this. I'm going to browse to the page that, this is the parent page. And you can see we have our 3 tasks here, task 1, task 2, and task 3. And I'm going to open up developer tools so we can keep an eye on the console. You can see that the tasks are written to the console as we had in our code. As I hit complete, it's going to write out those remaining tasks. That's how we use these features in Blazor, both the parent and child components and the lifecycle methods in Blazor to manage the application.
What if you could write a piece of code once and use it everywhere, cutting your workload in half? Reusable components do just that, helping you build applications faster and with fewer mistakes. In this video, we will explain the benefits of creating reusable components. Before we discuss the benefits, let's first explain what reusable components are and why they are important. Reusable components are pieces of code you create once and use in multiple places, like a button component that takes parameters for label, style, and click events, making it adaptable for various actions throughout the application. Think of them like Lego blocks. Each block has a specific function, and you can combine or rearrange them in different ways to build something new without having to start from scratch every time. Now that we understand what reusable components are, let's explore why they are essential in development. Reusability saves time and keeps your code consistent. When you update a reusable component, that change happens everywhere it's used. Imagine you're updating a template in a document editor. Changing the template automatically updates every document that uses it. This is exactly how reusable components work in your code. This saves a lot of time and effort, especially as your project grows. Reusability is important, but how does it help with maintaining and organizing your code? Let's explain that next. Reusable components make it easy to maintain and update your code. For instance, if you have a button used on many pages, you can change it once in the component and it updates everywhere. This reduces repeated code and minimizes errors across your project. Reusable components not only help with maintenance, but also support modular development. Here's how. Reusable components support modular development, meaning each component works independently from the others. Think about an input field used in many forms. When you update the input field in the component, the change appears everywhere it's used automatically, making the application flexible and easier to scale. Now that we've explored how reusable components help modular development, let's explain how they simplify more complex applications. Complex applications are easier to manage when you use reusable components. For example, if you have a navigation menu that's used on many pages, making a change, like adding a new link, once will update it across every page. This keeps your code organized and reduces the chance of errors. By using reusable components, you can keep your code easy to maintain, reduce repeated work, and create flexible, scalable applications. It's a key skill for building efficient software. You can create components that adapt to any scenario, all without rewriting your code. Blazor's tools like parameterization, templates, and inheritance make this possible, helping you save time while making your applications more flexible and efficient. Let's explore how these features can elevate your Blazor projects. In this video, we will describe key techniques for building reusable components in Blazor. Let's begin by exploring the first technique, component parameterization. Component parameterization allows you to pass values into a component, changing its behavior without rewriting the code. Think of a button you've used across different parts of your app. Instead of creating a separate button for submit, cancel, and reset, you can create one button component with a parameter for the label. By passing different labels like submit or cancel, you can reuse the same button component while customizing its text. Reusable components are designed to be used multiple times without modification, ensuring consistency across an application. Component parameterization, on the other hand, allows customization by passing specific values, enabling a single component to adapt to different scenarios without duplicating code. For example, a reusable button might be used everywhere, while parameterization allows changing its color or label as needed. While parameterization helps change how a component behaves, templates allow you to adjust the actual content displayed within the component. Templates let you pass user interface into a component so you can customize content without changing the component. Templates make your components more adaptable, saving time by reusing the structure with different content. Consider a list component that displays items. With a template, you can decide how each item should be presented. For instance, you might want to display product images and prices in one list and only names in another. The list structure stays the same, but the content is tailored to different needs. Templates allow you to customize content, but if you want to share and extend a component's behavior across multiple components, inheritance helps you do that. Component inheritance lets you create a base component with shared logic and then extend it to create new components with additional features. Inheritance helps you reuse logic without repeating code. Think of a form component that handles basic validation. Instead of creating multiple forms from scratch, you can build specialized forms like login or registration forms by inheriting from the base form. You add specific fields like username and password, but the core validation logic stays the same across all forms. Now, let's bring these techniques together with an example. Imagine you're building a product catalog. You can create a reusable product card component that displays an image, price, and title. Using parameterization, you pass the product data like image and price to the component, so each card is customized for a different product. With templates, you can customize how each product is presented. Perhaps one view displays a detailed description, while another focuses on the image. Finally, by using inheritance, you create specialized product cards, such as one for featured items with a sale tag. This way, the structure remains consistent, but the behavior and content are tailored to different needs. Mastering techniques like parameterization, templates, and inheritance makes your components reusable, makes your applications easier to manage and scale, and gives you more control over your code. Reusable and maintainable components are at the core of efficient software development. They help reduce redundancy, simplify updates, and facilitate collaboration in large code bases. However, designing these components requires thoughtful planning and a balance between flexibility and specificity. In this video, we will outline best practices for ensuring components are reusable and maintainable. To start, let's focus on one of the simplest yet most impactful practices, naming conventions. Adopting clear, consistent naming conventions is the first step towards making your components reusable and maintainable. Good names should reflect the purpose of the component and make its role easily understandable for other developers. Naming conventions mean a standardized system for naming files, variables, and components that improves clarity and reduces confusion. Avoid overly generic names like component 1 or button. Use descriptive names such as primary button or cart item. Follow a consistent naming pattern, for example, camel case or Pascal case. This improves readability and ensures developers don't have to guess the naming rules when creating new components. Documentation is essential because it allows other developers to understand how to use your components quickly. It also guides when and where to use them, which is crucial for maintainability. Documentation ensures that new team members can get up to speed quickly and utilize existing components without extensive knowledge transfer. Comprehensive documentation makes components easier to maintain and reuse. Each component should have clear documentation that explains the purpose of the component is to describe its function and how it integrates into the overall system. The parameters section explains which parameters the component accepts and how they should be used. An example of documentation could be writing code snippets describing how to implement the component. Designing components with flexibility in mind ensures that they can adapt to different contexts without major rework. Here's how to design flexible components. Use parameters to pass values to components instead of hard coding them. This enables customization while preserving the component's basic structure. Implement conditional rendering to display different elements based on the values of props. Avoid hard coding styles. Instead, pass styles as props to make components adaptable to different themes or use cases. Reusable components should be general enough to serve multiple purposes, but specific enough to avoid unnecessary complexity. Reusability is the capability of a component to be used across different projects or contexts without significant modification, whereas specificity is how tightly a component is tied to a particular context or use case. Keep components small and focused to make them easier to understand and maintain. When a component handles too many tasks, it becomes difficult to manage. Avoid side effects in components. They should not alter external states or cause unexpected behavior. Instead, they should focus solely on rendering based on input. Use composition over inheritance by combining smaller components to create larger ones. This approach keeps your code modular and easier to extend. The power of reusable, well-documented, and flexible components goes beyond just saving time. It transforms how you build and maintain applications, ensuring that your code stays adaptable and relevant. When building a web app, how do you ensure your components are not only powerful, but also easy to manage and reuse? Mastering a few key Blazor features will help you make your apps more flexible and efficient. In this video, we will identify advanced features available in Blazor components. Let's begin by understanding how dependency injection simplifies the way components access shared services, making them more modular. Dependency injection enhances component functionality by allowing components to use external services, such as data fetching or logging, without the need to create or manage these services themselves. This improves the application's modularity and reusability. For instance, a reusable service might handle API requests, allowing multiple components to share the same functionality without duplicating code. By separating the logic of fetching data from components, dependency injection keeps components focused on their primary responsibilities, making the code cleaner, easier to maintain, and more flexible to changes. Dependency injection handles services while cascading parameters simplify data sharing, both enhancing modularity and reducing redundancy. Cascading parameters allow you to pass data through multiple components automatically without having to pass it manually at every level. This is especially useful when multiple components rely on the same data. For instance, consider an online shopping cart. The cart details like total cost, item count, etc. need to be displayed across multiple sections, like the header, a summary view, and the checkout page. Instead of passing this data individually to each component, cascading parameters let you automatically share it across all relevant sections. This not only reduces repetitive code, but also ensures consistency. With cascading parameters managing shared data, Let's move to component references for more control over child components. Component references let a parent component directly interact with a child component's functions or properties. This is especially useful when you need to trigger actions in a child component or access its state. Imagine a multi-step form where users can progress through several steps. Suppose a user wants to reset the form or go back to an earlier step. In that case, the parent component can use a component reference to directly control the behavior of the specific form step without needing to pass extra instructions. This approach gives you more precise control over how your app behaves. Let's explore how dependency injection, cascading parameters, and component references work together to create a more efficient and flexible app. Imagine we're building a project management app where users track tasks, view progress, and manage projects. First, dependency injection provides shared services for tasks like data fetching and user authentication. Instead of adding data fetching logic to every component, we use a shared service to pull task data from an API. This keeps components focused on displaying data and makes the app easier to update and maintain. Next, cascading parameters pass shared data like the project's completion percentage automatically through multiple components such as the task list, progress bar, and dashboard header. This eliminates the need to manually pass the same data to each component, ensuring consistency and keeping the code simpler. Finally, component references allow a parent component to control child components directly. For example, when a user completes a task, the dashboard can reset the task editor form or update the task list without needing extra event handlers. This provides direct control over the app's behavior when interacting with child components. Building web apps that are maintainable and reusable isn't about adding more code. It's about using the right tools. By mastering these advanced Blazor features, dependency injection, cascading parameters, and component references, you'll make your components more powerful and your code easier to manage. When your app takes too long to load or respond, users lose interest quickly. How can you improve your Blazor components to make your app faster and more responsive without adding more complexity? In this video, we will describe techniques to optimize the performance of Blazor components. Let's start with pre-rendering, which helps you improve how quickly the page appears to users. With pre-rendering, you render components on the server and send the HTML to the client before the app fully loads. This way, the page's structure is displayed for users faster. Without pre-rendering, a blank screen may result until everything loads. By using pre-rendering, you ensure that the layout displays quickly even while data is still loading, making the app feel faster. After ensuring that your app's layout appears quickly with pre-rendering, the next step is to handle data efficiently in the background. Let's move on to asynchronous data loading. With asynchronous data loading, you load data in the background without freezing the interface, keeping the app responsive. Instead of waiting for all product data to load, you can display the page immediately and fill in product information as it arrives. This keeps users engaged and the app responsive. While asynchronous data loading keeps your app responsive during the data fetches, you still need to avoid unnecessary updates that can slow it down. Let's talk about minimizing rendering cycles. A rendering cycle happens every time the app updates the visual elements on the screen. Reducing the number of rendering cycles helps you improve performance. In a real-time chat app, updating the entire interface every time a new message arrives slows down performance. By updating only the message area, you keep the app running smoothly and avoid unnecessary re-renders. Now that you know how to reduce unnecessary updates, let's discuss efficient state management, which helps you control how and when components update. In Blazor, state management means tracking the data that drives your app's behavior. Managing state efficiently ensures your components update only when necessary, reducing performance costs. In an inventory system, If every update to stock levels trigger a full page refresh, it would slow things down. By efficiently managing state, you can update only the necessary parts, keeping the app responsive. Let's examine an example. Suppose a company's product recommendation engine causes delays in loading the home page. Initially, it retrieves and processes all recommendations at once, blocking the user interface. Enable pre-rendering so the homepage layout appears immediately while product recommendations process in the background. Load product recommendations asynchronously to prevent user interface blocking. Ensure that only the product recommendation section updates when the data arrives, avoiding unnecessary re-renders. Manage recommendation data state efficiently so updates occur only when necessary and don't trigger full-page re-renders. By applying these optimizations, the company improves its app's performance, ensuring that users experience a fast and responsive interface even when handling large amounts of data. Performance isn't just about speed, it's about efficiency. By mastering these optimization techniques, you'll not only make your Blazor components faster, but also create a smoother, more engaging user experience. How much control do you have over Blazor components? Advanced customization techniques can help you make your components more dynamic and responsive to user interactions. Let's explore how you can unlock their full potential. In this video, we will explain how to customize component behavior using advanced techniques. Let's start with custom lifecycle events, which let you control exactly when and how components behave in an application. They allow you to trigger actions like animations, data logging, or resource management at specific points, providing more flexibility and improving performance. While lifecycle methods like onInitialized and onAfterRender trigger predefined actions, custom events lets you trigger your own logic at specific points. For instance, if your component fetches data from an API, you can use a custom event to refresh the data when a user changes a filter, ensuring the component responds precisely as needed. Now that you can control when components act, let's explore how to customize what they display using render fragments for dynamic content. Render fragments lets you insert dynamic content into reusable components, changing what's displayed without rewriting the component. For example, with a reusable modal component, you can insert different content, like a form, image, or text, dynamically, making the component versatile without altering its code. Now that you've learned how to render dynamic content, let's explore managing the data that drives your components. Complex data binding ensures components handle structured data efficiently. In two-way data binding, data syncs automatically between parent and child components. For example, changes in a form field instantly update the parent object. Complex data binding builds on this to manage more structured data, like nested objects. For instance, in a registration form, if the user object contains an address object, you can bind address fields directly to it. This keeps everything organized and ensures data stays synced. Let's imagine a user dashboard with a data table that displays user information. The table supports filtering, and clicking on a row opens a reusable modal component displaying detailed user data. This setup demonstrates custom lifecycle events, dynamic content with render fragments, and complex data binding. The data table needs to refresh automatically when the user applies a filter. Instead of relying only on default lifecycle methods like onInitialized, you can use custom events to trigger the data refresh precisely when needed. For example, when the user adjusts the filter options, the data table can immediately update itself by fetching new data from the server. This ensures the component stays responsive and displays the most current information without page reloads. Now imagine the reusable modal component used to display user information. Instead of creating separate modals for different types of content, like user details, images, or a feedback form, Render fragments lets you pass in dynamic content to the same modal component. This allows the same modal to display different layouts based on the use case. For example, clicking a user's name might reveal a profile summary, while clicking a button in the table could bring up a form to update their information, all within the same modal component. Finally, let's say the user's data includes nested objects like an address or a list of roles. With complex data binding, you can bind specific form fields like street, city, or postal code directly to these nested objects. This keeps the data organized and ensures that any changes made within the modal or table update the parent object automatically. For example, editing the address fields inside the modal would instantly sync with the main user object, maintaining data consistency throughout the application. Customizing your Blazor components is key to building truly flexible applications. By applying advanced techniques, you'll streamline your components and improve their performance and responsiveness to users' needs.
In this lab, we're creating a simple product catalog application. And in step 1, we work through creating the app using the .NET New Blazor WASM template. We're just going to call this application product catalog. With the application set up, in step 2, we're going to implement dependency injection. This allows us to take Blazor components and inject them, essentially put them into other components, which is a very powerful feature of Blazor. So it allows you to compartmentalize your application development and then use those components in other parts of your application. So to do that, first we create a data services class. In this class, we just have a simple task that's going to get our products asynchronously. We're just simulating a delay in this first line, and then we're returning a new list of strings, product 1, product 2, and product 3. So this is our data service. It's again simulating getting products over the internet or from a network or a database, but it's just going to return a simple list of strings. Once we have our items created, we can go into program.cs and we're going to create a singleton using this line, builder services add singleton, and you can see we're using the data service as the object for that singleton. A singleton just allows us to use that object throughout the application. So we're making sure that that's available to other parts of the application by putting it in program.cs. The next thing we're going to do is go to our pages folder, and we have a reusable card.razor. We're using this as a way to illustrate how you can inject other components into Blazor components and use them throughout the application. So the first thing we're going to do is inject our data service, which we do here at the top. Notice that we're using the data service object, which is again that data service class that we created. We're going to inject that data service class or object and call it data service. And that will allow us to use that throughout this application. And then we have an HTML block at the top, which has some Blazor references in it. Essentially, what we're doing here is that we're toggling the product list. We have a button that toggles the product list. And we have an if-else statement and a for each statement, and then it pulls all the products in. As the page is rendered, we get a list of all the products that are in our catalog. In the code directive, we're creating a list of strings, which are the products. Notice that we're using that products class. And we have a new list of strings with product 1, product 2, and product 3 in them. In a real application, we wouldn't do it this way. We would use a database, but we're just using this for illustrative purposes so that we can show how you can create a new list of strings. And then we have a Boolean should render condition called should render condition, and we're setting that to true. And then when the Boolean value should render is set to whatever the should render condition is, then we're using that should render in the HTML so that we can show the products. In the last method, we're just toggling that should render condition variable. So if it's true, this line will change it to false. If it's false, it will return true. So this just shows us how we can use that data service object inside our product page here. And if we update the product page, we can reuse this card to show those new products without having to create a new card for every single product or list of products. Now in step 3, we're going to show how we utilize cascading parameters, how we can pass parameters from one block of code to another block of code using some Blazor specific components. So I'm going to go into main layout.razor in our layout folder. And you'll see that I have a cascading value called theme color. In there, I'm referencing the app body block. So within that cascading value tag set, I'll render the app body block of code. As the theme is changed under the select block, so we can see that we have a select block with 3 options, blue, green, and red. As that's changed, that will cascade to the code block. Now notice also we have a @code directive here. We have a string set to the theme color of blue, so that's what we're setting it to initially. So it has some value when the page loads. And then we have a change theme method that we're passing in whatever color we want that we set up here. And that method is a part of this select statement. So when we select the dropdown, it's going to call this method change theme, and then it's going to set the theme color to whatever value we pass in. And then that value that we pass in will be used in that cascading value element up above. On step 4, we're going to work through using component references, which again is a way that we can reference one set of code in another set of code in Blazor. So you'll see here in our pages folder, we have a parent component and a child component. And first we're going to update the parent component, and we're going to create a reference to the child component. So you can see at the beginning here we have child component and then an @reference, which is what we're going to use to reference the child component, calling it child ref. But this allows us to bring that child component into the parent component and use it as if it were a part of the parent component. The value here is that we can compartmentalize our development and create these as 2 separate entities, but to the user it appears as one block of code. And we have a button where that will allow us to update the child. So as things change, we click that button and whatever has changed in the child gets referenced in the parent. And then in our @code directive, we have a reference to the child component, which we've outlined at the top, called child ref. And then we have our method update child, which updates the state of the child ref object. Now let's look at our child component. In our child component, we simply have a div, which shows the child component state. So we've got a paragraph tag, child component state, add child state, which is the state of the child when we, for whatever we're going to be doing with it. In our @code directive, we have the child state initially set to the initial state, so we can see it change in the parent component. And when we click that button, that update state method's going to run, and it's going to change the child state to updated state. So in the parent component, when that happens, you see the child ref update state. It's going to modify what is shown in the child component, and we'll see it in the parent component. In step 5, we're just going to do some optimization here to make this a little bit more usable. So we're going to go into reusable card.razor. And we've already looked at this code, but the optimizations that we can do really are about using these for each statements and allowing us to improve upon the original code that we wrote by making it a little bit more efficient. We looked at this earlier, but the toggle render condition just flips the state, for example, instead of having a bunch of if-then statements in there. So this is an optimized version of this code. It allows us to be able to use this with a little bit more efficiency in Blazor. So what we looked at here is a number of different Blazor options that we have to make our application easier to maintain, easier to write, and better for our user.
Mastering Blazor's components is essential for creating modular, scalable applications. In this module, you'll focus on key skills that will help you build more efficient, maintainable projects. This will equip you with the knowledge to handle both foundational and advanced aspects of Blazor development. We began by defining the various types of Blazor components and establishing the groundwork for building modular and dynamic applications. Next, you explored the lifecycle of Blazor components, focusing on how each phase influenced your project's performance and behavior. Then, you examined parent-child communication, discovering how components interacted and exchanged data efficiently within Blazor applications. After that, you explored methods for building reusable components, enabling you to streamline development and maintain more organized code. Finally, you improved your Blazor components by applying advanced techniques to boost functionality and performance. Congratulations on completing the Blazor Components and Lifecycle module. You've gained the tools needed to design powerful, flexible Blazor applications that can be adapted to a range of projects. With a deeper understanding of components and advanced techniques, you're well prepared to enhance both functionality and performance in your future work. Welcome to data binding, event handling, and navigation in Blazor. Mastering these core concepts is essential for building responsive, user-friendly web applications. In this module, you'll develop the skills to create seamless interactions and manage data efficiently, ensuring your Blazor projects are dynamic and reliable. These techniques will significantly enhance the functionality and user experience of your applications. We will begin by defining data binding in Blazor and exploring how it connects your UI with underlying data to create interactive, dynamic applications. Next, you will examine event handling, focusing on how Blazor manages user interactions and triggers responses within your applications. Then you will explore routing and navigation, learning how to structure and guide users through your Blazor applications easily. After that, you will examine state management techniques to maintain data consistency across your Blazor applications. Finally, we will identify the best practices for form handling and validation, ensuring your forms are efficient, user-friendly, and secure. By the end of this module, you'll have the skills to build dynamic, responsive Blazor applications that handle data and user interactions seamlessly. Let's get started with data binding, event handling, and navigation in Blazor. Most airports have flight information boards that display passengers the latest details about their flights. Now imagine an airport that uses a chalkboard for this purpose. Whenever a flight status changes, someone has to erase the old information and manually write the new details. Modern information boards don't work that way. They automatically update as new data comes in, displaying only the changes without any manual effort. This is similar to the difference between websites that use data binding and those that don't. Data binding, a key feature in Blazor applications, enables instant updates by automatically reflecting changes in the underlying data without requiring a manual refresh. In this video, we will describe data binding and why it's important in Blazor applications. Let's begin by explaining what data binding means and how it works in Blazor. Data binding is a mechanism that synchronizes data between the user interface, UI, and the underlying application logic, so changes in one reflect in the other automatically. This means that if the app's data changes, the user interface updates without having to refresh the entire web page. If the user interacts with the user interface, like typing in a field or selecting options, the app's data updates automatically. This synchronization can work both ways too, by updating or adding data to a data store and getting data from it. If a user fills out a form, data binding will update a data store with that new information. If a user later wants to view the information they entered, data binding will enable the app to immediately provide that information in the user interface. Let's examine a practical example. Imagine you're using a to-do list app to manage your daily tasks. You can view a list of things you need to do: buy groceries, clean the house, water the plants. Next to each task is a checkbox. When you complete a task, like buying groceries, you click the checkbox and the task immediately moves to the completed section or gets marked with a line through it. With data binding in Blazor, the task is marked as complete in the database immediately as well, so it appears as completed the next time you open the app. With data binding, this change happens instantly. You don't need to refresh the page or press a save button. This instant synchronization is what makes apps feel responsive and user-friendly. Data binding makes Blazor apps responsive and interactive. It's an efficient way to keep data and the user interface synchronized automatically, creating a dynamic user experience. Imagine if your mobile phone only gave you one type of notification option. Every time something happened in your sports app, whether a player scored or a coach changed a strategy, you'd get notified the same way, over and over again. That would be frustrating, right? Like these inflexible notifications on a mobile device, users would have a poor experience if you could only work with data in your Blazor app in one way. Data binding solves this by allowing you to decide how data flows between your app and the user interface. Just like your phone offers different types of notifications, Blazor offers various types of data binding to offer the best user experience depending on the situation. In this video, we will describe the different types of data binding supported by Blazor. Blazor offers two ways to keep the user interface and data in sync using data binding: one-way binding and two-way binding. Each serves a specific purpose, allowing developers to tailor the user experience based on the application's needs. Let's start with the simplest type of data binding, one-way binding. In this type, data moves in one direction, from the app's code to the user interface. It's useful for displaying information that doesn't change, like a product name or a message. When an app shows a product name on a web page, the data is displayed on the screen, but the user can't modify it. In other words, the data is never sent back to the data store. This makes one-way binding ideal for content that doesn't need to change. The next type of data binding, two-way binding, is more interactive. This type allows data to flow in both directions. Changes in the user interface, like user input, update the app's data store, and any changes to the data are instantly shown on the screen. This type is commonly used in forms. When users enter their names in a form, the app's data updates immediately. If the data in the data store changes, the form reflects that update. Two-way binding is ideal for scenarios where users need to input or edit data. Let's review the two types of data binding in Blazor. Each type of binding serves a distinct purpose in Blazor applications. One-way binding is ideal for displaying static information like a product name or a status message. Two-way binding is perfect for interactive user inputs like filling out a form field or adjusting user settings. When your app and data stay in sync without effort, it creates a seamless user experience. Blazor's data binding techniques, one-way and two-way, make this possible. Imagine you're filling out a form with many fields and many pages. You've spent a lot of time filling out a few pages of your form, and suddenly your web browser crashes. You reopen the form only to find that none of your information has been saved. You have to fill out all the information you've already entered all over again. Data binding in Blazor can help users avoid situations like these. By automatically synchronizing form data with the application state, data binding ensures that information is preserved even during unexpected interruptions, creating a more reliable and user-friendly experience. In this video, we will explain how to apply data binding in real-world Blazor applications. Let's start by examining different ways data binding can be used in applications. Forms are where data binding shines. By using data binding in Blazor apps, developers can connect the input fields directly to the app's data. This enables the app to update the data immediately as the user types or interacts with the form. This real-time connection makes forms responsive and user-friendly. For example, when you fill out a contact form with your name and email, the app can use data binding to update a data store after you enter the information in each field. Data binding updates the data store in real time so the app can retrieve your information even if you close your browser. This use of data binding sends data to a data store in real time, and developers can also use it to retrieve data from a data store. Another data binding application is fetching data to update the user interface. When a field on a web form is bound to a data store, the user interface updates instantly when the data in the store changes without the user having to refresh the web page. For example, a sports app may have real-time information on player stats and game scores. Data binding enables the app to update the information on a screen when the underlying data changes. Because the app uses data binding, users don't have to continually refresh the page for the updates to appear. Finally, maintaining state is another common way developers use data binding. State is a snapshot of data for a specific period in time. It helps track things like user input, options users select, or progress during a browsing session or when a user is in an app. Developers use state management so their applications remember user actions and data. Data binding makes it easy to preserve these details as the user interacts with the app. For example, in an app with an online checkout, after you enter your shipping address, data binding saves the address information as you move to the payment step. Because the app maintains the state of the various form fields using data binding, you don't have to re-enter your address information. The payment screen can automatically fill in the shipping address by binding it to the data from the previous step. Data binding in Blazor isn't just about connecting your app to data. It's about creating a seamless, interactive experience for users. By using data binding, apps can better manage user input, update the UI in real time, and keep data consistent throughout the app experience. Every time you interact with a web app, whether you're selecting a button or typing in a form, something powerful is happening behind the scenes. That power comes from event handling, which gives modern Blazor apps the ability to respond to user interactions, changes in data, or system changes. By using event handling to manage these types of actions, apps are more responsive and handle data and interactions more efficiently. In this video, we will define event handling and its significance in Blazor applications. To begin, let's define event handling as a software development principle and apply this principle to Blazor applications. Event handling is how an application detects and responds to different things that happen, such as user interactions, data changes, scheduled tasks, and system changes. In Blazor, this means that when you interact with an app, that interaction, also called an event, causes the app to run code that makes things happen in response to the event. For example, if you add a task in a task manager application, the app will respond to the event by adding the task to the data store and updating the user interface to display the task. This interactivity makes the to-do list app responsive. Tasks can be added, checked off, or deleted, and the Blazor app responds to these events by running code that updates the data store or the UI. Now, let's explore how event handling works step by step in a Blazor application. Events are handled each time the user interacts with the app. For example, entering buy groceries into the task input field and selecting the Add Task button triggers an event. On the other hand, entering buy groceries in the input field alone might not trigger any events. In this case, the event happens only when the user selects the Add Task button. This event signals the app to run code that adds buy groceries to the task list. The code that runs is connected to the event through a process called event binding. For example, in Blazor, a button might have an on-click directive that tells the application to run a method called addTaskMethod when the user selects the button. The directive binds the button's on-click event to the addTaskMethod so that each time the button is selected, the method runs. After the event is triggered, Blazor executes the method bound to the event. In this example, the method adds the buy groceries task to the task list using the addTask method. The method might do a number of things like check for errors, add the task's information to the data store, and display the new task in the app's UI. Now that we've explored how event handling works step by step, let's explore the key benefits of using it in Blazor apps. Event handling enables apps to respond instantly to user inputs, such as button clicks, form submissions, or typing. This immediate feedback enhances the user experience by making the app feel more responsive and interactive. Without event handling, every change to the app or user interaction would require a full page reload or a round trip to the server to handle the app's updates. This would lead to slower, less responsive applications. Another benefit of Blazor's event handling is that apps can easily associate specific methods or logic with individual user or system events. This makes it simple to control user behavior, validate inputs, or trigger specific workflows, all within a well-organized structure that's easy to maintain. For example, event handling enables Blazor to selectively update only the parts of the user interface that have changed. Without it, the app would have to rely on older, less efficient methods like full page reloads, which would make the app slower and less responsive. Event handling isn't just about reacting to clicks or inputs. It's the foundation of creating seamless, interactive user experience in Blazor apps. Mastering event handling is key to building modern, responsive applications. Every click, keystroke, or mouse movement on a web page can trigger an action that shapes the entire user experience. The secret to creating fluid and engaging web applications lies in understanding how to respond to these interactions seamlessly. Knowing how to handle events in Blazor is a fundamental step in building truly dynamic apps. In this video, we will describe how to handle common user events in Blazor. An event handler is a method that runs in response to different things that happen, such as user interactions, data changes, scheduled tasks, and system changes. User interactions could be as simple as selecting a button or typing in a search box. Event handlers make your app interactive by responding to these events and running code when they occur. Suppose we have a Blazor web app called Event Handling Demo. It has a button called Add to Cart with a title Button Click Example. Below the button is a paragraph element with the text Items in Cart, followed by the number of times the user has selected the button. It also has an input field with a title Input Change Example. Beneath this field, it has a paragraph with the text You searched for, followed by whatever the user enters in the field. Finally, it has a box with the text Hover over the product in it. When a user hovers over the text, the words Eco-friendly product with reusable packaging appear beneath the box. Now, let's examine how to handle 3 common types of user events in this web app. Let's start with the button clicks, which is one of the simplest and most common types of events in Blazor applications. This is the code for the Add to Cart button element. The add-on-click code is a directive that tells Blazor to run the Add to Cart method whenever the button is selected. Notice the button is an HTML element and the Blazor directive is a property of the button. Blazor enables you to handle events similarly, but uses C# and .NET as the event handling code. Let's examine the event handler code next. The event is handled by the add-to-cart method, which increases the value of a variable called card count by 1 each time it's called using the code card count ++. This simple C# code runs when the Add to Cart button is selected. With that background on the basics of input handling, let's explore how we can use the @OnInput directive to handle more customized actions. For instance, this directive can give us more control over what happens when the user enters information into a field on a form. In this example, the @OnInput directive on the input element calls the update search method whenever the user types something into that field. The paragraph element below the input element updates in real time with the text the user enters into the input field. That's because the update search method is called every time the user selects a key on their keyboard. This directive enables us to control what happens when the user inputs data into an HTML element. While you can use the @OnInput directive on any element, it's most useful on elements that accept user input, like the input element or the text area element. Now, let's examine the update search event handler, which updates the @search query value. The update search method updates a variable called search query that we declared elsewhere in the code. The parameter E in the update search declaration holds data passed to the method when the event fires, including whatever text the user enters into the input field. Notice that the @OnInput directive works similarly to the onClick directive in that it calls an event handler method when the user performs some action. In this case, the action is any change to the input element. So far, we've examined handling clicks and input on HTML elements. It's also possible to call an event handler when a user moves their mouse over an item. Let's explore how to handle mouse events. In this code, the div element acts as a container that has a paragraph element inside it. The @OnMouseOver directive on the paragraph element tells Blazor to run the showProductDetails method when the user hovers their mouse over the element in the user interface. The paragraph element below the div element will display the value the showProductDetails event handler assigns to the variable product details. This code references the product details variable using the symbol, similar to how directives reference methods. The element will automatically display an updated value without having to refresh the page. Finally, let's briefly examine the showProductDetails. The showProductDetails method runs when the user hovers over the product. We declared a variable named productDetails elsewhere in the code. This method updates the variable with text that describes the product the user hovered over in more detail. In this case, product details will be given the value eco-friendly product with reusable packaging. Mastering event handling in Blazor enables you to build responsive apps that react instantly to user actions. Properly handling events creates a smooth and engaging experience for every interaction. Imagine crafting an interactive web app where every click, tap, or user input seamlessly triggers responses across different parts of your app. How can you ensure that when a user interacts with one component, the right actions happen elsewhere in the app? You can accomplish this with event callbacks in Blazor, tools that allow components to communicate, respond to events, and share data with precision. Callbacks help you streamline your code, improve data flow, and build apps that are more responsive and maintainable. In this video, we will explain the use of event callback and event callback with tag for event handling. Let's begin by defining a callback and how it functions in event handling code. A callback is a function passed into another function or event handler, which is executed at a specific time or when a certain condition is met, such as an event occurring. Think of a callback like ordering food at a restaurant. When you place your order, you tell the server what you want. Instead of waiting until your food is ready, you go back to your seat and you do something else, such as chatting with a friend or reading a book. Later, when your food is ready, the server brings it to you. In this scenario, your order is like the callback function. It's given to the server and the server brings it back when your food is ready. This way, you can keep doing other things while you wait. In coding, a callback lets your program continue without getting stuck, waiting for a task to finish. Now, let's examine callbacks further by investigating how a child component can send an event to its parent using the type event callback. Event callback is a type in Blazor like int or string that lets a child component send an event to its parent. This is useful when you need to notify the parent that something has happened in the child's function. You can define the event callback type generically or using the t tag or type parameter. By using the type parameter, you can pass data of a specific type with the callback. For example, you can declare a variable as event callback string tag or event callback int tag. These will send string and integer data back to the original function. Let's explore how to use the event callback type in real-world scenarios. In this Blazor code, we first define the button element in the child component. The button uses the @onClick directive to tell Blazor to run the onClick method when it's clicked. The directive is how you bind events in Blazor. You use the symbol before the event name, in this case onClick. The text "click me" appears on the button. Next, we define onClick as a property of the child component. By defining this property in the child, a parent component can interact with this event when the child component is used by the parent. Using Blazor, we can add C# code directly in our .razor files using the @code directive. In this code directive, we define onClick as public, give it the type of event callback, and define it using parameter in square brackets. Now that the child component can trigger an event, let's examine how the parent component interacts with the click event. Using a callback, the parent handles or runs the particular code when the event is sent from the child. Because the child declared the button click as an event callback type, the parent will listen for that event and is able to respond when it occurs. In this code, we add child component as an object in the parent component. Then we pass the handleClick method to the onClick parameter of the child component. This way, when the child component triggers the onClick event, the handleClick method in the parent will be executed. Next, in the parent, we define a code directive that contains the handleClick method. When the button in the child component is selected, this method will run and write button clicked in the child to the console. Notice that the handleClick method is an event handler because it is executed only when the click event occurs. Users can interact with other elements in the parent component, but the handleClick method is only executed in response to the click event in the child component. Now that we've covered sending basic events from child to parent, let's investigate how to use event callback t-tag to pass data along with the event. This is especially useful when the parent component needs more than just a notification from the child. In this example, we create a button with inline lambda expression to call the onValueSubmit invoke async function. A lambda expression is simply a shorthand way to pass this function when the event occurs. We also pass data to the function in the value parameter. This means that when the button is clicked, the data stored in the child component's value variable will be sent to the parent. Now, in the child component's code directive, we add a parameter for the onValueSubmit. We define this as public and give it the type event callback. We also define the private string variable value and assign it the default value Blazor rocks. Now that the child can pass data to the event handler, we need to set up the parent code to receive and handle the data we pass to it. First, in the parent component, we add the child component as an object. As with our previous example, we pass a method to the event we want to handle. In this case, we pass the handleValueSubmit method to the onValueSubmit event, so this method will be called whenever the child submits data. Next, we create a paragraph tag in HTML to display the value the parent received from the child, prefacing it with received value. We reference the child's component value with the @received_value directive. In Blazor apps, the paragraph element will dynamically update each time the child component passes a value to the parent. Finally, we write the parent component's code directive. First, we declare a private string called received_value. It stores the value received from the child. Initially, it's an empty string, but it will be updated when the child sends data. This is the variable we reference in the @received_data directive. We also declare the method handleValueSubmit, which has a single string parameter called value. This method is executed when the child passes the data. The method assigns the data passed to the value parameter to the received value variable. Now, the parent will be notified anytime the child sends data, and the parent will handle it by updating the user interface. Effective communication between components is key to building scalable, interactive web applications. Using Event Callback and Event Callback T enables you to handle user interactions and data flow with greater control and reliability. Smooth navigation between pages is one of the key features that make modern web apps fast and responsive. Routing, a core part of web development, makes this seamless experience possible. In this video, we will define routing and its role in Blazor applications. To start, let's focus on what routing is and how it works in Blazor. Routing is a system that directs users to different parts of a web application by matching the URL they visit to specific content and functionality. Think of a route like directions for an application. Just as an address provides you with a destination, a route tells the application location in the code to go to and run. In a Blazor application, routing helps users move between views. For example, in a Task Manager app, navigating to tasks might display a task list, while task/add opens a form to add a new task. Routing makes this happen without the need to reload the app or even the entire page. For example, when a user visits a URL in a Task Manager app, their browser request first goes to app.razor, which acts as the main entry point. The router then checks if the requested URL matches any of our defined routes. If a match is found, the router directs the appropriate component, binds any necessary parameters, and creates the content for the user to interact with. If no matching route is found, the user is shown a not found page. Throughout this process, various routes are available to handle different tasks, such as viewing the dashboard, managing tasks, and editing specific items in the system. Now that we understand what routing is, let's examine how it functions in Blazor. First, in Blazor, routing works by mapping URLs to components. Recall that components are reusable parts of the user interface, such as a task list or a form for adding tasks. When a user visits a specific URL, Blazor loads the matching component, but only updates the part of the page tied to that component. This keeps the app fast and responsive. Using routing becomes especially effective in single-page applications or SPAs. Traditional web applications were made up of many web pages. As users navigate the application, each page would have to be loaded independently. SPAs are web applications that load a single HTML page and dynamically update content without requiring full-page reloads. When a developer uses routing to build a Blazor SPA, content is loaded when the application runs, and only the relevant parts of the page are updated based on the user's navigation. This makes the app feel smooth and similar to a desktop application with quick, seamless transitions between views. Next, routing doesn't just enable a single page to update specific parts of the page. It also enables the ability to use data parameters to make interactions very specific. For example, with dynamic routing, URLs can contain variables. For example, suppose a user needs to update a specific task in your application. Instead of just routing the user to the edit page, it can also open up the specific task they want to edit. For instance, the route /tasks/edit/open curly bracket task ID close curly bracket opens the edit form to a specific task. The open curly bracket task ID close curly bracket part of the URL lets Blazor know which task to load, making the app more flexible. The need to navigate to a specific component isn't always triggered by a user interaction. Sometimes you need to navigate to a component in code. You can perform this type of routing using programmatic navigation. For example, after a user submits a form, Blazor's Navigation Manager can automatically take them back to the task list. This technique creates less burden on the user and enables you to automate important features when you need to. By combining basic routing, dynamic routing, and programmatic navigation, users can quickly move between different views and perform tasks within the application without unnecessary page reloads. Thanks to Blazor's efficient management of these transitions, web apps feel responsive and fluid, much like desktop applications. Navigating between pages smoothly is critical for creating fast, modern apps. Mastering routing in Blazor will give you the tools to make your application seamless and responsive. Imagine this. You're using an app to book a vacation, check out a new product, or even browse a personalized dashboard. You navigate from page to page, from home screen to detailed views, effortlessly finding what you need. No glitches, no delays. That's the kind of intuitive, guided experience users love. But what if you could build that experience from the ground up in Blazor? By mastering Blazor's navigation tools, you can create apps that guide users seamlessly through each section, making every click feel natural and every transition smooth. In this video, we will describe how to implement navigation using Blazor's built-in routing capabilities. Let's begin by exploring how Blazor maps URLs to components. This is the foundation of setting up navigation in a Blazor app. In Blazor, we use the @page directive to define routes for components. It tells Blazor which URL should display a specific component. Think of a Blazor page as a container divided into compartments. Each compartment holds a different component, like a razor page, with a particular function or display. The @page directive guides Blazor on which component to place in each compartment, organizing the content within the container as you intend. Imagine we have a Blazor app that simulates a shopping application. It has a navigation element on the left side of the page and a single compartment that will load home, cart, and product components when the user selects a navigation item. To start, we write @page, open quotation, /home, close quotation, at the top of a component file like home.razor. This means that when users visit /home, the home component will load and display its content. Blazor knows to load the home.razor component. Think of it as creating a path users follow to get to the home page. Sometimes you need to pass data to the target page in the URL. This is where dynamic routes come in. Dynamic routes enable you to display specific content, such as displaying different products based on their ID. In the product.razor page, we add an @page directive telling Blazor that this page will handle URLs like /product/123 or /product/456. The ID part is a placeholder for any product ID we pass in the URL. For example, if you were running this on your local machine, you might use the URL such as http://localhost:5141/product/123 to get to the product with the ID 123. Below the @page directive, we add an @code directive that contains a parameter attribute. The parameter attribute captures the ID value from the URL. If someone visits /product/123, the ID property will store 123 and use it to load the correct product. Next, let's create clickable links for easy navigation using the navlink tag. This code in cart.razor creates a link users can click to navigate to the home page. The href equals open quote /home close quote part of the element tells Blazor which page to load when the link is clicked. The words return to home between the tags will appear on the page. When users click them, Blazor will load the home.razor component in the right pane of the site. Using this type of routing and navigation, the whole page doesn't have to reload. This is the power of Blazor. While clickable links are useful, there are times where you'll want to navigate users automatically after an event, such as a form submission. Programmatic navigation with Blazor's Navigation Manager allows you to redirect users to a different component automatically after an event. Suppose in our shopping app, we want to redirect the user to their cart after they've added a product to the cart. In a real-world situation, the user would click an Add to Cart button and the app would do some work behind the scenes. When that work is done, the user then can be redirected to their cart. The navigation occurs as a response to an event the background process is finishing. To use Navigation Manager, we first need to include it into our product.razor component. Before the @code directive, we use the @inject directive to tell Blazor to make the Navigation Manager available in this component. We'll give it the name Nav Manager so we can use that name to navigate programmatically. It's like having a controller that can automatically navigate the user to different components. Once we include Nav Manager in the component, we can call the navigate to method on the Nav Manager object. This line of code navigates the user to the /cart page when the application places the order in the cart. Mastering Blazor's routing and navigation empowers you to create dynamic, user-friendly applications. These features are key to building apps that move users efficiently through every part of your application. Every click and page load in an application shapes the user's experience. Mastering advanced routing techniques in Blazor can make your application more efficient, dynamic, and user-friendly, ensuring users always find what they need quickly and seamlessly. In this video, we will discuss advanced routing techniques in Blazor. First, let's explore how to restrict and validate the data users pass through URLs using route constraints. In Blazor, you can apply route constraints to accept only specific data types for route parameters. In this example, the /user part of the URL is the component and /123 is the parameter. Adding a constraint in the route template restricts the type of values that can be passed in the URL. This is done by adding the data type constraint to the route parameter within the component's route definition. For example, to ensure a URL only accepts numbers for a user ID, you specify the integer constraint :int directly in the root. The user ID :int syntax specifies that the user ID parameter must be an integer. If a non-numeric value is used in the URL, for example, /user/abc, Blazor will not match the root, effectively blocking access to the page with invalid data. This constraint enhances both routing accuracy and data integrity. With constraints controlling the data passed through the URL, we can make routes even more flexible. Route templates allow you to create flexible, dynamic URLs that change based on user input. Because the templates are dynamic, the URL can change depending on what the user's trying to access. For example, suppose you're building a blogging web application. Instead of creating separate pages for every blog post, you can define a template that loads different posts based on the URL. This makes your app more efficient and scalable. To make the URL dynamic, you create a route template by defining a placeholder for the part of the URL that changes, such as a blog post identifier. When a user navigates to the page, the placeholder is replaced with the actual value from the URL. This diagram illustrates Blazor's URL routing process from initial request to data loading. The URL /blog/42 matches a route template. The template then extracts the parameter value, setting post ID equals 42, which gets bound to a component's post ID parameter property. Blazor finally executes load blog post with the extracted post ID. Route templates can make your web application dynamic and flexible. However, as your app grows, managing related sections can become challenging. This is where nested routing helps by organizing routes more effectively. Let's explore that next. Nested routing groups related routes under a parent route, similar to how templates create dynamic URLs and constraints validate data. For example, an admin dashboard can use nested routes for user management and settings, keeping everything organized under one parent. This simplifies both navigation and development, especially for larger apps. To implement nested routing, you define a main route and group related routes under it. This keeps your app structure clean and easy to navigate, even as it grows. The diagram displays a hierarchical Blazor routing structure. Starting from app.razor at the top, it branches down to a /admin route, which contains an admin layout.razor component. This admin section then splits into two main areas, users and settings. The users section contains two child routes, a list view and a create view. Similarly, the settings section has two child routes, general settings and security settings. The diagram demonstrates how nested routing creates a clean, hierarchical organization where related features like user management and settings are logically grouped under a parent admin route. This makes the application structure more intuitive and maintainable as it grows. Advanced routing in Blazor isn't just about navigation, it's about delivering a fluid and intuitive experience. By applying these techniques, you're building more flexible and scalable applications that meet user expectations with precision.
So in this lab, we're creating a simple recipe manager. And in step one, we set up the development environment by creating the project. It's a Blazor WebAssembly project. We move to the directory where that project is, and then we're going to start to build our recipe manager. So in step two, we're going to build out the data binding. The first thing we want to do is create a class to hold our recipes. So I've created a recipe.cs file, and then we've got three properties in that class. We've got an ID, a name, and a description, and that'll just be able to hold the recipes once we've created them. The next part of step two is to build out home.razor, and here we just have a navigation element at the top, and then we've got our @code directive in the middle here. We've got a list of recipes. This signifies the class that we just looked at in recipe.cs. So it creates a list of an instance of that recipe class. And then we have another instance of a recipe class called selected recipe. And when a recipe is selected, we're going to set that variable selected recipe to an instance of the recipe that we're passing into that method. We finally have to go to edit recipe. We're going to edit recipe.razor. If this isn't created, we'll create it. We have a navigation element here at the top that's going to navigate to this page, and then use the recipe ID as a part of the navigation. Now what we're doing in the code directive is to set two string variables to recipe name and recipe description. And these are just going to be a part of how we're going to display the recipes when we get to that point in the application. In this part of the application, we're actually going to create a save recipe method. and we're going to write out the recipe name and the recipe description when we do that saving. Now, this isn't actually doing anything meaningful in terms of saving the recipes to a permanent storage or anything. We're just demonstrating how you can use the save recipe method to write the recipe to the console. In the edit recipe HTML block, we have some input fields and a text area and a button, and this will allow us to enter the recipe information using HTML elements that will create that ability to edit recipes once we've included them in the application. So those are our 3 elements that we're going to modify for step 2. Now in step 3, we're going to work with event callbacks, and this just allows us to handle events when users interact with the application. So we're going to work with a few files here. We've got a parent recipe component, and that parent recipe component just references this child component, and the child component is setting this variable on recipe selected to a specific event handler, handle recipe selected. And then in the code block, we have the event handler itself, the handle recipe selected. And again, this is just simply writing the recipe name out to the console to show how it works. But notice that our parent component is referencing the child component. And in Blazor, this will pull in the child component into this parent component. And then when an event is fired, the onRecipe selected is fired, it will use this event handler to do some work for us. So next we'll take a look at child component.razor. This is a little bit more involved. We have a parameter block, which is the event callback, and there's our on recipe selected event. And then we have a private list, which just creates our 2 recipes, and then our select recipe method, and we pass in that recipe ID, which we saw earlier. And this just sets the selected recipe to the first recipe or the recipe ID, if we pass in the ID. And if the selected recipe is not null, then we invoke the async, the selected recipe method on that event. So that's the parent and the child components to enable the event callback so that we can actually interact with our recipe manager in our code. Now in step 4, we're going to work on navigation. So once we have these recipes in the system, how do we move between them and how do we display them on screen? So the first file we're going to look at is recipelinks.razor. This just will give us a list of all the recipes that are available in our recipe manager. Now in here we're creating another list just again for illustrative purposes. In a real application we would only create this once in one part of the application, but here we're just trying to show how this could work. So we create this list of recipe objects. Again, that recipe object is an instance of this recipe.cs class. We're creating a new list, and then we fill it with these recipes. And then we display it using this for each block. Now notice here we're using a nav link element, and the nav link will actually take that recipe, pull out the recipe ID, and then match that to a navigation item so that we can actually see the recipes one by one if we wanted to. What this would show if we were running this application is just a list of the recipes, each highlighted with view details. And then as we click on the view details item, it would take us, using this navigation element, it would take us to that specific recipe. So we have to use the recipe object and along with the recipe.id, which is a part of that recipe object. So in step 4, we saw dynamic navigation, and now we're going to talk about how we route to the specific recipes once we've selected it using the navigation elements that we looked at, that we built earlier. To do that, we're going to create a file. We created a file recipedetail.razor. This is much more involved than the other items, but this has all the information for the specific recipes that we want to take a look at. You'll notice again we have a directive at the top, an app page directive that has the navigation. It's going to be found at the recipe / whatever the recipe ID is that we're trying to navigate to. So in the previous code we set up that routing, and now once we click on the view details element, this is where it should route to based on that navigation. In the @code directive we've got another parameter here, which is the recipe ID. This is the thing we're going to pass into the navigation. We create an instance of the recipe class called selected recipe. We have this onParameter set method, which sets the selected recipe to whatever recipe ID we send in, and then we just print out to the console if the selected recipe isn't found. And then again, just for illustrative purposes, we're showing the list of recipes. We've done this 3 different times in 3 different places, but it's mainly to show how these could work in different parts of the application. In a real application, we would just create this once, or probably pull it from permanent storage and create and store our recipes that way. And then finally, we have an if-else statement here. If the recipe is not null, which means that it found the recipe in the storage, which is the in-memory storage here, we're going to display the name and the description of that selected recipe. Otherwise, we're going to show that recipe is not found. So this is the basis for a very simple recipe manager using all these really interesting elements that Blazor provides. And you can see how we mix some Blazor code with our HTML. We're allowed to use C# code in our Razor pages. These dynamic options help us make a very powerful and interactive app for our users.
Maintaining data consistency across application components is essential for delivering accurate information, including user inputs, real-time updates, and external data. Without proper state management, your app may lose track of critical data, resulting in a poor user experience. In this video, we will define state management and its importance in Blazor applications. Before we investigate the challenges of managing the state in an application, let's define what state refers to. State is the stored data that represents the current status of an object or system. It can change over time in response to different inputs or events. It allows your Blazor applications to manage and share information, such as between user inputs and data from a database. With state, the Blazor app can dynamically display and update information in response to your actions or other events. For example, if you've ever added items to a shopping cart online, you'd expect those items to stay in the cart when you move to the checkout page. Without state management, this data could be lost or become inconsistent. Managing state ensures that data, like the items in your cart, stays accurate no matter where you go in the application. Managing state can be challenging, especially in web applications. Let's investigate 3 common challenges with managing state in applications. The first common challenge is component communication. Different components in the application may need to share and modify the same data. For example, when a user logs in, both the profile page and the nav bar need to know the user is logged in. The second common challenge is data persistence. Sometimes state needs to be kept even if the user moves to a new page or refreshes the browser. Imagine filling out a multi-step form. Without proper state management, you'd lose all the entered data if you navigate away. This can lead to frustration as you may need to re-enter all your information from scratch, which wastes time and diminishes the overall user experience. The third common challenge is real-time updates. Synchronization across components can be challenging with multiple users and may lead to performance issues. Some apps need to update their state instantly. For example, messages in a live chat app should appear immediately without refreshing the page. Blazor is a powerful framework that helps address these challenges. It manages state across components using its built-in features and external libraries to enhance functionality. Let's examine how Blazor handles state management in a simple Blazor login system. When the user logs in, their login status is stored temporarily in memory. This allows the app to keep track of their logged in status while they interact with different parts of the app. Next, the login status is shared across components, so elements like the nav bar and profile page update accordingly. By default, Blazor doesn't retain state across page refreshes. To keep the user logged in after a refresh, the login state must be stored in local storage, session storage, or cookies. These storage methods allow the app to load the user status back into memory when the page reloads, preventing the need for a user to log in again. Finally, when the user logs out, the login state is cleared from both memory and storage. This ensures they are fully logged out across all components and their session is securely ended. Without effective state management, apps can become inconsistent and frustrating for users. Understanding how to manage state ensures your app stays reliable and provides a smooth experience for users. In any modern web app, keeping user data consistent and accessible across different components is key to a smooth user experience. Efficient state management ensures that your app behaves reliably and remains responsive to user interactions. Understanding state management techniques is important for building apps that work seamlessly. In this video, we will describe different state management techniques in Blazor. Let's start with the simplest form of state management, local component state. This involves maintaining a state and managing data directly within a single component. For instance, if you have a form within a single component, you might store input values and validation messages directly within that component's state. When a user fills out the form, the name is stored in the form itself. If the page is refreshed, the data is lost since it only temporarily exists in that component. Local component state is useful when data only matters to one specific component, like when a user types in a text box without needing that information elsewhere. This keeps the data contained, improves component reusability, and avoids the need to add complex data flows for small-scale interactions. For situations where you need to persist state between components, you can cascade them from parents to children. Let's explore that next. In Blazor, cascading values allow parent components to share state with child components without passing data through each layer. For instance, a parent component can manage a user's theme and automatically share it with the child components to adjust their appearance. This method is ideal for sharing themes or user information between related components. While cascading values work well within related components, sometimes data needs to be shared across unrelated parts of the app. This is where dependency injection, DI, comes in. DI is a design pattern where an object's dependencies are provided externally, making the code more modular, testable, and maintainable. It's a flexible state management technique that lets you store shared data centrally in a service. For example, if several parts of your app need access to the same user data, such as a profile name, DI lets you create one user data service that's available to any component that needs it. This way, if the user updates their profile name in settings, the service automatically reflects this change across all components that use it. This technique is best used when multiple components in your app need to share the same information or tools. It keeps your code organized and lets you avoid writing the same code in many places. Finally, when data affects the entire app, application state services manage global state, ensuring consistency across all pages. Application state services provide a way to maintain data across multiple pages or sessions in Blazor. By creating a service to hold state information, you can manage application-wide data, such as user authentication or shopping cart contents, that need to persist throughout the user's interactions. This state can even persist across browser sessions when combined with local storage techniques. For instance, a user's login status must remain the same whether they're on the home page or profile page. Application state services make sure this data is accessible throughout the app. Application state services are best for managing data that needs to be shared across multiple pages or components for a cohesive user experience. They are especially useful when the application's functionality relies on consistent data that doesn't reset as users navigate between pages. Choosing the right state management technique can make or break the user experience in your app. Whether it's a simple component or a global state, mastering these techniques ensures your app remains sufficient and reliable. Managing the state of an application can make or break the user experience. Without a thoughtful strategy, data can become inconsistent, components may not communicate effectively, and debugging can become a time-consuming task. A well-designed state management approach helps ensure that your application remains efficient, maintainable, and resilient as it grows. In this video, we will outline best practices for managing state in Blazor applications. The first fundamental principle in state management is to match state scope to the needs of your components. For data that only affects a single component, local state is often the best choice. It keeps things simple and reduces dependencies. This approach helps avoid the common pitfall of overusing global state. For example, in a form where users enter their names, the data is confined to that form and doesn't need to be shared with other components. By keeping the state local, you reduce the risk of causing state management-related bugs and maintain cleaner, more manageable code. If you do need to share data across components, global state might be necessary. Opting for the appropriate level of state management ensures that components remain isolated when possible, while shared data is efficiently accessible where needed, making your code base easier to maintain. Managing scope is just one aspect of good state management. You also have to think about how to organize the code that manages state. For example, as your app grows, handling state and user interface logic in one place can quickly become hard to manage. The next best practice is to separate state management from user interface logic. This separation improves code scalability and maintainability. UI components can be modified without impacting other parts of the program, reducing the likelihood of introducing bugs during updates. By separating state from user interface logic, components become more reusable. A user interface component can be applied to different data sources or states without modification, allowing for consistent design across the application. Another best practice is to maintain state consistency across user interactions to provide a seamless experience. To keep state consistent across components and user interactions in Blazor, you'll need to maintain shared data across pages, such as user authentication or shopping cart contents. This keeps the state consistent as the user navigates the app. Consistent state also helps avoid race conditions, which is where multiple processes try to update the same data at once, causing errors. By keeping state in sync, updates are predictable and reliable, preventing issues like lost changes. Finally, to avoid state management issues, remember to reset state as necessary, particularly in reusable components. When a component is used multiple times with different data, leftover state from a previous interaction can lead to unexpected behavior. You can reset component state by properly handling lifecycle events, allowing each component to clear previous data triggered by an event or user interaction. This approach makes your application more responsive and consistent for each user interaction. Following these best practices will help you build a reliable and maintainable Blazor app, while avoiding common pitfalls and ensuring a clean state management architecture. Imagine a form that adapts and responds to users, capturing information seamlessly and making each interaction feel smooth and intuitive. Forms like these are more than just fields to fill in. They're essential touch points in any application, and in Blazor, we can build them to be both functional and engaging. In this video, we will describe how to build forms using Blazor components. Let's start by exploring the first Blazor form component, Edit Form. The Edit Form component wraps your form and helps manage user submissions. It links the form to a data model, which is just a way of storing the information from the form. Think of the data model like a container that holds information from the form. For example, suppose we create a form where users enter contact information, such as their name and contact preference type. We'll wrap the form in Edit Form to control how that information is processed when the form is submitted. Let's go through the code step by step. First, we create the opening and closing tags for the Edit Form element. This is the wrapper for the entire form. To connect the form to the data model, we add the model attribute and use a directive that points the property to a C# class that holds user data. In this case, we're setting the form to use the contact information object, which we will define later. The user details class has two member variables, username and contact method, that we can use to set data and get it later when we need it. When we use the directive in the edit form element, we're telling Blazor to store the form data in an object called contact information that we will create and be of type user details. Next, we instruct Blazor to run the handle submit method when the user submits their form data. We'll use the onSubmit event on the form to respond when the user attempts to submit the form. Now that we've set up the form structure, let's explore how the user enters text information in the form. The input text component is used to get text from the user. In our form, we're capturing the user's name in a text field. To do this, we'll create a div element that wraps a label element which describes the field and use the input text element to capture the user's name. Using Blazor, we can connect the input name element directly to the username variable in the user details object. We use the @bind value directive to do this and set its value to the variable in the class. Now, whatever the user types into the input text box for that field will automatically update username in the data model. That's the magic of using Blazor's data binding with forms. Now that we've handled text input, let's add a drop-down list for the contact method. The input select component is used when you need to offer users a choice from a drop-down list. In our form, we'll give the user two options for their contact method, email or phone. Like the input text element, we'll wrap the input select element in a div element and label element that describes the information in the dropdown. In this case, that label is contact method. The input select element has two child option elements, one for each contact method. As with the text input element, the input select value is bound by the contact method property in the user details object. When the user selects an option, the form updates that field in the object automatically. Finally, we'll add a button to the form. When the user selects this button, Blazor will call the method defined in the onSubmit event in the edit form component. In this case, it will call handle submit. We'll define that next. We've captured the username and their preferred method of contact. Now let's explore how users submit the form and how Blazor handles the data that comes from it. When users fill out the form and select submit, we want to process that data. In Blazor, we use C# code to define what happens when the form is submitted. C# code is written inside the Blazor @code component. In this component, we can write C# code to do any work we need in our form. You'll recall that in our edit form element, we instructed Blazor to run the handle submit method when the user submits the form. In our @code component, we'll need to add that method. First, we initialize the user details object and assign it to a variable called contact information. We add the attribute supply parameter from form here to indicate that the variable contact information will get its value from a form. We can now reference any of the member variables in the user detail object using the contact information variable. If we added methods to that object, we would also call those. In this example, we'll add the method that we need to the @code component. We create the handle submit method with a void return type. The method will write the contact information.username and contact information.contact method to the console. Because the information in the user details object is automatically updated when the user adds text or makes a selection from the dropdown, we can simply write their values to the console in the handle submit method. Creating forms in Blazor allows you to easily collect and manage data. Now you know how to use Blazor components like edit form, input text, and input select to build forms and handle form submissions. When users submit forms with incomplete or incorrect information, your application's functionality and reliability can be at risk. Without effective validation, forms can introduce errors that potentially frustrate users and challenge developers. That's where robust form validation comes in. It ensures that the data your application collects is accurate, complete, and secure. In this video, we will explain how to implement validation in Blazor Forms. To begin, let's explore how to use data annotations for basic validation. Data annotations are attributes you can add to your data model to enforce validation rules, such as required fields or valid email format. These rules ensure that the user provides necessary and correct data before submitting the form. In a form where users provide their name and email, you can ensure these fields are correctly filled by using data annotations. Imagine we have a class called User Details that holds contact preference information like the user's name and email address. The class acts like a template for creating objects, and in this case, it provides a blueprint for organizing and storing the user's information. Now suppose we wanted to make the username required. In other words, we wanted to make sure the user enters data in the username field before they can submit the data in the form. We can use a data annotation to mark the username field as mandatory. If the user leaves this field blank, the form will display an error. We'll update the class to include the data annotation required along with a message that the app will display if the user leaves the field blank. In this case, we'll display the message, "Username is required." We can also add validation for the email field. By using the email address annotation, we can make sure the email address the user enters follows a proper format, such as example@domain.com. If the user leaves the email field blank or doesn't use a properly formatted address, the app will display them the message, "Invalid email address." Now that we've set validation rules using data annotations, let's discuss how these rules are enforced in a Blazor form. Blazor uses special components to enforce validation. Here's how to connect the user model to a form and display validation errors. We use the edit form element in Blazor to hold the form fields. This form element is bound to the user detail object and will call the handle submit method when the user submits the form. If we didn't want to use data validation, we'd trigger the handle submit method using the onSubmit event. But notice here that we use the onValidSubmit event to trigger the handle submit method. This is a special event in Blazor that tells the app to check for any validation annotations and submit the data only if the data is valid. Before we can actually perform data validation and display error messages to the user, we have to add two components to the edit form element. The first component is Data Annotations Validator. This component scans the model for validation attributes like required, string length, and email address, and enforces those rules when the form is submitted. If a property doesn't meet its requirements, Blazor will trigger validation errors, and these errors will be displayed to the user. Next, we can use the validation summary component to display a summary of all errors at the top of the form. If there are multiple errors, it lists all of them so the user knows what to fix. In this example screenshot, the user left the name field blank and didn't format their email address properly for the email field. The app displays the error messages at the top of the form. Implementing validation in Blazor Forms is about more than preventing errors. It's about enhancing the overall user experience and safeguarding data quality. By using data validation in Blazor, you can build forms that guide users towards entering valid information and protect the integrity of their data. Handling forms efficiently is about more than just collecting data. It's about ensuring that the process is smooth, secure, and intuitive for users. When your forms are well structured and reliable, you not only improve performance, but also build trust with your users. In this video, we will identify best practices for handling forms efficiently. Form handling involves collecting, validating, and processing user input, like names, emails, or payment details. The first best practice is to structure your forms in Blazor with proper handling logic, ensuring they run efficiently and are easier to manage and are protected against errors and security issues. This organization ensures that the form behaves as expected and allows you to build forms that are easier to manage and scale. For example, if you're creating a feedback form, use Blazor's form components like edit form, input text, and input date to streamline the process. These components help you structure the form with built-in validation and event handling. Another best practice is to apply the separation of concerns pattern. Separation of concerns keeps your code organized by dividing responsibilities between form logic and business logic. Form logic focuses on handling user input and validation so that each field receives the correct type of data and that all required fields are completed before the user submits the form. Business logic refers to what happens after the application has collected the input, such as saving feedback into a database or processing customer payments. Separating these parts of your application makes your code easier to read, maintain, and troubleshoot. Next, organizing your form data using a view model creates cleaner code by separating the form structure from the logic that manages the data. This makes the form easier to maintain and keeps your code base more organized, especially as forms grow more complex. A view model is a helper object that takes complicated data from your program and organizes it in a simpler way that makes it easier to display on screen. View models help enforce the separation of form logic and business logic by acting as an intermediary that holds the form data without being directly tied to how the data is stored or processed. For example, the view model would store the user's input in a feedback form, such as their rating and comments. The form logic ensures that the customer fills in the required fields correctly and that the fields have valid formats. The business logic saves this information to the database. With the view model organizing the input, you can adjust either the form or the business logic without disrupting the other, keeping everything neat and easier to manage. The next best practice is to apply validation attributes when structuring form handling logic. This guarantees that users provide the correct information in each form field. Validation attributes are built-in rules that confirm that data meets specific requirements before the form is submitted, preventing errors. By setting these attributes on form fields, you can create a layer of protection that guides users to submit accurate information. These attributes act as rules on form fields to ensure users submit the correct information. Validation attributes include built-in options like required, which requires the user to fill out essential fields before they submit the form. Other built-in validation attributes, such as email address, check that the field is formatted like an email address. When built-in attributes don't cover unique needs, you can create custom validation attributes to set additional rules, like requiring a password to meet complexity standards, for example. Finally, it's a best practice to manage form submissions by implementing strategies that prevent user errors and foster reliable data. First, validate all fields before submitting the form so the data is complete and accurate. For example, if the field needs to contain a number rather than text, you can validate that before the user is allowed to submit the form. This can prevent data errors later. Next, once you've validated the form data, disabling the submit button or displaying a loading indicator can prevent the user from submitting the form repeatedly. Multiple submissions can lead to duplicate entries, so it's best to take steps to prevent this. Lastly, use an asynchronous submission process. This allows the form to be submitted in the background, keeping the page responsive and giving users a seamless experience. Together, these actions help create a smooth, reliable submission process, enhancing data accuracy and user satisfaction. Successfully handling forms isn't just about technical execution, it's about creating a smooth, user-friendly experience. By organizing form logic, applying validation, maintaining form state, and ensuring secure submission, you'll build forms that are efficient, reliable, and user-centric. Following these best practices sets the foundation for better form management in any web application.
In this lab, we're creating a feedback form system so people can enter feedback and we can display that feedback to users. In step one, we're simply setting up the project. We're calling the application feedback app, and we're using the Blazor WASM template to do that. So to get started, I'm going to check my .NET version just to make sure I have my environment set up correctly. So I'm going to use the .NET version command, and this should just give me the .NET version. I'm on version 8.0, which is great. The latest version as of this recording is 9.0, but 8.0 is going to work great for our purposes. So now that we have the class created, we can move on to step 3 and actually create the form. So I've got a Blazor file here called feedback form, and you can see that it's using the edit form tag to create this form. And we've got some submit handlers here, so when the form is actually submitted, it will run that method. And then we've got some div tags in here that we're going to use to capture our feedback. So what we're going to do is bind each of the input fields to a specific property in our feedback class. So we're going to use the feedback class to capture the information that we need, and you notice that we do that down here in the code directive. We create a new instance of our feedback class called feedback, and we also have our method for handling the submission of that form, which we saw above. Now that we have the class created, we can reference that in our div elements up here above in the HTML section. And so for each of the binding values, you can see the ID is next to it. We have the ID name, ID email, and ID comment. And then we're going to reference that feedback class that we created below in the code directive, and then the properties for each one. So get feedback.name, feedback.email, and feedback.comment. And that's possible because we've created that feedback object in the code directive below. So then we can, essentially provide a label, which is the comment, colon, as an example. And then we've got the text input area, which is for comment. We bind it to the feedback object and the comment property of that object. And then we have a validation message in case something goes wrong. Now in step 4, we're going to add state persistence. So state persistence just means that whatever feedback items we add in one session, if we refresh the browser or close the browser and come back, we can get that feedback in the next subsequent sessions. So in order to do that, we're going to create a service called feedback state, and we'll do that in another class file here. So I created a feedback state.cs file, and we've got those items, the state persistence in this section. We're using a specific runtime called the IJS runtime, which will help us just essentially serialize to and from JSON. What I've done here is created an object at the very beginning of the class called feedback state, and I'm just referencing that runtime so that we can use it in the rest of the methods. In the save feedback async method, this is essentially allowing us to save the feedback items to local storage by using a serializer, the JSON serializer. We're going to invoke that runtime using the local storage.set item element of that runtime. So this will essentially allow us to save it to local storage as JSON in the JSON format. Now that allows us to save. The next method is load feedback async, which allows us to load whatever we saved to local storage back into our data object, and then we can use that again in our application. So you'll notice that this method uses the same runtime, the JS runtime, and it's going to pull from local storage. Instead of saying set item, we're using the get item method. If the string is null or empty, then we provide a new list which contains feedback items. Otherwise, we deserialize the list into a feedback list object of the JSON items that we got from local storage, and we'll return that feedback to the application so that we can display it to the user. So then in step 5, just what we'll do, we'll display the feedback, and we've created a feedback list page to display that feedback. In the HTML section at the beginning of the file, we have a for each loop that creates a list item of all the feedback items. We've got the name, email, and comment. Notice that we're using that feedback object again. And we create that feedback object under the @code directive. We create a list of feedback list items. It's a new object, which is a list of feedback objects. And you can see in the for each block above, we're looping through the feedback items in feedback list items. So that object holds a list of things. We're creating an instance of each of the items in the variable feedback. And then we can reference the individual items from that list by dot notation, feedback.name, feedback.email, and feedback.comment. So here we're getting the feedback when the Blazor page loads. We're loading the feedback into this feedback list items object, which is a list. And then we use that list in this for each block to display each of the individual items. So this allows us to display the feedback to the user as we need to. So this is a very simple feedback list item, which allows for not only creating and displaying feedback, but also persisting it to storage so that we can save it and retrieve it as we need between sessions.
Mastering data binding, event handling, and state management in Blazor is essential for creating robust, interactive applications. These skills will empower you to build apps that respond smoothly to user actions, manage data efficiently, and provide a seamless experience. Understanding form handling and validation best practices ensures that your applications are user-friendly but also secure and reliable, giving you the confidence to build more advanced and scalable projects. We began by discovering data binding in Blazor, showing how it links the user interface to the underlying data, enabling the creation of dynamic and interactive applications. Next, you explored event handling, examining how Blazor processes user actions and triggers the appropriate responses in your applications. Then, you examined routing and navigation, focusing on structuring and directing users smoothly through your Blazor applications. Next, you explored state management techniques to ensure data consistency throughout your Blazor applications. Finally, you reviewed the best practices for form handling and validation, ensuring that your forms were efficient, user-friendly, and secure. As you have discovered, mastering data binding, event handling, and state management is essential for creating smooth, interactive Blazor applications. Using best form handling and validation practices ensures your apps are efficient, secure, and user-friendly. In this module, you'll explore Blazor's two primary rendering models, server-side and client-side, to gain a solid understanding of how each function and their roles in web development. We will begin by exploring Blazor's two primary rendering models, server-side and client-side. You will gain a clear understanding of how each model operates and its distinct roles in web application development, setting the foundation for choosing the right approach for your project. Next, you will discover real-world scenarios where server-side Blazor excels. By examining various use cases, you'll see how this model enhances performance, handles complex data interactions, and improves user experience in specific types of applications. Following that, we'll focus on client-side Blazor, where you'll discover how this model enables more responsive, dynamic interfaces. Through practical examples, you will discover how to leverage client-side Blazor for creating highly interactive applications that run entirely in the browser. Then, you will examine hybrid rendering approaches in Blazor, combining the strengths of both server-side and client-side models. You'll learn when and how to apply hybrid rendering to balance performance, scalability, and real-time responsiveness. Finally, we'll focus on performance optimization techniques to ensure your Blazor applications run smoothly and efficiently. You'll gain knowledge of best practices for reducing load times, improving responsiveness, and ensuring your applications can scale effectively. By the end of this module, you'll confidently choose and implement the best Blazor rendering model for your projects. You'll be ready to build efficient, scalable web applications from understanding server-side and client-side approaches to optimizing performance. Let's begin. Have you ever wondered how web apps instantly reflect your actions, like when you add an item to your cart and it appears immediately without refreshing? This process is called rendering, and in this video, you'll learn how Blazor uses rendering to keep its user interface, UI, in sync with the app's state and logic in real time. In this video, we will describe what rendering means in the context of Blazor applications. Let's begin by explaining what rendering means. Rendering is the process of generating a user interface, UI, based on the application's state and logic. It ensures the UI stays up to date. Rendering ensures users get a fast, smooth experience. On a shopping site, applying a filter updates the product list instantly. If the page reloads slowly, users may lose interest and leave. For example, a user browsing a product page finds an item they'd like to purchase and decides to add it to their cart. When the user clicks Add to Cart, the application checks for any state changes. If a change is detected, the app initiates a re-render, ensuring that the interface stays synchronized with the latest state. After adding the item, the state updates, and now the cart icon has a +1, reflecting the added item instantly. The rendering process provides a smooth, real-time update without needing a full-page refresh, enhancing the user experience. To build the UI, Blazor uses components, independent parts of the interface, such as a product list or cart summary. When items in the cart change, only the cart component updates, while the rest of the page remains unchanged. Next, Blazor uses two types of rendering to manage the UI: initial rendering and re-rendering. Initial rendering occurs when the app first loads. For example, when a user opens a product page, Blazor sends all relevant components together, such as the product list, filters, and cart. Re-rendering happens when part of the app updates based on a state change. For instance, if a user adjusts the quantity of an item in the cart, only the cart component updates without reloading the entire page. To make updates more efficient, Blazor uses a virtual version of the UI to compare the current screen with the necessary changes. This approach updates only the necessary parts, keeping the app fast and responsive. For example, when a user applies a new filter, only the product list updates, while the rest of the page remains unchanged. Finally, Blazor employs two rendering models that determine how updates are processed: client-side rendering, CSR, and server-side rendering, SSR. Server-side rendering, SSR, generates pages on the server and sends them to the browser. This approach ensures that content is readily available and optimized for search engines. However, interactions such as applying a product filter can feel slower, as each change requires server processing before sending the updated content back to the browser. Client-side rendering, or CSR, on the other hand, lets the browser handle updates locally. With CSR, clicking a product filter instantly updates the product list without waiting for the server, creating a smoother user experience. Rendering ensures that every change in an app's state is reflected seamlessly on the screen, creating a responsive and dynamic user experience. Understanding how Blazor handles rendering gives you the foundation to build UIs that update efficiently and enhance the user experience. You may have noticed some websites feel instantly ready the moment you open them. That seamless experience often comes from server-side rendering, SSR, a process where the server generates the page and sends it to the browser fully prepared so content is ready to view right away. In this video, we will explain the core principles of server-side rendering. Server-side rendering, SSR, is the process of generating a UI on the server and delivering it to the client. The server collects data, builds the HTML content, and sends a fully rendered page to the browser for immediate display. This approach enhances load times, boosts search engine visibility, and enables smooth interactions by keeping content consistently updated across user sessions. SSR also ensures data freshness by updating the page with the latest content on each request. To understand how SSR stands out, let's explore the mechanics of rendering and the key differences between SSR and client-side rendering. Rendering refers to the process of displaying content on the server, and it can happen either on the client, the browser, or the server. Client-side rendering, CSR, server-side rendering, SSR. In client-side rendering, CSR, the browser builds the page directly on the user's device. For example, when shopping online and applying a filter to display only products under $50, the product list updates instantly without reloading the page. In server-side rendering, SSR, the server builds the page and sends it ready-made to the browser. A news website is a good example. When the page loads, the latest headlines are already in place, so you can start reading right away. But the browser and the server play important roles in rendering content, each contributing to how users experience a website. For applications that rely on delivering content quickly and efficiently, the way the server prepares and sends the page plays a particularly significant role. SSR allows the server to gather the latest data, build the page, and send it for immediate display. SSR is especially valuable for content-heavy applications as it ensures updated information displays right away without needing additional requests. By reducing the load on the browser, SSR helps create a faster, more consistent experience across devices and connection speeds. For instance, when you open a product catalog, the server collects the latest product details, prices, and availability, builds the page with that information, and sends it to your screen. As soon as the page loads, everything is ready to explore. No extra loading is needed for images or product descriptions. SSR can work in conjunction with mechanisms like sessions or cookies to ensure user-specific data is available across requests. So user-specific data like login status or shopping cart items remain consistent across sessions. The server is responsible for preparing and delivering fresh content. If you search for a specific product, like a pair of shoes, the server retrieves the most recent inventory and prices from its database and sends the updated catalog directly to the browser. The client or browser manages the display and handles additional interactions. Once the catalog loads, the browser manages actions like sorting or filtering products, requesting additional data from the server only when needed. For example, clicking View More prompts the browser to fetch more products from the server and display them instantly without refreshing the entire page. Server-side rendering ensures fast load times, better search engine optimization, and a smooth, consistent user experience. By preparing pages on the server and supporting real-time updates and state persistence, SSR keeps users engaged and helps create a reliable, frustration-free experience. Have you ever wondered how some websites feel incredibly fast, almost as if they're responding instantly to your clicks? These quick interactions aren't magic. They rely on a powerful approach called client-side rendering, or CSR. By shifting the workload from the server to your browser, CSR delivers smooth, seamless experiences right from the moment a page loads. In this video, we will explain the core principles of client-side rendering, or CSR. Client-side rendering, CSR, is the process where the browser generates and updates the user interface independently without relying on the server for each change. By taking on this responsibility, CSR enables faster interactions and a smoother user experience. In traditional web apps, the server sends updates for each action, but CSR reduces this back and forth by allowing the browser to handle interactions directly. CSR is especially powerful in Blazor WebAssembly, a tool that allows developers to write C# code that runs directly in the browser. This approach enables apps to operate independently of the server, making interactions faster and even possible offline in some cases. Let's explore how CSR enables apps to work without constant server checks. CSR apps store key files such as HTML, CSS, and JavaScript directly in the browser, minimizing the need to communicate with the server for each action and speeding up response times. For example, a note-taking app can let you keep writing even when offline and then sync your notes to the cloud once you reconnect. This server independence enables smooth, uninterrupted interactions and supports offline functionality. CSR also allows you to create highly interactive and dynamic user interactions. Since the browser is responsible for rendering, it can instantly update the UI based on user actions like filtering or sorting items, without waiting for server feedback. For example, an e-commerce site lets users quickly filter products by category or price without reloading the page, providing a smoother, more responsive experience. Because CSR reduces server demand, it can help apps scale to a larger number of users more efficiently. The server only needs to handle initial data requests and any critical updates rather than each interaction, making it easier to accommodate a growing user base. A social media app can handle thousands of users scrolling and liking posts without overloading the server, as most interactions are managed within the browser. While CSR has many benefits, it also comes with some notable drawbacks. CSR loads all resources up front, which can lead to a delayed initial load time. Users may experience a few seconds of waiting before they can interact with the app, particularly if the page contains large amounts of data or media. For example, when you open Netflix, it takes a moment for menus and display thumbnails to appear, but after that, everything works quickly since the browser has already loaded the necessary resources. Additionally, CSR can strain older or less powerful devices by placing more processing load on the browser. This can result in slower performance or even crashes on devices that struggle to handle the apps, JavaScript, or data. For example, a complex dashboard might feel smooth on newer devices, but could lag or crash on older phones that can't manage the load. Finally, CSR can lead to data consistency issues, as it often stores data locally and might not always reflect the latest information. This can result in outdated content if the app doesn't regularly sync with the server. For example, a stock trading app might display old prices if it isn't frequently updated with the latest data. As users demand faster, smoother web experiences, CSR plays a key role in meeting these expectations. By handling most interactions directly in the browser, CSR makes websites more responsive and reliable, even when the internet isn't perfect. Understanding CSR equips you with essential tools to build modern, high-performing web applications. With Blazor Server, you can build web applications that feel fast, smooth, and responsive, no matter how old or limited the user's device is. This architecture makes it easy for developers to deliver modern apps that perform consistently well for all users. In this video, we will describe the architecture of Blazor applications on the server side. Let's start by exploring how Blazor Server operates and what makes it unique. Blazor Server is a hosting model within Microsoft's Blazor framework that allows developers to build interactive web applications using user interface components in C# and .NET by running components on the server side. This architecture on the server side provides fast, responsive applications without heavy processing demands on the client's device. Think of it like streaming a movie from Netflix, only the display happens on your device while all the processing is handled by Netflix's servers. This approach ensures smooth performance even on older devices because your device isn't responsible for the heavy lifting. Next, let's discuss how the server and browser communicate to stay in sync. Blazor uses real-time tools to ensure that changes on the server immediately appear in the browser without requiring a refresh. This instant connection makes the app feel responsive. Blazor ensures that changes made on the server are instantly reflected in the browser, making applications feel quick and responsive. But how does this happen behind the scenes? That's where SignalR comes into play. SignalR is an open source library for ASP.NET that makes it easy to add real-time web functionality, allowing server-side code to push content to clients instantly. Normally, web apps require a refresh to display new information, but SignalR enables real-time updates without page reloads. For example, in a live sports app, Signal R can update the score immediately in the browser, delivering a smooth, up-to-the-second experience. Signal R ensures the same smooth experience in Blazor by keeping the UI updated with new information as soon as it's available, while the client's role is simply to display these updates. Blazor also uses state management to keep track of user actions across sessions, ensuring continuity. State management allows an app to remember user activity so progress isn't lost even if the page is refreshed. For instance, in an online shopping app, the items in your cart stay saved even if you refresh the page. This keeps the user experience consistent by preserving data and settings throughout the app. Running logic on the server makes Blazor apps both fast and reliable, as the browser doesn't need to perform much processing. Developers can also update the app instantly. Any changes applied on the server appear in the browser without requiring downloads or manual updates. This design keeps Blazor apps efficient, as updates and processing remain server managed while the client handles only the display, similar to how Netflix streams to any device, even older ones. In a world where users expect instant access to information and seamless experiences, server-side Blazor ensures your app is always fast, responsive, and easy to manage. By keeping the logic on the server, it empowers developers to build efficient applications that deliver for everyone, no matter what device they use. Blazor Server is uniquely designed to meet the demands of modern web applications, especially in scenarios where performance, compatibility, and ease of deployment are essential. By running most of the application logic on the server, Blazor Server minimizes the processing load on the client, providing a fast, responsive experience that works well even on devices with limited resources. In this video, we will identify scenarios where Blazor Server is most beneficial. First, Blazor Server's architecture keeps most of the processing on the server, reducing the amount of data sent to the client and resulting in faster initial load times. This setup is particularly beneficial for applications where users need quick access, such as business dashboards or internal tools that employees use frequently. It ensures faster performance, especially for users on slower networks or older devices. Since Blazor Server doesn't rely on WebAssembly, it can run on any device with a modern browser, including those that don't support WebAssembly. This compatibility makes it ideal for applications that need to serve a wide range of devices. For example, customer service tools or public information sites can reliably reach users on everything from desktops to older mobile devices. Additionally, Blazor Server is advantageous for applications requiring real-time data and frequent updates, as changes made on the server are instantly reflected in the client's browser without the need for downloads or refreshes. This makes it ideal for live reporting tools or collaborative dashboards where users need immediate access to the latest information. Blazor Server is an excellent choice for applications needing fast load times, broad device compatibility, and instant updates. These scenarios showcase how Blazor Server provides a consistent, efficient experience for users across a variety of devices and network conditions.
In this lab, we're going to create a server-side Blazor application. Blazor really is about the front end in a lot of ways, but we can use Blazor also on the back end to create for example, a Signal R application, which is what we're going to do in this lab. We're also going to incorporate some state management and session persistence using the local storage library, and then create some custom navigation and links. In step one, we set up the project. We're going to create a new Blazor WASM application using that template. Normally, we would probably not use that template in a real-world scenario, but for the purposes of illustration and for this lab, we'll use the WASM template. And then we'll navigate to the directory and then open the project in Visual Studio Code as a single application, which is what I have here. In step two, We'll start to modify our program so that we can use SignalR in the application. I've installed the SignalR libraries into the app, and that will allow us to use SignalR throughout the application. So you can see here I've got the add SignalR method, which will allow us to be able to leverage the SignalR libraries. Then we're going to use this method called map hub, which will allow SignalR to create a hub where clients and servers can use to communicate in real time. In step 3, we're going to use state management. We're going to show how we can use state management in a server-side app. What I've done here is use the JS interop runtime. This is really client-side code, but we're using it to illustrate how you can talk to the server and communicate with the server in real time using code like this. So we've got some HTML elements here with which the client would see, and we've got some methods, just very simple methods: increment, click, count, save state, and load state, which are what we use to modify some variables and do some work on the client. The other thing I want to point out is what we're using this local storage library, and the local storage library will actually save items to local storage so that between sessions and between browser reloads and all the rest, you'll be able to get that data back. And so it will save the state in this method, task save state, and load the state in the task load state. And what that means is it'll pull data from the local storage and load state and then push it to local storage and save state. In step 4, we're going to just simply create some navigation elements. And so I'm going to go to mainlayout.razor. This just allows us to have some navigational items for the items that we built. So what we have in the href section is pointers to routes that we've set in our pages. So you can see that we have a chat route, a state route, and we would put those in specific pages in our application if we want to route to those. So for example, in state management.razor, this has the route at page state. And then in our main layout.razor, we'll have a navigational item, a link essentially, that will route directly to that page. That's it for this very simple Blazor web application. The main points here are to use SignalR and to use SignalR throughout the application to communicate with the client. And that SignalR allows the client and the server to maintain a constant real-time communication, which makes the app very smooth and the data always current.
Imagine building powerful web applications that run entirely in a user's browser, just like a native app, but without needing JavaScript. How does that change the way we think about building for the web? That's where Blazor WebAssembly comes in, allowing you to leverage C# for fast, interactive client-side applications. In this video, we will describe the architecture of client-side Blazor applications using WebAssembly. Blazor WebAssembly is a hosting model within the Blazor framework that allows you to build interactive web applications using C# and .NET running directly in the browser. It uses WebAssembly, which runs code almost as fast as native apps. Native apps are programs that run directly on your computer or phone. This allows your Blazor app to run completely in the browser, making it fast and responsive. For example, if you're used to building software in C#, WebAssembly allows you to use the same language to create web apps without needing JavaScript. When you start a Blazor WebAssembly app, the first step is downloading the WebAssembly package, which includes everything needed to run the app, such as the .NET runtime, your app's code, and any dependencies. Think of it like opening a photo editor in your browser. Before you can start editing, the app downloads all the necessary tools. Similarly, the WebAssembly package acts as a toolkit, loading into your browser to prepare the app for use. After the WebAssembly package is downloaded, the app begins setting up the .NET environment in the browser to prepare for running. This initialization process ensures that all necessary tools and resources are ready. It's like a photo editor arranging its tools and panels on your screen before you start editing. This setup phase allows the Blazor app to run smoothly once it's ready. After initialization, the Blazor WebAssembly app runs entirely in your browser. The app only contacts the server when it needs additional data, such as loading new information or saving user changes. For instance, once the photo editor is loaded, you can edit photos right away without needing the server. If you need to fetch new images or save your work, the browser briefly contacts the server, but the editing happens instantly within the browser. With Blazor WebAssembly, you're building faster, more seamless web applications, all without the extra server wait time or language switching. It's a game changer for web development efficiency.
Client-side Blazor with WebAssembly allows you to build responsive, efficient applications in C# that run smoothly both online and offline. They instantly respond to user actions without putting a strain on a server. In this video, we will identify the key benefits of using client-side Blazor with WebAssembly. With client-side Blazor, your app can function smoothly even without an internet connection. WebAssembly enables the code to run entirely in the browser, allowing users to interact with the app and save progress offline. A task manager, for instance, lets users add tasks and check their progress offline. Once they reconnect, the server automatically syncs with them. This offline functionality is ideal for users in locations with limited or unreliable internet access. Beyond offline capability, client-side Blazor also makes your app feel faster and more responsive to user interactions. Let's explore how that works. Client-side Blazor enables all interactions to happen directly in the browser without waiting for server feedback. For example, a weather app can instantly display forecasts as users enter their location, eliminating any delay from the server. This immediate response creates a fast, smooth user experience that feels natural and efficient. Client-side Blazor also reduces the load on your server. Running the application on the client's device means fewer requests are sent to the server, which improves scalability. Typically, a web app relies on the server for tasks like filtering and searching. But client-side Blazor shifts this process to the client. In an online store built with client-side Blazor, customers can browse and filter products directly in their browser, reducing strain on the server during high traffic periods. This makes client-side Blazor a good choice for applications with a large user base that benefit from offloading processing to the client side. Finally, client-side Blazor provides a highly interactive experience. With everything happening in the browser, users can engage with features instantly, creating a more immersive experience. A photo gallery, for example, allows users to zoom in on images or scroll through collections without any delay, making the app feel more engaging and responsive. Client-side Blazor with WebAssembly offers offline functionality, full control over application environment, and reduced server load. This creates a more responsive and interactive user experience that's perfect for efficient, scalable applications.
A web app built with client-side Blazor delivers a fast and responsive experience, regardless of complexity or interactivity. It provides a powerful way to create modern, dynamic web applications using C#, even with offline functionality. In this video, we will describe situations where client-side Blazor is ideal. One of the best use cases for client-side Blazor is single-page applications, or SPAs, where fast, dynamic updates create a seamless user experience. Single-page applications, or SPAs, are web apps that load a single HTML page and dynamically update content as users interact with it without requiring full page reloads. Client-side Blazor is ideal for SPAs because all the code loads once and runs in the browser, allowing users to navigate seamlessly. A task management tool, for example, lets users switch between different project boards, view task details, and update statuses instantly without waiting for a full page reload. Another ideal scenario for client-side Blazor is highly interactive applications like a healthcare app, where users can fill out extensive medical forms with dynamic fields. As users input data, relevant sections, suggestions, or validations appear instantly without a page reload, providing a seamless and responsive experience. Client-side Blazor is also ideal for media tools that require real-time responsiveness, like photo editors. Users can crop and adjust images instantly without waiting on server communication, resulting in a smooth and efficient editing experience. Dashboards that display real-time data benefit greatly from client-side Blazor, as updates happen immediately within the browser. A sales dashboard, for instance, allows users to filter data by region or product and instantly view updated charts, all without needing a page refresh. Client-side Blazor is an excellent choice for apps that need to work offline, especially in areas with poor internet connectivity. Running directly in the browser, it allows users to continue working and save their progress even without internet access, with automatic syncing once they reconnect. A travel planning app, for instance, lets users add destinations and notes offline, syncing with the server when back online. Finally, client-side Blazor is a great fit for applications that benefit from reduced server interaction. By handling more tasks locally in the browser, it reduces server load and increases scalability. This setup is especially useful in e-commerce apps, where users can filter products by size or price and get instant results without a page reload. Similarly, product details like memory size or screen resolution load immediately, providing a fast, seamless experience. Whether your app needs to handle lots of data, run offline, or reduce server load, client-side Blazor gives you the tools to make it fast and interactive. Building a web app that loads quickly and stays responsive is essential to user engagement. The good news is you don't have to choose between speed and interactivity. By combining content delivery methods, you can achieve both. In this video, we will define what hybrid rendering is and why it might be used. Before getting into how these approaches are combined, let's first review the two main methods for rendering content. In server-side rendering, SSR, the content of a web page is built on the server and sent to the browser fully prepared. It's like visiting a news site where the entire article is ready to read the moment you click the link. The server has done all the work, so the page loads instantly. This approach is ideal for sites focused on fast-loading, static content, such as articles or images. In client-side rendering, CSR, the browser takes on the task of rendering content. For example, with Blazor WebAssembly, the app runs directly in the browser using C#, making it ideal for applications that need frequent updates and high interactivity. For instance, in an interactive web app, CSR allows content to refresh instantly as users navigate or interact without needing to reload the entire page. Hybrid rendering combines the best of both to improve user experience. Hybrid rendering is an approach where part of the web page is rendered on the server, server-side rendering or SSR, and part on the client, client-side rendering or CSR. By combining SSR and CSR, hybrid rendering offers the best of both worlds: fast initial page loads from SSR and dynamic interactivity from CSR. For example, in an online shopping app, the main page loads quickly through SSR, but CSR dynamically updates features like product recommendations or reviews in real time, making the experience both fast and interactive. Let's explore why hybrid rendering is a powerful approach. First, hybrid rendering enables fast content loading by using SSR to prepare content on the server, allowing pages to load instantly. For instance, in a blog, SSR enables the text of a post to load right away, letting readers start immediately without delay. Second, hybrid rendering improves SEO by using SSR to load content quickly, making it easier for search engines to index pages and rank them higher. Third, hybrid rendering enhances interactivity by using CSR to enable parts of the page to update instantly without a full reload, providing a smooth and responsive user experience. Finally, hybrid rendering increases scalability and flexibility by combining SSR and CSR, allowing developers to balance fast loading with dynamic features that adapt to user needs. Hybrid rendering helps you balance fast loading and interactive features. By combining SSR and CSR, you can build web apps that are both quick and dynamic, giving users the best experience. In today's fast-paced world of web development, delivering efficient, dynamic applications is more important than ever. Hybrid rendering in Blazor offers the perfect blend of server-side power and client-side flexibility, ensuring your app performs smoothly while staying responsive to user needs. In this video, we will describe how to implement hybrid rendering in Blazor applications. In a hybrid Blazor application, you can configure specific components to run on the server using Blazor Server, while others run on the client. Here are scenarios where server-side rendering is ideal. In applications that process sensitive information, such as a healthcare system, components managing patient data or medical records are best rendered on the server. This configuration keeps data secure and minimizes risks. Another ideal scenario for server-side rendering is when components need regular access to server resources, like database queries or complex computations. In a financial app, for instance, a real-time account balance display can be rendered on the server for accuracy and security. Finally, any components that rely heavily on server resources, such as APIs or secure databases, perform more effectively when rendered on the server. Configuring these components for server-side rendering reduces latency and ensures smooth access for essential data. In a hybrid Blazor application, while some components are suited for server-side rendering, others are more effective when rendered directly in the client's browser using Blazor WebAssembly. Here are scenarios where client-side rendering is ideal. For features that can operate independently of the server, such as product filtering or sorting, client-side rendering reduces the number of requests sent to the server, improving scalability. In an e-commerce app, configuring the product catalog to render on the client reduces strain on the server during high traffic times. Another benefit of client-side rendering is offline functionality, allowing users to interact with components even without internet access. In a travel planning app, for example, users can add destinations and notes while offline, with the application syncing to the server once they reconnect. Lastly, for highly interactive components like form inputs with real-time validation or photo editing tools, client-side rendering provides instant feedback and a seamless experience. By configuring these features to render on the client, you can improve responsiveness and usability. With both server-side and client-side scenarios in mind, let's discuss how to combine them in a Blazor application. In an educational app, you could use Blazor Server to handle secure user authentication and manage sensitive data, while Blazor WebAssembly powers quizzes and lessons, allowing students offline access. This setup lets Blazor Server manage real-time data and security tasks, while Blazor WebAssembly provides a responsive experience for activities that don't need continuous server access. By implementing hybrid rendering in Blazor, you get the best of both worlds: server-side rendering for security and performance, critical tasks, and client-side rendering for a fast, responsive user experience. This approach ensures your application is secure, flexible, and tailored to your users' needs. Developers use hybrid rendering to strike the perfect balance between fast loading times and smooth, seamless performance that users expect from modern websites and apps. By blending the strengths of two different rendering methods, they create applications that are not only quick, but also highly interactive. In this video, we will explain the benefits and challenges associated with hybrid rendering. One of the biggest advantages of hybrid rendering is the ability to improve user experience by allowing pages to load quickly with SSR, while CSR manages smooth, real-time interactions. With SSR, the server processes the initial HTML content and sends it to the browser, allowing users to view the page right away, especially helpful for those with slower connections. Once the page is loaded, CSR takes over to enable features like live updates. For instance, on a news website, SSR quickly delivers the main article content, while CSR handles updates to comments and other interactive features without needing a full page refresh. In addition to improving performance, hybrid rendering also boosts scalability by offloading specific tasks to the client. This reduces the server's workload and helps the app handle more users simultaneously. The client-side manager uses interactions and real-time updates, relieving the server from constantly processing every action. In an online store during a big sale, the server efficiently loads product listings, while the client manages customer reviews and interactions. This setup ensures a smooth experience even with thousands of users online. Another major advantage of hybrid rendering is improved search engine visibility. SSR enhances SEO by delivering fully rendered HTML that's easier for search engines to index, addressing a common challenge with CSR-only applications. For example, a restaurant website using SSR can allow search engines to readily index important details like the menu and location, while CSR dynamically updates real-time reservations, improving both SEO and user experience. While hybrid rendering brings several benefits, it also introduces unique challenges. Let's explore the key challenges developers face. One challenge with hybrid rendering is the increased complexity of managing two rendering methods within the same application. Developers need to carefully balance server-side and client-side tasks to ensure they work together smoothly. For example, a blog platform might use SSR to display articles quickly, while CSR manages live comments. Keeping both rendering methods synchronized requires careful planning to avoid inconsistencies. Another challenge is managing state between the server and the client, which can be difficult in a hybrid setup. State refers to an application's current data or status, and if the server and client aren't in sync, users might encounter outdated or inconsistent information. On an e-commerce site, for example, a user might add items to their cart handled by CSR. However, if the server doesn't properly sync this information, the cart could appear empty at checkout, leading to user frustration. Finally, hybrid rendering can make debugging more complex because both server and client components require thorough testing to ensure smooth interaction. Since part of the app runs on the server and part on the client, testing both environments is essential for catching potential issues. For example, in a job application form, SSR might quickly load the form while CSR manages real-time field validation. If there's a bug in the client-side validation, users could unknowingly submit incorrect data, leading to problems later on. Modern web applications face higher demands than ever. Hybrid rendering addresses these needs by combining speed and interactivity while offering ways to tackle its unique challenges. Have you ever quit a website because it was too slow to load or respond? Today, users expect apps to be fast and responsive. If your Blazor app is slow, you might lose users. That's why optimizing performance is so important. In this video, we will identify key factors that impact the performance of Blazor applications. Let's start with load time, a crucial factor in performance, as it determines how long users wait before they can start interacting with your app. The faster it loads, the better the user experience. To reduce load time, you can optimize components by minimizing unnecessary code and files. Think of it like packing lightly for a trip. The less you pack, the faster you can get moving. Reducing unused libraries and compressing large images, for instance, can significantly improve load times, especially in Blazor WebAssembly apps where files are downloaded to the browser. Another factor impacting performance is network latency, or the delay between your app making a request and receiving a response from the server. Every time your app requests data, it waits for the server's response, and frequent server calls can add up to noticeable delays. To reduce network latency, you can minimize the number of server calls needed for your app. Imagine texting less often in a conversation to speed up the responses. In Blazor server apps, reducing server calls decreases waiting time, making responses faster for users. Beyond load time and latency, application size significantly impacts performance. Application size refers to the total size of your app's files, which affects how long it takes to download and initialize. Larger apps, especially in WebAssembly, take longer to load, particularly for users on slower internet connections. Reducing application size involves keeping only essential resources, such as necessary code files, libraries, and images. This streamlining speeds up the loading process, enhancing the experience for all users. Finally, resource utilization affects how smoothly your app runs, especially when managing large data sets or complex tasks. Resource utilization refers to how effectively your app uses memory and processing power, ensuring smooth performance under demanding conditions. Inefficient resource use can slow down your app, causing lag or delays. Optimizing resource use with asynchronous programming lets your app handle tasks in the background, like fetching data from the server, while users continue interacting. This is like multitasking, such as folding laundry while watching TV. Now that we've covered the factors, let's discuss how they impact Blazor Server and Blazor WebAssembly applications differently. In Blazor Server, where the app runs on the server and communicates with the browser to update the UI, network latency plays a significant role. Each interaction depends on a back-and-forth connection with the server, so delays in the network can directly impact responsiveness. Additionally, resource utilization in Blazor Server directly impacts the server's ability to handle multiple users. High resource demands can reduce scalability and slow performance if the server struggles to manage numerous simultaneous connections efficiently. While Blazor WebAssembly apps, which run entirely in the browser, are more affected by load time and application size, these determine how quickly the app loads and become usable for users. For Blazor WebAssembly, resource utilization impacts the user's device directly, so devices with limited memory or processing power may experience slower app performance or higher battery drain. Optimizing resource use in WebAssembly apps ensures they run efficiently across a variety of devices, providing a smooth experience for users. A web app's performance can make or break its success. By improving key factors like load time, network latency, application size, and resource utilization, you can make your Blazor app faster and keep users engaged. Have you ever been stuck in a long checkout line at a store, frustrated by the slow pace? That's exactly how users feel when an app is slow and unresponsive. In today's fast-paced digital world, a slow app can quickly drive users away. Just as a well-organized store makes checkout fast and easy, optimizing your app's performance ensures a seamless experience from start to finish. In this video, we will describe techniques to optimize the performance of Blazor applications. One of the simplest ways to boost performance is by minimizing and compressing JavaScript and CSS files. This reduces the amount of data that needs to load, allowing your app to start faster. This method keeps only essential data, improving initial load times. For instance, compressing images and minimizing CSS can significantly speed up page loads for a blog platform, even when the page has a lot of visual content. Another effective way to reduce application size is by removing unused libraries and resources. This prevents unnecessary bloat and ensures that the app loads only what's needed. For instance, in an e-commerce app that no longer uses a third-party payment library, removing this unused resource helps reduce load times and streamlines the checkout process. After optimizing size, the next step is managing when different parts of the app load. Lazy loading defers certain parts of the app until they're needed, and the code splitting divides your app into smaller chunks that load separately. Both techniques allow the app to load only essential components at first, keeping it fast and responsive for users. In a video streaming app, for example, the video player could load only when a user selects a video, and code splitting can make sure only the homepage components load initially, keeping everything light and fast. Once you've optimized size and loading order, managing your app's data efficiently is essential to keep it responsive. State management refers to how your app tracks data, like user inputs or selections, and ensures only necessary updates occur. Efficient state management prevents unnecessary re-renders, maintaining a smooth experience. In a shopping cart app, for instance, when a user adds an item to their cart, efficient state management ensures only the new item is added without reloading the entire cart. After implementing these optimizations, it's essential to measure your app's performance and identify areas for further improvement. Profiling tools analyze your app's performance, helping you pinpoint specific areas that need optimization. Using profiling and diagnostic tools, like those available in browser development tools, you can identify bottlenecks in Blazor WebAssembly apps and make targeted improvements. For example, in a social media app, profiling might reveal that notifications are slow to load. With this insight, you can reduce load times and enhance this feature. Every second counts when it comes to app performance. Slow load times can frustrate users and lead to lost opportunities. By optimizing your Blazor applications, you not only improve speed, but also enhance user satisfaction and retention, ensuring your app stays competitive in the market. Think of your favorite app. What makes it great? Is it how quickly it responds or how smoothly it runs? Just like a well-tuned car, apps need regular maintenance to keep them performing at their best. In this video, we will explain how to monitor and analyze the performance of Blazor applications to ensure your app runs as efficiently as possible. Monitoring performance helps identify issues like slow load times or high resource usage. Just as a mechanic diagnoses engine problems, monitoring your app helps you spot and address performance issues early. One of the most accessible ways to monitor Blazor performance is through browser developer tools, available in most modern browsers. The Performance tab allows you to record loading times and identify slow resources, such as large images or scripts. This insight helps you pinpoint specific areas to optimize. For example, if a large image takes too long to load, optimizing or resizing it can improve load times and make your app feel faster. Another valuable method is logging, which acts like taking notes on your app's performance over time. In Blazor ASP.NET, core logging captures key data like how long a button click or form submission takes to process. By setting up logging, you gain visibility into events that might be slowing down your app. For example, if submitting a form takes too long, logs can reveal which process or resource is causing the delay, giving you a clear path to improve performance. Profiling tools can provide a detailed view of your app's performance, helping you identify bottlenecks and resource-heavy areas. Using browser developer tools and .NET diagnostic tools, you can pinpoint which functions or components are slowing down your app. These tools work like a mechanic's diagnostic equipment, revealing precisely where optimizations are needed. For instance, if notifications in a social media app are loading slowly, profiling tools can help you identify the exact code or resource causing the delay, allowing you to focus your optimization efforts. Once you've collected data, the next step is to interpret what it means. Analyzing response times, load times, and error logs helps identify where your app may need improvement. For example, if response times are high after a button click, it may be due to a slow API call or a large file. Reducing these resources or deferring their load time can make your app feel much faster. Similarly, errors can act like a car's check engine light, signaling deeper performance issues. If an error repeats every time a page loads, resolving it can significantly improve performance. For instance, if a recurring error occurs during page load, fixing it can reduce the extra work the app is doing and result in faster page rendering and a better user experience. After analyzing your data, consider applying a few key optimization strategies. If large images or scripts are slowing down your app, use lazy loading to prioritize essential resources and load less critical assets later. For example, a large background image can be loaded last while essential text and buttons appear immediately, creating a faster experience for users. Another technique is compressing or resizing large files. Reducing a high-resolution image from 2 megabytes to 200 kilobytes, for example, can greatly improve load times without sacrificing visual quality. This approach ensures that users experience a fast-loading app without missing any key visuals. A high-performing app doesn't happen by accident. It requires ongoing care and fine-tuning. Small improvements made by monitoring and analyzing performance can make a big difference in speed and overall satisfaction.
Imagine waiting for an app to load or respond. It's frustrating, isn't it? We can enhance Blazor app performance by identifying key performance factors, applying optimization techniques, and monitoring performance. In this video, we'll explain how to monitor and analyze the performance of a Blazor application. We're going to begin by creating a new Blazor WebAssembly project, and this will serve as the foundation for implementing performance optimizations. I have my Visual Studio Code environment opened up with a terminal available, and I'm going to create a new Blazor application. I'm just going to call it Blazor Perf App, and I'm using the Blazor Wasm template to do this. Okay, it's created the application, so now I'm going to switch to that folder and then open this up in a separate Visual Studio Code window. Okay, I have my application open. I'm going to open a terminal, and we're going to run this really quickly just to make sure everything's operating properly from the template. It's going to have all the template code, but we just want to make sure the application runs. Okay, the application ran without errors. We're going to quickly just test by going to the location in our browser, and we see we get our Hello World application. This is just all based on the template, and it all seems to be working fine. Okay, so we have our application running. We'll go back to our Visual Studio Code environment. I'm going to stop the application, and now we can start editing. When we think about Blazor performance, it really depends on factors like load time, the network latency that you'll have when you're operating over the internet, the size of the application, and how the application utilizes resources. So if we address these things, we can make sure that our app runs smoother and it's faster for the user. We're going to start by adding a component for testing performance. We're going to call this a hybrid component. In Blazor, hybrid rendering allows the server and the client to work better together. So the application will actually run like a single page application where the user doesn't have to keep reloading the page or going to different pages to do work. It all happens on the same page. So we're going to kind of simulate that using this, this hybrid component approach. So in our app, I have the home page here, the home.razor. It's just a simple page based on the template. And I'm going to add a couple of things here to make sure that I can load data and then test for a specific environment when I'm doing that. Before I add the hybrid component to the home.razor page, I'm going to create a new component called hybrid-component.razor, and I'm just going to put that in the pages folder. In a real-world application, you may want to structure this a little bit differently, but I'm going to create a new page called hybrid-component.razor, and this component will have a bunch of code that will simulate this hybrid environment. Paste that in, and then I'll explain what it looks like when it's in the file. This code is, it has a title hybrid rendering component. It checks to see if data is loaded, if we have the data value full. If not, if it's null, it just gives us a loading message. Otherwise, it goes through each item in the data object, and then it prints it out as a bullet list. Now we also have a code component here, and this is going to create a list data object, and then it's going to use an async task to run when the application is initialized. It does some logging here, which we haven't really implemented yet, but you can see how it will log. And then we have some test data. So we're pre-populating the data object with 3 items of test data: test data 1, test data 2, test data 3. And then again, it logs some information when it's completed. So this is our hybrid component. Now we can inject this component into our home.razor file with a simple line of code. And I'm going to add some things here. So I'm going to change the title, and so I'm going to change the home.razor file a little bit. And I'm going to just simply inject our hybrid component where it says hello world, this right here. And that's just going to inject our hybrid component into our app. Now what this is doing is, instead of having to write all the code in our home.razor file, it's pulling in the code from the hybrid component, and this is going to do all the work for us. This is going to create that visual that we want to see in our application. So now we have a reference to the hybrid component, and that can be served from the server side, or it all can be done on the client side. But in this environment, we just simply have the hybrid component as a file in our file tree, and then we're going to pull that in when Blazor loads. Okay, now that we have our hybrid component in our homepage, what we should see is a list of those items that we listed in hybrid component here. Test data 1, test data 2, test data 3 as a bulleted list when we rerun our program. So I'm going to rerun. It's running without errors. So I'm going to refresh the page. And remember, we put that hybrid component in our home page. So there we have it. We have test data 1, test data 2, test data 3. And remember, that hybrid component is coming in as a reference on the home page. So we can actually do all the work in the component, add it to our home page, and then it shows up here. Let's try to simulate some performance options. There's a concept called lazy loading, which loads data as the page shows up on the screen as the user scrolls, for example. In a real-world scenario, lazy loading would only pull data in from the server as the page is visible. It's called a viewport. The part that you can see in your browser is called a viewport. And as the viewport shows, the data loads in real time. For really long pages where there's a lot of data, that prevents all the data from having to load before the user can see anything. So lazy loading is a very important concept. We're going to simulate that in our app by adding a button to our home page that will load data when I click the button. It won't pull the data in real time. It'll load it as we need it. So I'm going to add a button to our page that will allow us to simulate lazy loading. So I'm going to modify our home page fairly substantially. I'm going to change the title. I'm going to give it a header, and then I'm going to add some code that will simulate that lazy loading approach. Put this into our application. And again, this is on home.razor. In this new code, I've added a header, which we'll see. And then I'm adding an if statement. If the data is loaded, then load the hybrid component. So we shouldn't see the hybrid component when we first load the page. Otherwise, if the data is not loaded, then it's going to show a button that asks to load the data. And again, this is simulating lazy loading. So if hybrid component had a lot of data in it, the user wouldn't have to wait to see anything before that data is loaded. The data would load automatically. Now, in the real world scenario, we probably wouldn't use a button, but for this screencast, we're using the button to simulate that lazy loading. And all the lazy loading button is doing is just setting the is data loaded to true. What we would do in a real world example is check to see that the data has downloaded from the server. Once that completes, once that event completes, then it would show the hybrid component because now we have all the data. But at least the user would be able to see something happening. We could also add a wait message or whatever we need to do there. So I'm going to stop my application and rerun it. And then we'll go back to our home page and refresh. Now, when the page first loads, the is data loaded is false. So we get to see our welcome to our Blazor performance app. Now, here we might show a spinning dialog or something that says that the data is loading. We're going to click our load data to load that rendering component. And now we've got our hybrid component that's been pulled in from the server with all of our data in it. And that's an example of how lazy loading could work. Now I'm going to switch back to the code and look at the logging that we added to our hybrid component. You'll notice here that we have some logging information, and what this will do is actually write to a specific area of the browser that developers can use to track what's happening in the application. You'll see I've added a reference to the iLogger component, and it's essentially creating a log instance so that we can use that logging instance to write information to the browser. There's two things happening here. So when the logging starts, it tells us that it's fetching the data when the application loads. And then we assign our data object to the 3 data items that we've provided. And then we say once that's done, we log another item to the console that says that the the data fetch has been completed. In a real world scenario, if this were a very large data set coming from a server or coming from an API, it might take some time for that data to load. So we can learn in our console that the process has started loading. And then once it's completed, we can see in our console that the data fetch has been completed. So we've already implemented this, and so it should be in our browser already. So I'm going to go back to our application, and I'm going to use developer tools in Microsoft Edge. These are under more tools, developer tools. And you can see I get this little interface here, and there's an interface called console, which is where the logger writes the messages. Now remember when we loaded this, we loaded it from the application and then I refreshed the page. And when I refreshed the page, those messages that we saw that we were writing to the logger will write to this console. It's a little bit hidden, but it's useful for developers. So you'll see that we have our log messages here. There's the fetching data and there's the data fetch completed. Now you can imagine in a real world scenario, if you are loading a large amount of data, you can pull up this tool as the application is running, and we can display the fetching data message. When that data has been loaded, it will show the data fetch completed. You won't be able to see it because it happens so fast on this local app, but I'm going to refresh the page and you can see those messages appear. Now, you don't see the messages yet because we haven't loaded the data. I'll click the button and it happens instantaneously. So since we're talking about managing and optimizing performance in a Blazor app, I'm going to add actually a little delay to this code to simulate data downloading and taking time to download. So I'm going to add a simple delay in between the 2 logging messages. This is about 2 seconds. I'm going to actually make it 4 seconds so it looks a little bit longer. This would simulate pulling data from a server or an operation that might take a little bit of time. Rerun our project. Okay, it's running. I'm going to refresh the page. We don't see our messages yet because we have to load the data. Now we're going to simulate that data loading. And when we do that, you should see the first message that tells us that the data is loading. And after about 4 seconds, we'll see the second message. So you can see it's fetching the data. The delay is happening, and now the data fetch is completed. And that's a good way to watch for performance. So if data is taking a long time to load, or if there's an error, you can catch that between those 2 messages, and you can use logging to improve how your application is performing. These simple operations in a Blazor app helps us to manage performance, and it can help us implement tools that make us better at figuring out where performance bottlenecks are and how we can improve them. In this lab, we're going to implement data binding, event handling, and navigation in a Blazor application. And we're going to use data binding to connect UI elements to application state, which allows for instant refresh of data in the state. We'll implement some event handling to interact with users' input. We'll configure routing and navigation, as well as manage global application state using a shared service. In step 1, we set up the project. We're going to use the Blazor WASM template and create an application called Task Management App. And then we'll quickly run that to show that it works. In step 2, we'll start implementing data binding. I have a file here called taskform.razor, which is where we'll set up our binding. You'll notice in the page that we have this @bind value, which is what we're using to bind the value to a data object. So I have a data object that I've created called taskmodel.cs, and it's a very simple task object that we're using to store data. It has an ID, a task name, a description, and isCompleted fields. And we're binding to those fields in our taskform.razor file. So you'll notice in the @code directive, we create a new task based on that object, that class that I just showed you. And we also have a method where we can add tasks using that method. So in here, once we've instantiated the object, we can then bind it to a specific HTML element called input text, and we bind that value to the object called task and the property called task name, which we saw in task model earlier. So that's how we do binding and bind directly to a data object in our user interface. I also created another class called task service, which is what we're going to use to retrieve tasks, add tasks, and remove tasks. And this is just a very simple class with 3 methods in it that we'll use in our binding to be able to interact with tasks themselves. We don't have that implemented here, but we do have a add task button. And you'll see here that when we click on that button, it calls the method within this code directive, add task, and that add task method calls the task service add task method. So we're actually bringing in that service into this file. We're injecting it here. We're injecting it in this first line, inject task service. And we can use the methods in that task service in our application. So in the add code directive, we then call the add task method that's here, and we pass in the task, and then that will add it to the tasks object. Now in step 3, we're going to implement event handling. So I'm going to go to another file called tasklist.razor, which is where we display our tasks. This has some HTML elements as well, and you can see we have some binding also here on click is bound to the remove task method, which we have as a part of our code directive. When the application or the page loads, you'll see here that we have an onInitialized. And the first thing that this does is it loads all the tasks from the task service. So there's a get tasks method in our task service. That's the first method that we use. And all it does is it just simply returns the tasks that are loaded into the object. And when we go to task list, it will run that as soon as the page loads. And then we can interact with those tasks. So we'll have some buttons here, for example, remove task, call that remove task method, and then it will just remove that using the task service again. It will remove that task from the list. Now the final thing we're going to do in this lab is create a main function and a nested function, and call the nested function from the main function. So I'm going to continue to modify my counter.razor, and I'm going to remove that and create a new function called main function. Create my braces, and then inside this I'm going to call nested function. It's turning red there because we don't have our nested function written yet, so we'll create that next here, and we'll use the IntelliSense, and then in here we'll update that counter like we had in our original code. We'll do current count ++. So now when we call our main function, the main function is going to call the nested function, and nested function will update the count, and we should be able to see that on our page. One thing we can do here is debug it by setting a breakpoint, and I'm going to go into our debugger and run this. I'm going to choose C# as the language, and then I'm just going to choose the default configuration of weather app, and that just sets some properties for our debugger. Now notice this actually won't run. We'll get an error when it tries to build. So this is telling me that we had a build failure. Would you like to continue to run the last successful build? We don't want to do that. The issue is that I changed the method from increment count to main function, and I didn't update the onClick event. So it's essentially telling me there's no method to run when someone clicks the button here. So I'll just have to change this to main function. Since we already set those properties earlier, we don't need to set them again. But it's going to try to build the application. All right, so our application is running, which is great. It built and it's going to run. going to go to our counter page, which is the one that we modified. And now when we click this button, remember that the main function is going to be called. That's the onClick event here. It's going to call the nested function, and I set a breakpoint at this line. So we can see how we can actually debug this by clicking the button. And then we'll go back to Visual Studio Code, and you'll notice that it stopped at that line because that's where I told it to stop. That's what the breakpoint does. And we can check the value of current count. So I'm going to hover over current count, and it should give me the value. If not, I can look in other places. There should be watch lists and other places that we can look at. So I'm going to hover over current count, and you can see the value is 0 because we haven't actually run this nested function even once yet. And we set the current count to 0 initially. So when we hover over it, we just get a 0 because it hasn't changed. Now I'm going to step into the code, which is going to increment that current count by 1. And now when I hover over it, you'll see that it's changed to 1. So I can watch this change as we work through the program. You'll also notice that some of these variables and values are showing up under our variables list, so I can watch that increment each time. So now I'm going to just continue to run the program. And when I click it again, it'll stop at that breakpoint. Current count is 1. And when I step into the application, it should increment to 2. And you can see it's changed there. Current count is 2 and current count is 2. So this just allows us to, in real time, see what's happening in the code and find bugs. So as bugs occur or as issues occur, we can use these breakpoints to stop at any point in our code and try to sort out what's going on.
Understanding Blazor's rendering models is crucial for effective web development. Mastering these approaches and hybrid techniques and performance optimizations empowers you to build responsive, high-performing applications that elevate user experience and scalability. We examined Blazor's two main rendering models, server-side and client-side. You gained insight into how each model functions and its unique applications in web development, helping you make informed choices for your projects. Next, you explored practical scenarios where server-side Blazor excels. Through various use cases, you discovered how this model boosts performance, manages complex data interactions, and enhances user experience in specific applications. Next, we focused on client-side Blazor, exploring how this model enables responsive and dynamic interfaces. Hands-on examples taught you to harness client-side Blazor to build interactive applications that operate entirely within the browser. Then, you explored hybrid rendering approaches in Blazor, blending the strengths of both server-side and client-side models. You learned when and how to use hybrid rendering to achieve optimal performance, scalability, and real-time responsiveness. Finally, we focused on performance optimization techniques to keep your Blazor applications running smoothly and efficiently. You gained insights into best practices for minimizing load times, enhancing responsiveness, and supporting effective scalability. As you've discovered, understanding Blazor's rendering models is key to making informed design choices in web development. By exploring each model's strengths, hybrid options, and performance optimizations, you're now equipped to create efficient, responsive, and scalable Blazor applications. Welcome to using Microsoft Copilot for Blazor development. In this module, you'll discover how Copilot can enhance your Blazor projects from start to finish, writing efficient code, navigating debugging processes, and optimizing performance. By the end, you'll have the skills to build robust Blazor applications with Copilot as your coding assistant. We will begin by learning how Microsoft Copilot can elevate your Blazor development and leverage its advanced assistance for efficient, high-quality front-end solutions. Next, you will examine using Copilot to write Blazor code, discover techniques to generate functional components, automate repetitive tasks, and streamline development. Then you will explore debugging, using Copilot's suggestions to quickly identify and resolve code issues and optimize Blazor applications for smoother performance. After that, you will combine the concepts and skills you have learned to create a comprehensive Blazor project with Copilot, applying Copilot's capabilities to develop, refine, and polish a real-world application from start to finish. Finally, you will complete and submit your Blazor project, which will showcase your Copilot-assisted code and newly refined front-end skills in a final functional application. By the end of this module, you'll have the tools to harness Microsoft Copilot in every phase of Blazor development, streamlining code creation, enhancing debugging processes, and optimizing performance. Let's begin. Tools like Microsoft Copilot are transforming how developers work. They help you code faster and with fewer mistakes while learning as you go. In this video, we'll describe the specific ways Microsoft Copilot aids Blazor development by generating Blazor component code, suggesting syntax corrections, providing inline documentation, and automating repetitive coding tasks. Microsoft Copilot is an AI assistant that helps you code faster by generating, correcting, and explaining your code in real time. This helps reduce errors and speeds up your development process. One essential task in Blazor development is creating components, the reusable building blocks of your user interface. Copilot can generate these components for you, saving you from writing all the code manually. Imagine you're building a product page and need a component to display product details. Instead of writing the structure yourself, Copilot can generate fields for product name, image, and price, letting you focus on customizing the component. As Copilot assists with component generation, it also helps keep your code error-free by identifying and correcting syntax mistakes. In programming, syntax defines the rules for writing code, and it's easy to make small errors, like missing brackets or mistyping a keyword. Copilot highlights these issues in real time and suggests corrections as you code. For instance, if you're building a filter function and miss a closing bracket, Copilot will flag the error and recommend a fix immediately, keeping your code clean and error-free. Beyond fixing errors, Copilot also aids your understanding by offering inline documentation for Blazor-specific features. Inline documentation provides helpful explanations directly within your editor, so you don't have to search for answers elsewhere. For example, if you're using two-way data binding and want to understand how to bind user input to a data model, Copilot can provide a quick explanation right in your editor. This support is like having a guide as you code, helping you learn and apply Blazor concepts on the spot. Lastly, Copilot enhances productivity by automating repetitive tasks, which are common in many development projects. Repetitive tasks include creating similar forms or tables across different pages, which can be time-consuming. Copilot identifies patterns in your code and automates these repetitive tasks. For instance, if you're setting up registration and login forms, Copilot can quickly generate the structure for both forms, allowing you to modify only the unique details, saving time and effort. Imagine how much more you could accomplish with fewer errors, faster coding, and automated tasks. By leveraging Microsoft Copilot, you can improve your productivity, focus on more creative challenges, and make your development process smoother than ever. What if coding didn't have to be a time-consuming, error-prone process? What if you had an intelligent assistant guiding you through every line of code, helping you avoid mistakes and improve your skills? That's exactly what Microsoft Copilot offers for developers, especially those working with frameworks like Blazor. Whether you're a beginner or experienced, Copilot makes Blazor development easier and more efficient. In this video, we will explain the benefits of using Microsoft Copilot for Blazor development. One of Copilot's main advantages is its ability to reduce coding time by offering real-time suggestions and generating useful code snippets. Code snippets are small blocks of reusable code, and Copilot can automatically generate them to speed up your development. This feature is especially helpful for creating repetitive UI elements in Blazor projects. For instance, if you're building a Blazor component, Copilot can suggest a full structure for the @code block or form elements, saving you from manually writing repetitive code. In addition to saving time, Copilot enhances the quality of your Blazor code by suggesting best practices and identifying areas for improvement. Best practices are coding guidelines that help ensure your code is clean, efficient, and easy to maintain, especially valuable in Blazor's component-based architecture. For example, if you're writing a form in Blazor, Copilot might suggest using two-way data binding to sync the UI with your data model automatically, making your code more efficient and aligned with Blazor standards. Another significant benefit is that Copilot helps reduce errors by identifying issues early and suggesting corrections. As you code, Copilot flags potential syntax errors or logical issues, helping you prevent bugs in your Blazor applications. For instance, if you forget to initialize a list in a Blazor component, Copilot will remind you, reducing the likelihood of runtime errors. Copilot is especially helpful for new developers who are still learning how to structure Blazor components and build interactive UIs. By providing relevant suggestions, Copilot guides beginners in structuring and writing their components correctly, helping them follow proper development patterns from the start. For example, if you're unsure how to structure a Blazor component, Copilot can suggest a layout that includes both the C# code and HTML sections, making it easier to get started. While Copilot is a valuable resource for beginners, it also benefits experienced Blazor developers by offering advanced suggestions for optimizing performance and writing efficient code. This feature is particularly useful in larger Blazor projects that require fine-tuning for performance. For instance, if you're optimizing a complex Blazor application, Copilot might recommend using techniques like @key to avoid unnecessary re-renders, enhance performance, and ensure a smooth user experience. As Blazor applications become more complex, tools like Microsoft Copilot can be the key to simplifying your work while improving your results. By using Copilot, you're not only speeding up the development process, but also ensuring higher code quality and fewer errors in your Blazor projects. Wouldn't it be great if code could practically write itself, anticipating your needs, correcting mistakes, and even suggesting best practices as you go? What if you could focus on creating instead of troubleshooting? With Microsoft Copilot, that's possible. This powerful AI tool transforms how you approach coding by turning complex, repetitive tasks into quick, seamless steps. In this video, we will set up Copilot for Blazor development. First, you need a GitHub account. If you do not already have one, you can create an account with a free trial. Once you've secured and/or opened your GitHub account, open Visual Studio Code. Go to the Extensions view by clicking on the square icon in the sidebar or pressing Ctrl-Shift-X or Command-Shift-X on a Mac OS. Search for GitHub Copilot and select the official extension by GitHub, then install it. To get the most out of Copilot for Blazor, writing clear, specific prompts is essential. Here's how to structure prompts for common Blazor tasks. We'll start by creating new Blazor components. Use prompts to specify the functionality or user interface, UI, elements you need. For instance, instead of a general request, try specifying the purpose of the component and what fields or elements it should contain. A prompt like, generate a Blazor component to display a product list with name, price, and image fields will result in a well-structured component with placeholders for each field. This type of prompt helps Copilot deliver code that aligns closely with your project's requirements. Event handlers in Blazor, like those for form submissions or button clicks, are essential for interactive elements. Direct and precise prompts can help Copilot provide the correct syntax and structure you need. For example, a prompt such as create a submit button with an @onClick event that triggers form submission in Blazor guides Copilot to generate a button with an attached event handler. Prompting in this way saves time on setup and ensures the code aligns with Blazor's structure. To enable two-way data binding in Blazor forms, it's helpful to be specific about the @bind attribute and data model you're working with. A focused prompt like add two-way data binding to an input field for capturing user email in Blazor will lead Copilot to generate the input field with the appropriate @bind attribute, allowing for seamless data capture. With this approach, Copilot supports efficient and error-free data binding, enhancing the app's interactivity. Blazor's lifecycle methods, such as onInitialized or onAfterRender, play a vital role in managing component behavior. When you need a lifecycle method, mentioning the specific stage in your prompt ensures Copilot provides the right structure. For instance, prompting with add the onInitialized method to set default values in a Blazor component results in Copilot suggesting code for initializing data as the component loads. This precise guidance helps you leverage Blazor's lifecycle methods effectively. When seeking performance improvements, prompts that focus on specific aspects, such as load time or reducing re-renders, help guide Copilot's responses towards relevant optimizations. A prompt like suggest performance optimizations for reducing re-renders in a large Blazor project directs Copilot to provide strategies suited to Blazor's component architecture. Copilot might suggest techniques or code adjustments to improve performance, enhancing the user experience in complex Blazor applications. Using clear, targeted prompts helps Copilot deliver precise suggestions, enhancing your productivity in Blazor development. The more specific your prompt, the better Copilot can assist with your code, making it a powerful tool for building efficient, responsive applications.
Imagine a tool that doesn't just help you write code, but also understands your development goals, offers suggestions, and can even anticipate your next steps. Microsoft Copilot provides a powerful AI-driven solution to simplify and accelerate this process, helping you develop Blazor code quickly and accurately. In this video, we're going to demonstrate how to use Microsoft Copilot to write Blazor components. Suppose we want to create a simple task manager application that will allow us to create tasks, display them, and check them off as complete. We'll use Copilot to help us get the basic code set up and running. Using Copilot to get the basic application framework set up will enable us to refine it and add features later. We have a basic Blazor application here called Task Manager that has a program.cs file and a Task Manager Razor file. We'll use Copilot to build our app from this basic structure. We'll start by building the data model. We'll prompt Copilot by explaining our setup and the app we're building. Then we'll explain what we need. I'm going to use a prompt that will help get the results that I want. I'm going to switch over to Copilot. Okay, so here I have my prompt. You'll notice that I've explained the structure of the application in a very basic way, told it what files I have, and then I gave it the goal. I want to create a basic task manager application, and I want to start by setting up the data model to store the tasks. And then I describe what that should look like. So we'll go ahead and submit this to Copilot. Copilot responds by providing code and some instructions on where to put it. First, it tells me to create a models folder, and then create a file called tasks.cs inside the models folder. I'll do both of those things in order. First, I'll create a models folder, and then inside I'll create tasks.cs. Copilot also provides me with the code that I need to put inside tasks.cs. So I'll copy that file and I'll paste it into my file. With that in place, I'll next prompt Copilot to create the data service I'll need to manage, create, delete, and complete tasks. I'll task Copilot with another prompt. Now notice I can keep the conversation with Copilot going. So I'm going to go ahead and paste in the new prompt, and we'll send that to Copilot. Copilot responds with code and instructions. It tells me to create a new folder called services in the project root. I'll do that first. Create a services folder. And then it tells me inside the services folder to create a new file called taskservice.cs. Let's do that next. Copilot also gives me the code that I need to put into this file. So let's switch back to Copilot and grab that code, copy it out of the tool, and then paste it into my file. Okay, so far so good. We've got our task service file and our model tasks.cs file. One thing I'm going to do is change the namespace for, I'm just going to make it all Task Manager app. So this is one thing that you'll have to look for if things aren't compiling properly. It could be a namespace issue. So I'm just going to change all these to use the same namespace. It can find all the files. Now you can see all those red lines went away because now it's able to find all the files in our namespace. So those are things that with Copilot you'll have to look for every once in a while. Things just may not work exactly the way you want them to. Now let's go back to Copilot and see if we have any other instructions. The next thing that Copilot tells me to do is to register the service in program.cs. We're going to have to go back to our program.cs file and make some changes. And I'll have to be going back and forth between Copilot and our file to make sure that we get all of our things in place. As I look over this Copilot recommendation and I look over our program.cs file here, we have most of the things that we need, but we're going to add a scoped task service call here, a method. So I'm going to go ahead and copy just that line out, grab that line, and I'm going to paste that below where the builder has already been declared. So if I go back into my file, you can see under builder, paste it right under here. And because we already have our namespace declared, we don't have to worry about our application finding our task service. Now we'll work on the user interface. Now that Copilot understands how my code is structured, I can give it a simple prompt to generate the code that I'll need for the UI. Paste in another prompt here and tell Copilot what we want to do for our UI. I'm going to ask it to build the user interface for adding and deleting tasks and marking tasks as complete, and it should give me some UI I can use for that. We're going to add some code to taskmanager.razor. So in the taskmanager.razor file, we're going to inject the task service. So I'm going to copy this out, paste it into my taskmanager.razor file. So we've got that now. Notice here that I have taskmanager app.services. Since we've changed the namespace, I'm going to remove that piece of it so that I'll be able to find service. That's able to resolve that. Let's go back to the next step. We're going to add a component state. And a component is a Blazor block of code that does work for us. So we'll go ahead and copy that out, and I'll put that in my file below where we added the previous code. Now we've got the component in there, the code block, which has these three methods: add task, delete task, and complete task, which is what we asked it to do. So these are the methods that the user interface will use to do the work that we need it to do. Let's go back to Copilot. And now we're going to construct the UI from a form. And so we'll construct the form by adding new tasks and display the list of tasks according to Copilot. So it's giving me the HTML that I need, along with some code that will build the UI for me. So I'm going to copy this out, and I'm going to paste that in below the code. Actually, I'll put it in above the code. It's a little cleaner that way so I can see my UI first. Okay, so now we've got the user interface items in our task mgr.razor file, and along with our code block that will do the work once we perform these tasks. For each task item, there's going to be a isCompleted, which has the onClick method that calls complete task, which is down here. We also have another onClick button for deleting a task. These are going to allow us to do the work that we need to do in the user interface. We also have another button up here in the top portion for adding a task, which is also one of the methods that we added previously. Now we're going to go back to Copilot and see if there's anything else we need to do to add to our file. All right, so it tells us that we have a basic UI for managing tasks, so we can move on to the next step. Okay, so the last thing we're going to do now is run the project. I'm first going to just build it just to make sure everything builds correctly without any errors. We have in green there the build succeeded, so we're good to go. So now we'll run it. And I'm going to hold down my control key and click the link that's there in the output, and it will take us to our home page. This was from the template that the builder gave us. So we'll go to our task manager route. You can see we have our interface that Copilot gave us. I'll put in a task here and a description. And then we can click the button and that should work. So it gave us our task 1, my first task. So it's the name of the description. We can check it off to complete it, and we can also delete it. Now you can see this is a very simple task manager app, but we use Copilot to essentially build the whole thing. And now we can use Copilot if we wanted to continue to refine and tweak this application. And by using Copilot, you can speed up your development efforts and build apps quicker and more efficiently. Before AI tools like Copilot, developers had to search the internet for information and sample code they needed. Each time they had a question, then they have to do another search. One of the most powerful features of Copilot is its ability to converse with you. You can refine your questions and give feedback on its responses. It's this conversational aspect that can greatly increase development speed and reduce bugs and issues. In this video, we'll explain how to refine and customize Copilot's code suggestions. Let's suppose we have a task manager app written using the Blazor framework. We started the app by setting up the data model and services, but we haven't built the user interface yet. We'll work with Copilot to help us build the application we've started to construct a user interface we're happy with. We'll start out by describing our project and what we need for the user interface. Since the user interface will need to interact with the services we have, I'll paste the code for that file into my prompt. I'll ask Copilot for what I need using the following prompt. So I'm going to switch over to Copilot, which I have running in the background, and I'm going to put in my prompt here. I'm telling it that I have this service already, so I'm going to go back to my code in my Task Manager app. I have this task service which describes kind of the structure of the application and some of the objects that we're using. So I'm going to select all of the code from the file, and I'll copy that, and then I'm going to go back to Copilot, and I'm going to paste that into Copilot so it knows this is the structure of the application. I'm also telling it that I want to put the user interface elements in a file called taskmanager.razor, which I have here in the pages folder, taskmanager.razor. Okay, so let's submit this prompt to Copilot and see what it comes back with. Okay, so it recognizes the file and it says, sure, we can get this started. It's going to give me some code, some user interface code that will allow me to add, delete, and complete tasks and display all the tasks and indicate which ones are completed. So it provides all this code for me that I'm going to put right into my taskmgr.razor file. And I'm going to click the copy button so it puts it on the clipboard. And you'll notice here at the bottom it also explains all of the code that it's provided. Now I'll go back to my application and I'll open my empty taskmanager.razor file. Okay, so now we have that into our file here, and this should interact with the service that we created. Now notice we've got a lot of red lines here. So it's injecting the task service. What I want to do is create the namespace, actually add the namespace that I have in my services file. You'll see that I'm using Task Manager app. So I'm going to go back to my Razor file and I'm going to inject the Task Manager app task service. Now that I've copied over the text from Copilot, I've switched over here to my taskmanager.razor file, and I'm going to paste that code into the Razor file, and this gives us our user interface. And it gives us the ability to add, delete, and complete tasks. You'll notice that it added HTML here at the top, created HTML here at the top, which we've added, and then a code directive, which has all the methods that we'll use to do the work that we need. Now that we have the basic user interface, we can run this app and just see what it looks like. So we can work with Copilot to improve it if we don't like the look and how the app operates. Run this application. Gives me a few warning messages that we can ignore. And then it outputs some information that will help us locate the app. So you'll notice if I hover over what it's listening on, I can hold down the control key. When I click on that, it'll open the application up in my browser. That's going to take us to the home page because this is the initial route that it takes us to, but you remember we put the task manager in a file called taskmgr, which is also the route, and it'll load that page for us. And now we have the interface that it created. So we can add a task along with a description. Click task, And then it gives me the task along with the description, a checkbox, and a delete button. If I check the box, it crosses out the task, which is handy, and I can also delete that task if I want. So everything appears to be working as we expect, but it doesn't really all look all that great. We're going to ask Copilot, the tool, to help us improve this just a little bit. The first thing we'll do is ask Copilot to improve the code by making the buttons look a little bit more modern. They look a little bit dated, so we're going to ask it to modernize the buttons, and that will help our app look better. I'm going to prompt Copilot by asking it to update the original code, and this is the conversational aspect of Copilot. It already has the context for the application. Now we can just ask it to improve it a little bit. So I'm going to use this prompt to ask it to update the design of the buttons. We're going to ask it to have rounded corners that appear more modern and style it more like a Windows application. So we'll submit that query to Copilot, and it says, oh, well, let's go ahead and do that. So it's going to give us some more HTML here. You'll notice that it gave us a style block for our HTML. It also applied those styles within the HTML. Now, it gave me all of the code, so I can just click copy and replace everything that I needed that I pasted in. I'm not going to do that. I'm just going to select the new parts that I needed. I'm going to take all the HTML because it's all new and there's been some changes that Copilot made to that. So I'm going to select just the HTML portion of what it gave me, all the way down to the bottom before the code directive. And I'm going to copy that out. I'm going to go back into my task manager file, and I'm going to select all the HTML that I previously put in. I'm going to delete that and then paste in the new code that it gave me. Now notice it doesn't format it properly, but that's okay. It'll still run. So it doesn't look great, but it'll still run, and we don't have to worry about how it looks in the editor. So I stopped the original one that we had running, and I'm going to run this again. And once it completes building and running, I'm going to go back to my application and refresh. And you'll notice that it improved the look of the application a little bit. You can see that we have the add task button here that looks new, and then when we click on the add task button and we get a delete button, that also looks a little bit more modern. We have a couple of little updates to our application, and it looks a little bit better than it did before. Now there's a couple of other things that I want to do here. One thing I'll have it do is move the description and the add task buttons below each other so that it's not all in one row. And I want to do the same thing on the task. We'll go over to Copilot. So what I'm going to do is ask Copilot to update a couple of things. I'm going to ask it to move the description entry box below the task name box and the add button below both of those so that it looks a little bit more organized. I'm also asking it to remove the bullet from in front of the task list. When we have our task list up here, there's always a bullet just in front of it, and I want to remove that bullet so it looks a little cleaner. So we'll submit this query to Copilot. Here's what I'm asking it to do, and it provides me with more updated HTML that I can copy and paste into my application. Now just so it looks a little bit more formatted, I'm going to copy the entire code block, and I'm going to select all of my code, delete it, and then paste in what it gave me. Now a lot of times Copilot will not give you the entire code, so you have to be careful when you do a copy and paste, and make sure you're looking at what it provides back so that you're getting what you want. In this case, it's giving me all the code, including the code directive, so it's very safe to just copy and paste it out of Copilot and into my file. So I'll go ahead and stop my application again and then rerun it. Okay, now that's running, and it's still running in the same port number, 5161, so I can just go back here and refresh. And now it's done exactly what I've asked it to do. It's placed the task name and the task description in order from top to bottom, and then added the add tasks button below that. So I can now add my task. And it also removed the bullet from in front of that task list. So now it's looking a little bit better. Let's see what it looks like with 2 tasks. So there's still some more work that we can certainly do here to make our task manager look a little bit better, but using Copilot, we started out with no user interface, and then we slowly improved the interface by updating some of the features of that interface, and we can continue to refine our interface as we need to. So using Copilot, you can update your existing code, you can refine it, you can generate new code and add new features to the task manager. And using Copilot in this way makes it a powerful assistant for your software development. In addition to reducing the time it takes you to write applications, Copilot can also help reduce errors because the code that it gives you generally is a little bit more refined than what you might write on your own. Always check Copilot's code for bugs and test it thoroughly. And many times it's good to read what it provides before you actually put it into your code. Copilot can be a super big help when you're working on particularly new applications or trying to refine an existing application. Imagine you're developing an application and you begin to suspect that your code contains performance bottlenecks, but you're not quite sure how to identify them. Microsoft Copilot brings a significant advantage to your coding workflow. It makes it easier to identify inefficiencies and optimize your code for better performance. Microsoft Copilot brings a significant advantage to your coding workflow, making it easier to identify inefficiencies and optimize your code for better performance. In this video, we'll describe how to use Copilot to identify potential performance issues in Blazor code. I'm starting here with a simple task manager application in Blazor that enables a user to add, delete, and complete tasks. I've added a simple reporting section to the task manager so users can get a list of which tasks they've completed and which ones are open. You can see the task manager running here. I have Visual Studio Code, but this is the running version. And it just has a simple name and description, a button to add tasks. You can complete tasks by checking off the box, and then you can delete tasks as you need. In the Blazor application, I have a Razor file with HTML and Blazor directives in the file. The Blazor directive is down here with all the code that does all the work when you add, remove, or complete tasks. So that's all here in this file. I believe the code can be optimized for better performance, but I'm not really sure what areas to work on. So I'll use Copilot to guide me on what changes I can make to improve the code's performance. I'm going to go ahead and copy this entire file into Copilot before I prompt it. I have Copilot open here on my machine, and I'm going to open up a new conversation so that it has a clean context for my chat. And then I'm going to paste in the Razor file. I'm just going to give it the whole file so it has all the context that it needs to provide me with the information that I need. Then I'm going to prompt it by asking it how I can improve this code. So I'm just going to give it a very simple prompt, and now that it has the context for the file that I'm trying to improve, it can go ahead and give me recommendations with this very simple prompt. So I'll submit this to Copilot, and it tells me it looks pretty functional, but there's a few things that I can do. One of the things it tells me to do is use event callbacks instead of the on-click method that I have here. And it gives me the code that I can use to replace the code I have to improve the performance of the application. It gives me both the C# in the code directive as well as the HTML that I would use. It also tells me to use CSS isolation. So instead of using inline CSS, to create a CSS file that I could reference in my code to get better performance out of my application. There's a couple of other things here. Avoid repeated instantiation of tasks, which is a good recommendation, so I'm not continually creating that object. And then it says use dependency injection or DI for my services. So that also should improve performance. So I can take all of these recommendations, I can take some of them, I can try each of them in turn and just see what works and what doesn't. And I can take the code that Copilot provides and just copy it and paste it into my Blazor application. If something doesn't work the way that I want, I can prompt Copilot again and see what Copilot gives me back. Now with that context, I want to look at other areas of my file to see if I can improve those as well. I have a services file called task service that seems like it would be a good option for improvement. So I'm going to take this file now, copy everything out of this file. I'm going to go back to Copilot. I'm going to paste that file into the Copilot chat window. And now I'm going to say, prompt it for some other options so I can improve my service file. Give it this prompt and see what kind of response it gives me back. I'm giving it a little bit of information here. I'm telling that now that you can see from my original code that I pasted in earlier, I'm using a service layer. This is the service layer. and I'm asking it to analyze this code and to see how I can make it more efficient. So submit that prompt to Copilot. It gives me a little bit of feedback. It says the service layer is pretty clean and functional, but there's some things that I can do to improve the thread safety of the app. So make the tasks thread safe by using concurrent bag with a type property. This ensures that I can handle multiple tasks at the same time. I can optimize the delete task method, again, using kind of the same methodology here. And again, each time Copilot is giving me the code that I need that I can try in my app. It tells me how to improve the complete tasks method and then also how to use logging, again, with all these code samples that I can try. A fifth recommendation is to use asynchronous methods, always a good way to improve app performance. Asynchronous method allows multiple things to happen at the same time. So add tasks using async method, and then you can pull that through the rest of your code. I can try each of these. Again, it's always a good idea to look at the recommendations that Copilot is giving me to make sure these are the things that I want to improve my app with. And then I can try them all at the same time, or I can try them one by one and continue to converse with Copilot as I try them and tell Copilot how it works, or if it doesn't work, or if something introduces a bug, and then I can work with Copilot to improve all of these things. So by harnessing Microsoft Copilot's ability to highlight inefficient code patterns and recommend improvements, you can build better Blazor applications. Optimizing code isn't just about speed, but it's also about creating applications that deliver a better experience. Copilot can help you improve your apps to make them both better and more efficient. In a fast-paced development environment, identifying and fixing performance issues can help you create responsive applications. Imagine having a tool that not only spots inefficiencies, but also guides you towards optimized code. This enhances both speed and functionality without compromising your workflow. In this video, we'll demonstrate how to implement Copilot's optimization suggestions. We'll start with a simple task manager, which I have here on screen in Visual Studio Code. It's a Blazor application that enables a user to add, delete, and complete tasks. I've added a simple reporting section to the task manager so users can get a list of which tasks have been completed and which ones are open. I have the application running in my browser, and you can see it's just a very simple implementation with a very simple user interface. As you create tasks, it will add tasks to the list. You can also delete them and mark them as complete. Now, when I go to my code, inside the task manager razor file, .razor file, in the user interface code itself, I'm using a for each loop, which for this application works well. But as the task list grows, this can become very inefficient, and there's probably better ways to do it. I'm not quite sure what I want to do to improve this. So I'm going to use Copilot to help me come up with a more efficient way to improve this code. So I'm going to copy the entire file, the code from the entire file. I'm going to go to Copilot, which I have open here. I've started a new task, and I'm going to paste this entire file into Copilot so it has the context that it needs to improve my code. And then I'm going to give it a simple prompt that will ask it to provide me with a better version of this, a more efficient version. And I'm thinking about this application long term, because as people, add tasks, if I continue to develop this application and people add tasks, I want the application to be as efficient as possible. So I tell it what I'm writing, what I want to accomplish. And I also indicate that I have a report that shows the status of the completed tasks and what my concerns are. So I'm being very specific in this prompt to let it know what I want it to be able to do here. I also explain that I have a directive, a Blazor directive in this file. I'm using it to make changes to the tasks. I am very specific about the fact that I want to just update the reporting code, and my goal is to make it more efficient. So I'm giving Copilot all of this context, so it gives me a very targeted fix in this case. I'm not asking it to look at the entire file and improve the entire file. I'm asking it just to focus on this one task. So I'll submit the prompt with the code to Copilot, and it says I can leverage Blazor's @key directive and an observable collection to keep the task list updated efficiently. And then it explains why this works. The description is that using @key helps Blazor tracks elements in the list and optimizes the rendering. So I can look at this code now and evaluate it and see if this is the way that I want to improve it. If I go down to the list where I'm actually doing the reporting, you can see the @key item here, that it is included and how this is different from my existing code. So if I want to, I can take this code. It's still giving me a for each loop. It didn't modify that. So I can copy this for each loop out, and I can go back to my code. Notice I'm just taking this one section out. I can go back to my code and I can put that block here in my code. And now I can use this to improve my original code. Now notice that it gives me a little squiggly line here, which means there's an error. So I'm going to go back, I'm going to undo what I did here. And notice that my code has task services.getTask, and Copilot's code just had tasks. So I need to go back and look at Copilot and see if I missed something when I was implementing this service. Now, if I look at my code directive, the implementation that Copilot gave me may be different than the implementation that I used, and it looks like it is. So I'm going to go back to Copilot, just take out the code directive block and paste that in. Now, if this doesn't work, if I still get problems, if I still get bugs, I can go back and just copy the entire block out and paste that in, because Copilot gave me the entire file. What I'm trying to do here is just be very targeted in what I replace. The less I have to replace, the less problems that can be introduced. So I'm going to just try to replace just parts of this file. Now you'll notice when I did that, I replaced the code directive, the squigglies went away, which means that the file was assuming, this user interface was assuming that that code directive was constructed a certain way. So I had to include that section in order for the application to no longer produce errors. Now with this code, I've made a slight improvement that will help my code to run in a more optimized way as the application grows. And I can do this with each file in my application. I can go through and ask it to do the same analysis for certain sections of task service if I think there's something that needs work there. I can even look at my model and ask for ways to improve or optimize my model as I continue to grow the app and improve the app. So you can use Copilot in a variety of ways to help improve the efficiency and the performance of your app. You can do it by asking it to analyze entire code blocks. You can do it by asking it to analyze specific functions. And each time you provide Copilot with more context, the better it can get at analyzing and improving your code. The nice thing about tools like Copilot is that it's conversational. So if you get code back that doesn't work well, if Copilot happens to introduce a bug for some reason because it didn't have enough context, you can continue to dialogue with it and work with Copilot to help you improve your code. Imagine you're building a powerful application with your team. It's fast at first, but as the code base grows, maintaining performance becomes challenging. Without ongoing monitoring, even the best systems can slow down. In this video, we'll describe the role of Copilot in ongoing performance monitoring. First, let's explore why performance tends to degrade over time and how Copilot can help. As a code base grows and more developers join a project, the chances of performance degradation increases. Minor updates or feature additions may inadvertently create inefficiencies. Copilot can help catch areas where code additions or modifications create performance bottlenecks. Copilot can play a significant role in catching potential performance risks early on. As developers work, they can use Copilot to analyze code patterns and suggest optimizations. Each code update receives checks and suggestions by integrating Copilot into the development process. Copilot's recommendations make iterative optimization practical in daily coding. Next, let's examine how Copilot integrates this concept into coding workflows. Developers can use Copilot to provide real-time feedback on inefficiencies by analyzing code as it's written, allowing developers to address potential performance issues immediately. When complex code patterns emerge, developers can use Copilot to suggest streamlined alternatives, effectively simplifying complex code patterns. This proactive assistance helps developers avoid performance bottlenecks by guiding them towards efficient solutions as they code, keeping applications running smoothly without requiring major refactoring later. Copilot's code suggestions support coding best practices. By integrating Copilot into your coding workflow early, your code will be cleaner and more aligned to common coding practices. Next, let's examine how you can make Copilot part of your development lifecycle from the very beginning. To make Copilot effective, it's important to integrate it early into the development lifecycle. Using Copilot in code reviews helps establish a performance-first approach, catching potential slowdowns before they accumulate in the code base. This proactive approach reduces technical debt over time and makes optimization a habit from the beginning of a coding project. Organizations can create a framework around how Copilot should be used, such as policies on when to apply Copilot suggestions, common performance issues to watch for, and regular reviews of Copilot's feedback. By formalizing these practices, development teams ensure that performance remains a top priority throughout the project lifecycle. As projects grow, an organization can rely on Copilot to review every feature update. As the project approaches the deployment phase, Copilot can detect potential issues across the code base. This helps the team improve overall performance. It enables the team to make targeted improvements before deployment. This prevents the company from needing to make time-consuming optimizations after the code is released. It also means the user gets a faster and more efficient application. By making Copilot a partner in performance monitoring, development teams can keep applications optimized over time. Integrating Copilot into the development lifecycle fosters a culture of proactive, iterative optimization so that code remains efficient as it scales. Planning a project can often feel like a daunting task, especially when you're working with a powerful framework like Blazor. But with a tool like Microsoft Copilot, turning your ideas into reality has never been easier or more efficient. In this video, we'll explain how to plan and set up a Blazor project using Microsoft Copilot. Let's suppose we want to develop a web app that will enable users to store information about their vinyl record collection. Step one in planning any project is to define the requirements. Let's break that down with the help of Copilot. I have Copilot open on my computer and I have a new task started, so it has no context. I haven't told it anything about my project yet. But I'm going to prompt it by helping me define the project requirements. I'm going to describe a little bit about the project that I'm trying to accomplish and the direction I want to take with this. So I'm telling it that it's a vinyl record collection manager. I'm telling it I'm building with Blazor. That's important. It needs to know what type of platform or framework that you want to use. And I want to start out by keeping it simple. I don't want to use a database or any API calls. It should just be stored on the user's computer and the data should be stored in JSON format. So with those parameters, it helps me begin to formulate my plan for this project without making it too complicated. Obviously down the road, if I want to use APIs or use a database, I can add those as new requirements and ask Copilot for help even in implementing those. But we're going to start out simple. And I'll submit that prompt to Copilot. It's going to tell me to lay out some basic requirements. So it gives me categories. User interface and data management are two, obviously very important ones for data management application. It gives me some features to look for, like search and sorting, some options to mark certain records as favorites, and then some basic validation. Now, it also talks about what it calls non-functional requirements. These are not a part of the way the user will interact with the app, but it's more about the app itself. So things like performance, usability, and maintainability are requirements I should consider at the beginning of the project, even though they may not directly impact the user interface. And then it gives me specific technical requirements. So it tells me, it knows that it's a Blazor app because I told it that's what I wanted to build. So it tells me what type of Blazor setup I need, how to work with local storage. It tells me that Blazor has the ability to manage JSON files, and it gives me an example structure of what the JSON file might look like as I start to add records. So then it prompts me. It says, do you want any other features or details? And I can give it some more information. So I'm not quite ready to get started, right? I want to continue to interact with it. So I'm going to prompt it to give me a little bit more information and just to make sure I haven't missed anything. So I'm going to ask it to give me some other features that the record collection app might include. Now I do this because I might want to consider things down in the future. I might not want to implement these right away, but I want to think ahead. So as I'm building my app, what could the app look like down the road? I have some ideas in my head, but Copilot can help me remember things that I may have forgotten, or come up with new ideas that I've never thought of before. For example, a wish list might not be top of mind for a new record management application, but that's a good idea and maybe something that I want to think about later. It gives me a lot of features here, some other things that I can consider, some enhanced user experience options like drag and drop, make sure my app is responsive in case I want to use it on mobile, and even something like voice commands, which is not something I would do immediately, but something I might want to consider down the road. So I'm not going to ask it to give me the requirements for each of these. These are just ideas for features that I might want to include as I develop my app. Now, to create a foundation for the app that I want to build, I'm going to ask it to ask Copilot to give me a folder structure for the files in my app. I want to make sure that I'm setting up my Blazor project properly. So I'm going to just see what Copilot gives me when I think about this WebAssembly project and what the folder structure should look like as I prepare my project. So it's going to give me some feedback here. And it actually gives me a diagrammatic representation of a folder structure that I can put into Visual Studio. I have a www root folder, a data folder, which is where I would store the data for the application. The pages is where all my user interface pages will go, and then a shared folder for some utility functions. Notice it's giving me two www root folders, so that's an error on Copilot's part, or that's something we can ask about. Why are there two www root folders? We can interact with it there. Let's see if it described this. So it did have the two in its description. This www root folder contains static files like CSS images and JavaScript, and these contain static images accessible by the client. So this is an interesting structure, and we can converse with Copilot about that structure. And if we have a structure in mind, we can ask Copilot about our structure and the ideas that we had there. Now that we have a structure for our project, let's consider how we'll develop the application. I'm going to ask Copilot to help us map the workflow so getting started will be easier. It's really important at the beginning to outline the steps that you're going to need to take to create an application in Blazor. And I want to make sure that I'm not going to miss anything as I get started. So Copilot now has the context for my app. It has a general direction of what I want to accomplish, and it's actually given me some recommendations on how to proceed. So now I'm going to ask it for that roadmap. Again, this is all project planning, so I want to make sure I've got everything in front of me before I begin. So I'm asking it to create a roadmap for the specific development steps that I'll need in order to build this application in Blazor. So it gives me a nice numbered and phased-based approach to developing this roadmap. It tells me the things that I'm going to want to do in terms of the actual development effort. I'll initialize the project, create the models and services. I'll start to work on the user interface. So it's having me create the services first and then the user interface next. And then phase 3 is about managing the data. So once I have the user interface and users can add and manage records in that tool, how do we manage the data behind the scenes? And then phase 4 is where you start to add any of those other features that it suggested, favorites, search, and sort functionality. Phase 5 is about enhancements. So as you go through the development process, once you've got the main features in place, then you want to start to enhance those features, make them better in terms of how they work with the user. Data management can be improved, make sure you're adding validation, things like that. Then we go into the testing phase where we've got all the code implemented. Now we're going to look for and find bugs. Then we go into the testing and deployment phase. So we do all the testing, we make sure the app works, and then we deploy it to our user base. And we get the users interacting with the application. The users may find bugs, and so then we go into maintenance and updates. So once the product is out there, once the application is out there, then we can go into a maintenance mode. But you'll notice that Copilot gave me a nice approach here and a very clean way to think about how to develop this project. And once I have this map in front of me, I can then use Copilot to help me go into the details. So I might prompt it next for how do I initialize my project? Tell me the specific steps I need to initialize my project. What code do I need to create my models, right? I'll have all this context and you can continue to interact with it to build out those specific steps. Now we're almost ready to get started, but there's one other thing I want to prompt Copilot for, and that's about the development environment. I want to know what tools I want to make sure I have on hand for this specific app. If I've been developing for a while, I may have a development environment all set up, but I'm going to ask Copilot just to make sure I've got everything that I need. Now that it knows the context of what I want to build and it's giving me specific steps on how to approach it, it's going to use that context to make sure that I have everything in place in terms of my development environment so that I can build what it's essentially recommended for me to build. I'm going to prompt it with that simple prompt about the development environment, and it's given me this response. So again, a very detailed response about what I'm going to need, and it even goes down to the operating system level. You're going to need a major operating system like Windows, Mac OS, or Linux. The .NET SDK needs to be installed, and it gives me a link so that I can go in to that link directly and install the .NET SDK. It tells me what tools I can use in terms of a development environment in order to make my development easier. I'm going to need a browser to do some testing, and then it gives me some optional tools like Git and Node.js and NPM, which I can use as a web server and then version manager. It then walks me through each of the setup steps. So if I don't have the .NET SDK installed, I would install that first. I would make sure I have my IDE set up. It gives me the actual command that I can use in Visual Studio or Visual Studio Code to start the .NET project by creating a new Blazor WSIM project. I open up that project and I can test the basic app. Once the basic app is running and ready to go, then I can start adding my specific code. It's very robust in terms of how it walks you through the specific steps to get my project started. With these in place, now we're ready to start our project using the guidance that Copilot suggested. We can continue to use Copilot throughout the process. We can refine our requirements. We can get help with setup. We can even ask Copilot to help us write and review code. Planning for a project is key to making the project successful. And by using Copilot, you can make sure you have everything prepared and everything in place so that your project will go smoothly. Imagine waiting for an app to load or respond. It's frustrating, isn't it? We can enhance Blazor app performance by identifying key performance factors, applying optimization techniques, and monitoring performance. In this video, we'll explain how to monitor and analyze the performance of a Blazor application. We're going to begin by creating a new Blazor WebAssembly project, and this will serve as the foundation for implementing performance optimizations. I have my Visual Studio Code environment opened up with a terminal available, and I'm going to create a new Blazor application. I'm just going to call it Blazor Perf App, and I'm using the Blazor WASM template to do this. Okay, it's created the application, so now I'm going to switch to that folder and then open this up in a separate Visual Studio Code window. Okay, I have my application open. I'm going to open a terminal, and we're going to run this really quickly just to make sure everything's operating properly from the template. It's going to have all the template code, but we just want to make sure the application runs. Okay, the application ran without errors. We're going to quickly just test by going to the location in our browser. And we see we get our Hello World application. This is just all based on the template, and it all seems to be working fine. Okay, so we have our application running. We'll go back to our Visual Studio Code environment. I'm going to stop the application, and now we can start editing. When we think about Blazor performance, it really depends on factors like load time, the network latency that you'll have when you're operating over the internet, the size of the application, and how the application utilizes resources. So if we address these things, we can make sure that our app runs smoother and it's faster for the user. We're going to start by adding a component for testing performance. We're going to call this a hybrid component. In Blazor, hybrid rendering allows the server and the client to work better together. So the application will actually run like a single page application where the user doesn't have to keep reloading the page or going to different pages to do work. It all happens on the same page. So we're going to kind of simulate that using this, this hybrid component approach. So in our app, I have the home page here, the home.razor. It's just a simple page based on the template. And I'm going to add a couple of things here to make sure that I can load data and then test for a specific environment when I'm doing that. Before I add the hybrid component to the home.razor page, I'm going to create a new component called hybridcomponent.razor, and I'm just going to put that in the pages folder. In a real world application, you may want to structure this a little bit differently, but I'm going to create a new page called hybridcomponent.razor. And this component will have a bunch of code that will simulate this hybrid environment. Paste that in, and then I'll explain what it looks like when it's in the file. This code is, it has a title hybrid rendering component. It checks to see if data is loaded, if we have the data value full. If not, if it's null, it just gives us a loading message. Otherwise, it goes through each item in the data object, and then it prints it out as a bullet list. Now we also have a code component here, and this is going to create a list data object, and then it's going to use an async task to run when the application is initialized. It does some logging here, which we haven't really implemented yet, but you can see how it will log. And then we have some test data. So we're pre-populating the data object with 3 items of test data: test data 1, test data 2, test data 3. And then again, it logs some information when it's completed. So this is our hybrid component. Now we can inject this component into our home.razor file with a simple line of code. And I'm going to add some things here. So I'm going to change the title, and so I'm going to change the home.razor file a little bit. And I'm going to just simply inject our hybrid component where it says hello world, this right here. And that's just going to inject our hybrid component into our app. Now what this is doing is, instead of having to write all the code in our home.razor file, it's pulling in the code from the hybrid component, and this is going to do all the work for us. This is going to create that visual that we want to see in our application. So now we have a reference to the hybrid component, and that can be served from the server side, or it all can be done on the client side. But in this environment, we just simply have the hybrid component as a file in our file tree, and then we're going to pull that in when Blazor loads. Okay, now that we have our hybrid component in our home page, what we should see is a list of those items that we listed in hybrid component here. Test data 1, test data 2, test data 3 as a bulleted list when we rerun our program. So I'm going to rerun. It's running without errors. So I'm going to refresh the page. And remember, we put that hybrid component in our home page. So there we have it. We have test data 1, test data 2, test data 3. And remember, that hybrid component is coming in as a reference on the home page. So we can actually do all the work in the component, add it to our home page, and then it shows up here. Let's try to simulate some performance options. There's a concept called lazy loading, which loads data as the page shows up on the screen, as the user scrolls, for example. In a real-world scenario, lazy loading would only pull data in from the server as the page is visible. It's called a viewport. The part that you can see in your browser is called a viewport. And as the viewport shows, the data loads in real time. For really long pages where there's a lot of data, that prevents all the data from having to load before the user can see anything. So lazy loading is a very important concept. We're going to simulate that in our app by adding a button to our home page that will load data when I click the button. It won't pull the data in real time. It'll load it as we need it. So I'm going to add a button to our page that will allow us to simulate lazy loading. So I'm going to modify our home page fairly substantially. I'm going to change the title. I'm going to give it a header, and then I'm going to add some code that will simulate that lazy loading approach. Put this into our application. And again, this is on home.razor. In this new code, I've added a header, which we'll see. And then I'm adding an if statement. If the data is loaded, then load the hybrid component. So we shouldn't see the hybrid component when we first load the page. Otherwise, if the data is not loaded, then it's going to show a button that asks to load the data. And again, this is simulating lazy loading. So if hybrid component had a lot of data in it, the user wouldn't have to wait to see anything before that data is loaded. The data would load automatically. Now, in the real world scenario, we probably wouldn't use a button, but for this screencast, we're using the button to simulate that lazy loading. And all the lazy loading button is doing is just setting the is data loaded to true. What we would do in a real world example is check to see that the data has downloaded from the server. Once that completes, once that event completes, then it would show the hybrid component because now we have all the data. But at least the user would be able to see something happening. We could also add a wait message or whatever we need to do there. So I'm going to stop my application and rerun it. And then we'll go back to our home page and refresh. Now when the page first loads, the is data loaded is false. So we get to see our welcome to our Blazor performance app. Now here we might show a spinning dialog or something that says that the data is loading. We're going to click our load data to load that rendering component. And now we've got our hybrid component that's been pulled in from the server with all of our data in it. And that's an example of how lazy loading could work. Now I'm going to switch back to the code and look at the logging that we added to our hybrid component. You'll notice here that we have some logging information, and what this will do is actually write to a specific area of the browser that developers can use to track what's happening in the application. You'll see I've added a reference to the iLogger component, and it's essentially creating a log instance so that we can use that logging instance to write information to the browser. There's two things happening here. So when the logging starts, it tells us that it's fetching the data when the application loads. And then we assign our data object to the 3 data items that we've provided. And then we say once that's done, we log another item to the console that says that the data fetch has been completed. In a real world scenario, if this were a very large data set coming from a server or coming from an API, it might take some time for that data to load. So we can learn in our console that the process has started loading. And then once it's completed, we can see in our console that the data fetch has been completed. So we've already implemented this, and so it should be in our browser already. So I'm going to go back to our application, and I'm going to use developer tools in Microsoft Edge. These are under More Tools, Developer Tools. And you can see I get this little interface here, and there's an interface called Console, which is where the logger writes the messages. Now remember when we loaded this, we loaded it from the application and then I refreshed the page. And when I refreshed the page, those messages that we saw that we were writing to the logger will write to this console. It's a little bit hidden, but it's useful for developers. So you'll see that we have our log messages here. There's the fetching data and there's the data fetch completed. Now you can imagine in a real world scenario, if you were loading a large amount of data, you can pull up this tool as the application is running, and we can display the fetching data message. When that data has been loaded, it will show the data fetch completed. You won't be able to see it because it happens so fast on this local app, but I'm going to refresh the page and you can see those messages appear. Now you don't see the messages yet because we haven't loaded the data. I'll click the button and it happens instantaneously. So since we're talking about managing and optimizing performance in a Blazor app, I'm going to add actually a little delay to this code to simulate data downloading and taking time to download. So I'm going to add a simple delay in between the 2 logging messages. This is about 2 seconds. I'm going to actually make it 4 seconds so it looks a little bit longer. This would simulate pulling data from a server or an operation that might take a little bit of time. Rerun our project. Okay, it's running. I'm going to refresh the page. We don't see our messages yet because we have to load the data. Now we're going to simulate that data loading. And when we do that, you should see the first message that tells us that the data is loading. And after about 4 seconds, we'll see the second message. So you can see it's fetching the data. The delay is happening, and now the data fetch is completed. And that's a good way to watch for performance. So if data is taking a long time to load, or if there's an error, you can catch that between those 2 messages, and you can use logging to improve how your application is performing. So these simple operations in a Blazor app helps us to manage performance, and it can help us implement tools that make us better at figuring out where performance bottlenecks are and how we can improve them. Developing a great application involves more than just getting it to work. It's also about creating a smooth user experience and writing efficient code. With Copilot as our pair programmer, we can improve our Blazor applications to make them more user-friendly and more efficient. In this video, we'll describe how to use Copilot for testing, debugging, and refining a project. I have a small record album manager application here, and I'm going to start by improving how our record list displays information. Currently, it's just an unordered list, but we can make it more visually appealing using Copilot. You can see here I have the application running, and this is what it looks like. It's just a simple form, and once you've added record albums to the manager, it will just display the records below. But we can improve that by making it a little bit more efficient. So I'm going to go back to my code, and I'm going to copy out my record list display. I want it to display the records in like a table format because I think that will be a little bit more interesting. So I'm going to go to Copilot, and I've got a chat started here, and I'm going to ask it to enhance the code. So I simply said I just want to enhance this code to display the records in a table format, and I paste the code that I want it to change in my prompt. So I'm going to go ahead and send that to Copilot. So it just gives me a revised version of that code, and this should present the records in a table format. I'm going to copy that out of Copilot and paste it into my record list.razor file. And I'm just copying out the whole code block as I update this item. I can copy sections of the code, but I've chosen to just copy the whole thing because it's simple and there's not much going on there. So I'm going to stop and restart my application. So I get a few warning messages here. We're going to ignore those for now because they're not blocking us from testing the application. Later on we can go back and fix those if we want to. I'm going to go back to my app, and since it's using the same port number, I'm just going to refresh the page. And I'm going to add an album. Now you notice this data is not persisting because we're just using in-memory storage. In a real application, we might save this out to JSON just so that we can persist from session to session. And when I save that, so it does put it in a table format. You can see that it's got a column, album name, and release year. That doesn't look very good. It doesn't show it in a way that's appealing. So I'm going to go back to Copilot and ask it to enhance this even further. So I just asked it to make the table more visually appealing by adding headers and some styling to the table. So again, we'll copy that out. I'm going to go back to my code, paste that in. We'll rerun the project. Copy this out so that I don't have to retype it. And refresh the page. And now we can see we're getting a little bit closer here. We know we have a header and we have some styling. So we'll go ahead and we'll save the record again. And now we can see it looks a little bit better. And we can continue to refine and improve that if we wanted to, just to make the table more visually appealing. We could also add the other fields like the description if we wanted to, and even include the cover art as we add that data. I'm going to go ahead and add a second album. I'm just going to use a dummy name here. And we can see how it also just continues to add those records and looks pretty stylish. I'm going to go back to my code, and I want to continue to improve this application. And I'm going to use a different approach here. So we're using a for each loop in our record list .razor file. So the for each loop will go through all the records that are in memory in the records object and produce the table based on that. But there's a Blazor component called virtualize, which we can use in this instance to improve performance. For a small app like this, when we're adding just a couple of records, it's not going to matter. But as you add more information, it might slow things down. So we're going to use a virtualized component, which is native to Blazor and will help improve performance. So I'm going to ask Copilot to help me improve this component by using that keyword virtualize in my prompt. So let's go ahead and see what Copilot gives us back. You'll notice that it does say that utilizing the virtualized component can enhance the performance of the record list. and only render those records that are visible in the viewport. So this means that as the list gets longer, it will slowly build out the list to accommodate what the user can see in the viewport, which is the area of the screen in the browser that you can actually see. So it's provided me with this code, and you can see now it has this virtualized keyword in here, which will load the records based on the size, and then that will build out as you add records to the list. So I'm going to copy this out, and again I'm just going to paste it into my entire file. Sometimes you want to do this, sometimes you want to do it in components, but since the file is so small and the code is fairly modest, we're just going to paste in the whole thing. We see some issues here. It may not build, so we'll take a look and see if we've missed something as we work through this, but I'm going to go ahead and try to run it as it is and just see if it works with the code that Copilot gave us. So let's restart this. You'll notice that it introduced a bug. So it's telling me that something's not quite right, and we'll look this over and see what's happening here. It looks like we have a dependency where something is not added properly. So now I'm going to use Copilot to help me debug this. I'm going to actually copy and paste this error out of my application and use Copilot to help me fix it. I'll go back to Copilot and I can say, so what I've done is just give it a simple prompt and saying I'm getting an error and asking it to help me debug the code. Let's see what Copilot returns and how we can fix it. So it's giving me an explanation of what it believes the problem to be, and it says it can be resolved by explicitly specifying the type arguments for the virtualized component. So it's giving me a new code block, and I'm going to go ahead and copy that out and paste that in, and we'll see if this fixes the problem. Now notice a lot of the squigglies went away, which are errors in the code. So we'll see if that actually solved the problem. Let's go ahead and try to run this again. Well, we still have a problem. We're getting some issue now with an invalid expression. So I can, again, use Copilot to help me fix this. And I'm going to copy that out. And now I'm just going to paste in the error message because Copilot has some context. So I don't need to explain that I have an error, and it's telling me that there's an issue with the code that it provided. So it's seeing it as an invalid expression. So it provides me with a new code block, and I'm going to copy that out again and paste it in. And we'll see if we can get this to run. We're getting less issues with the code, but that doesn't mean it's going to run properly. So let's give it a try. Okay, we're going to run this again and see if we can get this to work. Okay, it looks promising. We don't have any warnings or issues. So we're going to go back to our application and just make sure it works again. I'll refresh the page, and I'll add an album and give it a release year of 1973, and we'll see what happens. Okay, I'm going to try to start this application again and rerun it using the virtualize. Okay, now that we have the virtualization code, I worked with Copilot to get the virtualization code where it needs to be. I'm going to try to rerun this application and see if we can get it to run properly. You may have to go back and forth with Copilot as you're working with it to get the code to work. That's the nice thing about conversational AI, is that you can continue to refine your code and improve it and make it better. So I'm going to refresh the page. Add a couple of records. Okay, so the code is working fine. We're not going to see the result of that virtualize component until you get a lot of records and you have to scroll, but the virtualize code works, and we've implemented it into our code using Copilot. Now you'll notice here I can add a new record, a new album without a release year. So it might be helpful to include some validation in our code. So let's do that next. We'll use Copilot to add some validation items to our records. So I'm going to take the model that we have, this records model, and I'm going to copy this out, and I'm going to ask Copilot to provide some validation for this. All right, so I pasted in my my model, and I'm just asked it to add validation to each item. based on the name of the item and what it thinks the best validation would be for those. So let's see what it gives us back. It's going to add common data annotations. So you'll see here that it's adding a required for the release year and the album name. And it's going to add a length for the description. It's also going to give us a range for the release year. So we have to add a release year and it has to be between a certain range. So this looks pretty good. We can obviously tweak that if we needed to, but I'm going to go ahead and copy that out and paste that into my code. And so now we have some validation added to the code. Let's go back and look at it before validation. So again, if I don't have an album name or a description, I can continue to add records with no values. So now we'll stop our program and rerun it, and then we'll see how that works. Let's go back to the browser, we'll refresh. Okay, so I just click save without adding anything in here, and you can see it's giving me some feedback. I need to add an album name, and the release year needs to be between 1900 and 2100. So let's add an album name, and I'm going to add a release year of 1980. You'll notice those validation items go away. I can still add something without a description because we didn't make that required, but now it gives me some validation so that I can only add records that have at least these fields filled in properly. So using Copilot, you can do a number of things to improve your code. We implemented real-time validation, we added some visual feedback, we improved our list display, and we optimized performance as well as debugging common problems. And we did this all using Copilot. Copilot is a very helpful pair programmer to help you improve the way that your code operates and performs.
A strong understanding of Blazor's core concepts and techniques is essential for building modern web applications. Mastering these tools, from component creation and data binding to rendering strategies and performance optimization, will significantly improve your ability to develop dynamic, efficient Blazor projects easily. We began by introducing the core concepts of Blazor, guiding you through creating and configuring Blazor projects. You also explored how to run and debug your applications effectively, establishing a solid foundation for your development journey. After that, we discovered Blazor components, focusing on their lifecycle methods and communication processes. You learned how to create reusable components and applied advanced techniques for building dynamic user interfaces. Next, you explored data binding, event handling, and navigation techniques in Blazor, key elements for building interactive applications. You also examined state management and best practices for handling forms and validation. Then, you examined server-side and client-side rendering in Blazor, discovering when each approach is most effective. You also investigated hybrid rendering models and focused on critical strategies for optimizing application performance. Finally, you utilized Microsoft Copilot to aid in developing Blazor projects. You applied Copilot to write, debug, and optimize Blazor code, completing a well-optimized, efficient project. As you have discovered, understanding Blazor's core concepts and techniques is essential for building modern web applications. Mastering components, data binding, and performance optimization helps you create efficient Blazor projects and equips you with valuable skills to tackle more complex web development challenges and scale your applications effectively. Congratulations on your completion of Blazor pages for front-end development.